Hello everybody, and welcome to the Expert.js JavaScript course. My name's Abrar, and I'm your instructor and guide for this course. And in this video, I want to take a moment to thank you, to congratulate you, to welcome you aboard, and to introduce you to this course. So let's get started. Now before we start, I want to give a big thanks to you for getting started on this course. That is a big accomplishment on its own, so congrats for that. I'm actually really excited to have you on board for this course. It'll be an amazing experience learning JavaScript together, and I can't wait to get started. So without further ado, let me start by introducing myself first. My name's Abrar Arik, and I'll be your guide and instructor for this course. I'll walk you through all the videos and lessons and help you learn JavaScript on the way. Now, I always actually had a keen interest in technology. I had always been fascinated by technology and gadgets. I was always amazed by computers, the internet, hardware, software, and all that kind of stuff. And this strong interest also made me very curious about technology. I wanted to learn how technology works. I wanted to learn how computers work and how the internet works. So while most people are happy just surfing the web, checking emails, spending time on social media, and downloading apps on their phones, I wanted to learn how these things work. I wasn't just happy surfing the web, I wanted to know how the web works, how the internet works, and how do you develop and create websites. How do you develop and create web applications and mobile apps? I wanted to learn all these things, and I always had an interest in these subjects. And this is what got me started in the world of programming. I started to learn code when I was around 12 years old. And at that time, I focused mostly on web technologies and web development, basically learning how to create and develop websites and web applications. And after learning the basics of HTML and CSS, I came across JavaScript. And JavaScript was actually my first programming language, and I loved it. Well, actually it wasn't that simple. You see, when I was learning JavaScript, I had a simple tutorial that I was following. However, that tutorial wasn't very detailed, and that's why at first I didn't understand anything. That's right, I was going through the tutorials, I was reading everything, I was trying out the code examples, but things were not working. I didn't understand even a bit of what's actually going on. I really had a hard time wrapping my head around JavaScript at first. And I was a bit surprised, because I didn't have any problem learning HTML or CSS. The problem started with JavaScript. I just couldn't understand the programming language even a bit, and that was quite frustrating. But I kept at it. I went through the tutorials again and again, I revisited them from time to time, and I practiced the code and tried to understand it as much as possible. And finally, it all clicked inside my head. Suddenly, I started to understand everything, and once I got the fundamentals down, it was a lot easier to go on from there and pick up the more advanced topics. I started working on personal projects where I could practice JavaScript, so I started building and developing websites and web applications on my own, practicing and improving my programming skills in the process. And eventually I started working on real-world projects as well, where I started using JavaScript for real-world applications. And with all the practice, real-world experience, patience, and some hard work, I finally understood how amazing and powerful JavaScript actually is, and I've loved it ever since. I learned a lot of other programming languages afterwards, including Ruby, Python, amongst a lot others, but JavaScript always had a special place in my heart. Because it was the first programming language I learned, it always felt special to me. And after going through this experience, I realized something. See, if you're a beginner in the world of programming, there are a lot of resources out there which will help you learn a specific programming language. These resources are mainly geared towards beginners, where you have video lessons, presentations, and a lot of other easy to understand and easy to digest content. And because these are geared towards beginners, these are relatively easy to understand. So even a beginner who doesn't know anything about programming can actually pick up these courses and tutorials, go through them, and learn the basics of the language. However, things get complicated when you want to move on from the basic levels of the language, because learning the basics of the language is often not enough. Preferably, you would want to become an advanced level developer in any specific language, because that's when your skills will really shine. However, the advanced level content for most programming languages are not that easy. They're not the same beginner friendly. Often you'd have to go through books with hundreds of pages or go through boring documentation in order to understand the more complex topics of a specific programming language. And that is not very fun, because I actually believe education and learning can be fun. It can be exciting. It doesn't have to be boring or hard. And that's the reason I created this course. My goal with Expert.js was to create a course that would help people learn JavaScript from beginner to advanced levels. So on one hand, that course would need to be very beginner friendly and easy to understand. So simple and easy that even someone with no experience in programming can pick up the course and start learning. However, unlike most of these types of courses, it shouldn't stop at just beginner level content. It would actually start tackling the more advanced topics and concepts of a programming language while maintaining the same beginner friendly aspect of it. So I wanted to boil down even the most complex and complicated topics about JavaScript into simple, easy to understand, and very beginner friendly lessons. And that's why I strived and tried to make Expert.js as valuable and helpful as possible. Okay, so now let's talk about what exactly is Expert.js. We know this is a course about JavaScript, but what's the specific definition of this course? Well, Expert.js is a JavaScript course designed to help you learn the core JavaScript programming language along with client-side browser APIs for a full understanding of both the theoretical and practical uses of the JavaScript programming language for front-end web applications. That's the definition of this course in a single sentence. Expert.js focuses on two topics, the core JavaScript programming language and the client-side browser APIs. And throughout this course, we will go through these two topics and help you develop a full understanding of both the theoretical and practical uses of JavaScript. Now that's the very important thing, because a lot of courses are mainly just teaching the JavaScript fundamentals, the theoretical aspects, mainly the JavaScript syntax and the programming language itself. But that's not enough. There's a lot to learn and understand in the practical side of things as well. For example, in order to become a skilled programmer or developer, you not only need to understand the language itself, but also how to use it practically in real-life examples. You need to know how a programmer works and thinks, and how you can think creatively to find solutions to problems and implement those as JavaScript code. Knowing and understanding the practical side is equally important as the theoretical side, and that's why this course focuses on both these sides, and it'll help you learn and understand JavaScript so that you can go ahead and build front-end web applications yourself. And that is the goal of this course. Now let's talk about the design and structure of this course. This full course is divided into separate modules. So if you look at the course curriculum, you'll see that we have a lot of different sections or modules. Each of these modules focuses on a certain area of JavaScript, and we start with the easy concepts and gradually start tackling the more advanced topics. So the first few modules are very easy. They're beginner fundamental level stuff. But as we go through this course, the modules focus more and more on intermediate and advanced level topics. And this is a very efficient way of learning JavaScript, because if you have the easy and fundamental concepts down first, it's a lot easier to build upon that knowledge and start learning the more advanced features. Now each module contains one or more video lessons, and that video lesson describes and explains the topic along with code examples. Now videos are the main content of this course, so each module contains at least one video that explains and describes the topic. And by watching these videos, you'll get a clear understanding of the specific topic we're trying to understand. And these video lessons also have code examples. Just like a picture is worth 1,000 words, a code example can explain a topic much simpler, much easier, and much faster compared to without one. And that's why code examples are a big part of this course. Now we also have some coding sessions, and these coding sessions show how to write code and create JavaScript applications in real life, along with practical examples. Now this is where we focus on practical side of things. In these coding sessions, we will actually open up our code editor and start writing some code for real. And these videos are very fun, interesting, and valuable, because they'll show you and help you learn how a real JavaScript application is created and how a programmer actually works in real life. And finally, we have quizzes, and these quizzes test the understanding of the module with quick and simple multiple choice questions. So after you finish up a lesson, you can take a simple quiz to evaluate how much you've learned. By taking the quizzes, you can evaluate your understanding of the lesson and determine if you're ready to jump on to the next module yet. Now before we actually get started on the course, here are a few tips on how to learn JavaScript so you have a better overall experience. First of all, start from the beginning. Remember that in this course, the modules and even the individual lessons are carefully designed and ordered in a specific sequence, and that sequence is designed to help you start from the beginner level and move on to more intermediate and advanced topics. Almost every module builds upon the previous one, so it's a very good idea to start from the beginning, because if you skip some of the lessons or modules, you might miss those content and not understand the more advanced topics. So after starting from the beginning, first watch the videos. The videos are the main content of this course, and they will help you understand the topic in as much detail as possible. So watch those videos carefully. And try out the code yourself. So when you see a code example in a video or anywhere else, try it out yourself. Actually write the code and execute it, and that will help you understand and even memorize all the different aspects of the language. And take the quizzes. The quizzes are quick and simple, and you can take them to evaluate and understand how much you've learned about a specific lesson. And also go through the coding sessions, because they focus on the practical side of things, and that practical side is often very important for a programmer. So understanding and knowing how to use the JavaScript language is actually very valuable. Practice, practice, and even more practice. Now remember, if you're a beginner, at first you might not understand anything. You might be watching the videos, trying out the code yourself, taking the quizzes and going through the coding sessions, but it still might not click inside your head. And that's okay, that happened to me as well. And what you can do here is just keep on practicing. Be patient and continue practicing. If you don't understand something, go through the lessons again. The lessons are always there, so don't worry if you don't understand something right away. You can always come back to them later. And of course, most importantly, never stop learning and never give up. If you're a beginner, learning a programming language for the first time can come with a steep learning curve. And it might be a bit hard as well, but you can never give up, because if you give up, you won't be able to learn the language. So always stay at it and never stop learning. Now what if you get stuck? What do you do? Why do you get help when you need it? Well, first of all, you can always contact us. We're here and ready to help you with anything you need. You can also search on Google. If you encounter an error you don't know how to solve, just copy the error message and search on Google. And more often than not, you'll be able to find the cause of that error and fix it. You can also look for answers on sites like Stack Overflow. StackOverflow.com is a very popular website for questions and answers on programming languages. So it's actually a goldmine for programmers. In fact, Google and Stack Overflow are two of the most important resources a programmer has in his or her arsenal. And you can also check out a JavaScript documentation. For example, the MDN or Mozilla Developers Network contains an extensive and up-to-date documentation on everything about JavaScript. So if you want some reference, go there. Hello everybody, and welcome back to Expert.js. My name's Abrar, and I'm going to be your instructor for this video. In this video, we're going to be talking about prerequisites and some recommendations and requirements that we have for this course. So let's get right to it. Okay, so what do you need for this course? Are there any requirements? Are there any things that you should check off your list before you start this course? Well, we do have a list of prerequisites and requirements for this course. However, here's a quick thing that you should note. These prerequisites are more like recommendations rather than strict requirements, which means whether you meet them or not depends on you. The course can be completed without meeting the requirements. However, the course content might not be that effective and your learning might not be most efficient. So if you don't meet the requirements, it's up to you to decide whether you want to continue on with the course or first take some time to actually meet the requirements. But because they're not strict requirements, you may be able to skip some of them. Okay, so let's talk about the first requirement. What's the first thing that you need for this course? Well, this is a computer programming course, so obviously you'll need a computer, because when you're trying to learn programming and JavaScript, you'll obviously need a computer where you can learn it and where you can practice it. Now you'll need a computer for practicing, learning, and of course real-world development work as well. Now here are a few things about the computer. First of all, a high-performance or very expensive computer is not required. Coding and programming is mostly working with text, which means you won't need a computer with crazy performance in order to run some code. Almost any computer can run some basic code very easily, so you won't need a very high-performance or high-end computer for this course. Any decent computer will do. In fact, even if a computer is old, like 10 years old, even a 10-year-old computer is perfectly capable of running some basic JavaScript code that'll be enough to support your learning. So just use any computer that you have lying around and don't worry about it. And also, whether the computer is a laptop or a desktop or a convertible doesn't really matter that much as well. As long as it's a decent computer which can run some basic code, then it'll be fine. And any major operating system will do as well. Now, you can use any one of the major 3 operating systems, Windows, Mac, or Linux. For this course, we're going to be using a Mac. However, all the things that we're going to be doing on our computer should be perfectly replicable on a Windows or a Linux machine as well. Most professional developers often prefer a Mac or Linux based system because they are more geared towards a power user. However, there are developers who use Windows systems as well, so it mostly comes down to personal preference. If you're serious about programming, then later on you might want to get a good Mac or Linux based computer. But for now, if you have a Windows or any other operating system, don't worry about it. All the things we're going to be doing can perfectly be done in a Windows computer and you have no problem with it. So any major operating system will do. Don't worry about it. And of course, there's one requirement that a good physical keyboard is needed. Now, it is very hard to write code efficiently on a touchscreen keyboard, so using a smartphone or tablet might not be a very good idea. When you're learning programming, you really need a physical keyboard. So make sure you're using a real-world keyboard and not a touchscreen keyboard when actually typing the code, because a real-world keyboard makes writing code and the programming syntax a lot easier. So that's all about the computer that you'll need. So basically, just have a good computer with a good keyboard and you'll be good to go. Now the second thing you'll need is an internet connection. Now an internet connection is sometimes required, but here are a few things about it. First of all, again, a high-speed or premium internet connection is not required. Especially during all the things that we're going to be doing throughout this course, a very high-speed internet connection should not be required. Any decent internet connection should be more than enough. So if you have a good internet connection, that is all you need. In fact, if you're watching this video online, chances are you already have a good enough internet connection. So just use that. Don't worry about the internet too much. And again, coding is mostly working with text. And text files are not really that big in size, which means most code files are actually very small and they can be downloaded and used on even a slow internet connection. So don't worry about the internet connection speed, any decent internet connection is more than enough. And again, the internet can be wired or wireless, it doesn't really matter. If you have a good internet connection with good speed, that's all you need. Now the internet in our case will mostly be used for research, learning, code debugging, and solution hunting on the internet. In fact, when you're running JavaScript locally inside your browser, you won't even need an internet connection because all the files are being loaded directly from your computer. However, an internet connection is a very good thing to have because sometimes you might run into errors or problems that you don't know the solution to. In those cases, it's really easy to solve the problem with a quick Google search. That's why having a good internet connection is helpful. Okay, so the next requirement is knowing HTML. Now if you don't know HTML, HTML stands for Hypertext Markup Language, and this is the markup language which is the basis of web pages. Now knowing HTML is a very good skill to have because it will help you in learning JavaScript. A basic understanding of HTML is thus recommended and very helpful because if you understand the basics and fundamentals of HTML, JavaScript will make much more sense. Because with web development and front-end development, at the very bottom we have HTML, that's the foundation of a web page. On top of that we have CSS or cascading style sheets, and on top of that we have JavaScript which adds dynamic behavior. So that's why actually development and learning most often starts from HTML and then jumps to CSS and then to JavaScript. So if you're learning JavaScript, it's helpful if you have a good understanding of HTML. Now there's no need to be an expert at HTML. A basic fundamental understanding of HTML is more than enough. So if you don't know HTML currently, you can in fact go online and read some quick tutorials about HTML which will give you a basic understanding of the language, and that should be more than enough. You don't need to be an expert, and understanding the basics of the language doesn't take that much time. Knowing HTML actually makes the course content more effective and your learning more efficient. Because again, HTML is the foundation. If you know that, it's a lot easier to learn JavaScript, which is built on top of all this. The next requirement is CSS. Now CSS, or cascading style sheets, is the language that is used to style HTML. It is the styling language of the web. Now as we just said, HTML is at the bottom. That's the foundation. On top of that, you have CSS. So after you learn HTML, developers usually learn CSS, and then developers move on to JavaScript. So knowing the basics of CSS is again helpful when you're learning JavaScript. Being able to understand CSS code is helpful because oftentimes JavaScript includes CSS code and manipulating a lot of CSS properties. Understanding the fundamentals is again enough. You don't need to be an expert at the language. The CSS language itself is actually quite detailed, but in order to learn JavaScript efficiently, you really just need to know the basics of CSS. So if you don't know CSS right now, again, you can go online and read some quick tutorials which should give you a basic overview, which should be enough to get you started. And just like HTML, knowing CSS makes learning JavaScript and front-end development a lot easier, faster, and simpler. Because if you know HTML and CSS, a lot of things in JavaScript will make a lot more sense. The next thing that you'll need is a web browser. Now the web browser is a core component of front-end development, and when learning JavaScript, it's very important that you have a good web browser. So a good and up-to-date web browser is required for development and learning, because oftentimes you'll be practicing code, debugging them, and inspecting them inside the web browser. Now you have a lot of options when it comes to choosing a web browser. There's Google Chrome, Mozilla Firefox, Apple Safari, Microsoft Edge, amongst a lot others. For this course, we're going to be using a Google Chrome browser. However, you can use other browsers as well. Do note that Chrome and Firefox actually comes with a built-in set of very good developer tools, so you might want to choose one from these two. And these browser developer tools actually make writing code a lot easier and makes debugging and inspecting code a lot easier and faster as well. And that's why a good web browser is important for front-end development. The next thing that you'll need is a code editor. Now a code editor is actually the program that you use to edit and write the code. So this is the software that you use to open up all your code files and write the code. Now a good code editor makes writing code easier because a good code editor will have a lot of features that will make writing code a lot faster and more productive. Now there are a lot of options that you have when choosing a good code editor. There's Atom, Sublime Text, amongst a lot of others. For this course, we're going to be using Atom, which is a very good open source, hackable text editor that has a lot of customizations and options available. So it's a very good text editor if you don't know where to start. However, most professional developers actually use a command line based code editor called Vim. Now Vim is very productive, however it's a bit advanced and it has a steep learning curve because it doesn't actually work like a normal GNU software. So you might want to use a simpler and more beginner friendly text editor such as Atom. Now using word processor applications such as Microsoft Word or Apple Pages is not recommended because these things are not actually designed to write code. Using a program specifically designed to write code makes programming a lot easier because they have certain features such as syntax highlighting and autocomplete. And word processor files often suffer from file extensions and encoding problems, so using them is not recommended. Just get a nice code editor and you'll be fine. Now all those requirements and recommendations are good. However, there's one requirement that is very important and that you should definitely meet when you're starting this course. And that requirement is the right mental attitude. You'll need the patience, the willingness to learn, some hard work, a lot of practice, and a never giving up attitude. Now if JavaScript is your very first programming language that you're learning, then it might have a steep learning curve. A lot of things you might not understand, and that's okay. Almost no one understands it completely on their first try. So if you're confused about something, or the language just seems very hard to actually learn, then don't give up. You might need some time before you actually understand it and everything actually clicks inside your head. So until then, you need to practice, you need to review all the materials, you need to learn the best you can, and of course, you must never give up. And if you can do that, you'll be successful at learning JavaScript, even if you're not very intelligent, tech-savvy, or very creative. So just to reiterate, these are all the things that you'll need for this course. First of all, you need a decent computer and a good internet connection. These two things are the fundamentals when it comes to development. And then you'll need a basic understanding of HTML and CSS, because understanding these two languages helps a lot when learning JavaScript. Then you'll need the right tools for development. which means a good web browser and a good code editor, because these two tools will make your development work a lot easier and faster. And of course, most importantly, you'll need the right attitude and focus. If you have all these things, you're more than ready to learn JavaScript, so go ahead and jump right into the course. Hello everybody, and welcome back to Expert.js. I'm Abrar, and I'm going to be your instructor for this video. In this video, we're going to be talking about understanding JavaScript. We'll take a look at what JavaScript is as a programming language and understand the fundamentals of JavaScript and also the World Wide Web so that we can understand going forward. Okay, so first let's answer the question, what is JavaScript? Like, this course is about JavaScript, we all know that. We also know that we want to learn JavaScript, but what is the definition of JavaScript? What exactly is the JavaScript programming language? Well, JavaScript, or JS for short, is a high-level, lightweight, interpreted or JIT compiled, multi-paradigm programming language supporting object-oriented programming, imperative and declarative styles that features dynamic weak typing, first-class functions, and prototype-based inheritance. Now, these are the main characteristics of JavaScript, and you might not understand what all of this means right now. Don't worry, as we go through this course, we will gradually start to understand what all of this means. But for now, just know that JavaScript, or JS, is a programming language that is mostly used on the web to add dynamic behavior to websites and web applications. Now, before we actually dive into JavaScript specifically, let's take a step back and talk about how the web works. Now, we all use the web, right? The internet is a core part of our digital lives, and if you're watching this video, chances are that you use the internet as well. Now, in the internet, we do a lot of things. We browse websites, we check email, we get a lot of work done, and we read news and articles, amongst a lot of other things. But how does this web actually work? How do the websites work behind the scenes? So on a fundamental level, how does the internet work? Well, internet means interconnected networks, right? Which means the internet is a mesh of networks which are all connected to one another. That's why they're called interconnected networks, or the internet. Now, in order to understand how internet works in real life, let's take a look at a very simple example of a network or a connection. Let's say that we have two computers, computer 1 and computer 2. Now, what if we want to connect these two computers? Say we want to connect these two computers together so that we can transfer data between them. We want to transfer files and other data in between these two computers. Well, one way of doing that would be using a good old Ethernet cable. So if we have an Ethernet cable, we can use that cable to connect these two computers together. And then when computer A and computer B are connected using that Ethernet cable, we can transfer data between them using that cable. So we can send files from computer A to computer B and vice versa. So in this case, using that Ethernet cable, we have established a connection between these two computers. We can call this a very simple network. In fact, it's the simplest a network can ever get, because it has only two nodes or two parties, two computers connected to one another, and that is a very simple network. Now, on a fundamental level, the internet works in a very similar way. On the internet, instead of just two computers, we have billions and billions of devices that are all connected to the internet, and that creates a very big network connecting all the billions of devices from around the world, and that is what we call internet. Now, in our example, we had two computers which we connected using a simple Ethernet cable. But in the real world, all the devices on the internet connect in different ways. Some of them connect using a cable, for example by using a fiber connection or a dial-up connection, or maybe a wireless connection such as Wi-Fi, or maybe carrier-based cellular data. We have submarine cables which connect the different continents and different countries together on the internet. Another thing to note that in our example, we had two computers and those two were connected using an Ethernet cable. But in the real life, on the internet, we don't just have computers. These days, we have a lot of different devices. We have, for example, computers including laptops, desktops, convertibles. We also have mobile devices such as smartphones and tablets. We also have wearables, smart speakers, amongst a lot of other things. So these days, we have a lot of electronic devices that can connect to the internet. And the internet is made up of all these devices connected in one way or another. Now, when we have two computers connected using a simple Ethernet cable, Because we only have two computers, it's really easy to identify them and communicate between these two computers. However, on the real internet, we have billions of devices from all around the world. So how do we recognize a specific device? That's why each device that connects to the internet needs a unique ID, right? We need some way to identify that specific device on the billions of devices that are connected to the internet. And we do that using an IP address. An IP, or an Internet Protocol address, is a unique ID that is given to each device that connects to the internet. And that unique ID can be used to refer to that specific device on this pool of billions of devices that are connected to the internet. Now, amongst all the devices that are connected to the internet, a lot of them are consumer devices, which means they're used by the general public. So when we, for example, use the internet from our computers or our smartphones, we are connecting to the internet through those devices. And using that computer or smartphone that is connected to the internet, we might browse the web, check email, or maybe read some news and articles. And all of these things we're doing from our computers and smartphones. These computers and smartphones that we use to access the internet are known as consumer devices or user devices. However, there is another type of device that is connected to the internet as well, and this type of device is known as a server. Now, servers are just like ordinary computers, although they are a lot powerful, but fundamentally they're just a computer. But the difference is that these computers stay connected to the internet almost 24/7. So while a normal user might connect to the internet, browse for a few minutes and take some emails and stuff like that, and then they might disconnect from the internet. And when they do, their device is offline. They're not connected to the internet anymore, and their device is not available on the internet as well. However, server computers have a very high uptime, which means they actually run and stay connected to the internet almost 24/7. And that is because these server computers are usually serving an important resource. For example, a website. So if you have a website and you want to make that website available on the internet so other people can access it, you need to put that website and all the files related to that website on a server computer. And that server computer will be online and it will stay connected to the internet almost 24/7, which means it'll be available whenever someone on the internet asks for that website. And this is how the web works. When you have a device which is operated by a user and that is connected to the internet, and you have your server computer which serves and hosts your website, and that is also connected to the same internet, then the user can request access to the website through the internet using a web browser, and the server will receive that request and respond to it with the correct website files. And those website files will travel back through the internet to the user's device, and it will be loaded, and the user will have that website available on their device. So if we try to visualize this whole diagram, this is how it probably looks. So first we have a device. By device here we mean the user device. So it can be a smartphone, it can be a computer, it can be a tablet, laptop, desktop, or a wearable, or a smart speaker, it doesn't matter. It can be any electronic device that can connect to the internet. And this device is usually operated by a normal user, so a normal person like me or you. Now after the user has connected to the internet, let's say that that user wants to visit a website. Let's say the website example.com. So if we have a website example.com and the user wants to visit that website, what does she do? In most cases, the user will usually open up a web browser. So a web browser is a software that is available on the user's device. Now as we know, there are a lot of popular web browsers, such as the Google Chrome, Mozilla Firefox, Microsoft Edge, Apple Safari, amongst a lot of others. So let's say that a user has one of these installed on that device and she uses that to browse the internet. So she opens up the browser application and on the URL box or the search box, she types in example.com and presses enter. And the moment she presses enter, the browser actually sends a request through the internet to the server that actually hosts the website. And this request is what we call an HTTP request, or a Hypertext Transfer Protocol request. Now internally, all the devices on the internet are recognized by a unique IP address. However, normal users usually access websites by domain names. For example, the user might type in example.com. Now in this case, the browser will actually have to send a request to a DNS server first. And that DNS server will convert the domain name into a related IP address. So the browser will basically ask a DNS server, hey, I need the IP address of the server that hosts this example.com website. And the DNS server will search through its database of all the different domain names and the related IP addresses, and when it finds the example.com domain name, it'll also find the associated IP address of the server that hosts the website. So in this case, we have a server which has an IP address, and that server hosts the example.com website. So the DNS server will respond back with the IP address of the domain name. So a DNS server basically takes a domain name and translates it into an IP address. Now once the browser has the IP address, the browser can send an HTTP request to that specific IP address. So basically, through the internet, the browser sends a request to the specific server that hosts the example.com website, telling that server that, hey, I want this example.com website on my device. So it sends an HTTP request to the specific server. And here we have the server. Now the server, as we just said, is like any other computer, although it's a very powerful computer and it stays online almost 24/7. And this server's storage has all the files of the example.com website. Furthermore, this server is open to HTTP requests. Basically, it's ready to serve the example.com website's files. So when it receives an HTTP request from the user's device, it does some processing on its own. Depending on how complex the website or the web application is, we might have the server first, which is a server software. We also might have a server-side scripting language, which defines the backend of the website. And we might have databases as well, which permanently stores data on the server. So after going through all these processes, the server finally comes up with all the files for the example.com website. And those files might contain the HTML, CSS, and JavaScript files of the example.com website. So when it's done processing the HTTP request, it responds with an HTTP response. And this response contains all the files of the example.com website. And all these files travel through the internet to the user's device, and the browser takes all those files and loads them up inside the user's device, and thus now the user can see the example.com website. This is how the web actually works. You have a device with a browser application or something like that, which is able to send HTTP requests, and you have servers ready to serve those HTTP requests, and that server actually contains the website or the web application, and the server's job is to process the HTTP requests, figure out what to do in response, and send that response back to the device that sent the original request. So in this case, the user's device basically asks the server, hey, I want this example.com website. And the server says, well, okay, then here's the website files. And this sends the website files, and the browser inside the user's device takes those files, loads them up, and thus the user can now see the example.com website. This is how websites and web applications actually work. Now, if the website is a static website, then the whole process is actually very simple. Because then on the server, you just have the static website files, including HTML, CSS, and maybe JavaScript. And all these files will be stored on the server. And when a user's device from the internet requests those files, the server will basically just serve those files up, and the device browser will load them up, and the user will have access to that website. However, it gets a little bit more complex with dynamic web applications. In that case, you'd usually have some server software on the server computer. And before sending a response, the server will most likely need to do some processing on its own. And that is done using server-side scripting language. And these server-side scripting languages often come with frameworks, and sometimes these frameworks actually bind the server and the server-side scripting language together in one big application. You also might have databases, and these databases can be SQL databases or no SQL databases. And these databases can be used to store data permanently on the server. So, to illustrate how this works, let's say that the example.com website actually has a users area, where a user with an account can actually log in with the email and password. So first a user visits the example.com website, and then on the login page, she inputs her email and password and presses the login button. Now usually the HTTP request that is used to communicate between the server and the device is an HTTP GET request. But in these cases, when we need to send some data from the device to the server, for example in this case, we need to send the email and password from the user's device to the server, so the server can actually evaluate whether the email and password is valid or not. In those cases, you'll usually use an HTTP POST request. Using an HTTP POST request, you can actually send some data along with the request. So in this case, when the user inputs her email and password and presses the login button, the browser sends an HTTP POST request. And inside the POST request body, it also sends the email and the password that the user has entered. And this POST request is sent to the server. So when the server receives this POST request, it also receives the email and password the user has entered on her device. And this is where server-side scripting comes into play. Because here the server-side script or the backend web application actually takes the email and password from the POST request, and then it searches its database. And in its database, it has a list of all the emails and passwords of all the users of that website. So when the server receives the HTTP POST request along with the email and password, then the server-side script or the backend of the web application actually searches the database for that specific email and password. And if it does find a match, it responds with an HTTP request allowing the user to access the user's profile or the dashboard. But if it can't find the email and password and those two doesn't match, then the server responds, sorry, that email and password is not valid, so try again. And that's how we have different types of HTTP requests for different types of operation. Usually we use an HTTP GET request. However, if we want to send some data, we would usually use an HTTP POST request. If we want to update some data on the server, often an HTTP patch or put request will be used. And if you want to delete some data from the server, often an HTTP delete request will be used. So we have different types of HTTP requests for different types of operations. And the user's device and the server computer communicates with one another using these HTTP request and response protocols. And this is how the web works. Basically, on the web and on the internet, we have billions of devices connected to the same network from all around the world in one way or another, either actively or passively. And some of these devices are user devices, which normal people use to browse the web. Others are server computers, and these servers are actually powerful computers which stay connected to the internet almost 24/7. And these servers are almost always online to serve some important resource, for example, a website or a web application. And the user's device and the server communicates with one another, sending data back and forth using HTTP requests and responses. And through this protocol, data is sent back and forth between these two devices. Now these days, oftentimes we have more modern single-page web applications. And these web applications actually communicate with the server through AJAX requests using a data type known as JSON. Now AJAX means asynchronous JavaScript and XML. And using AJAX, the device can communicate with the server asynchronously using HTTP requests. And in these cases, a syntax known as JSON or JavaScript Object Notation is used to send data back and forth between the device and the server. And when the browser receives some JSON data, it parses and interprets that data and loads it up inside the browser in the web application. Now, all the HTML, CSS, and JavaScript that is loaded inside the user's device and browser is known as client-side code. And all the code that stays on the server is known as server-side code. And that's why programming web applications on the server is known as server-side scripting. And programming web applications for the user's device is known as client-side scripting. That's why the application loaded inside the browser of a user's device is known as client-side, and the server is known as server-side. And JavaScript is actually executed inside the user's browser, inside the web application that is loaded. And that is how the web works in a nutshell. Okay, now let's talk about HTML, CSS, and JavaScript. So where does JavaScript go in relation to HTML and CSS? Well, if you imagine HTML, CSS, and JavaScript as being different layers of the web development process or different layers of the web page itself, then you can visualize these three languages somewhat like this. At the very bottom, we have HTML, because HTML is the foundation of a web page or web application. HTML or hypertext markup language is what defines the structure and basic content of a web page. So that goes at the very bottom, because the development of a web page usually starts with HTML, because HTML defines the fundamental structure of a web page, and that is what we start the development with. So for a website, the development usually starts at HTML, because that defines the basic structure. And then on top of that, you have CSS or cascading style sheets. CSS is used to style the web pages. Specifically, CSS can be used to add style and change the appearance of the default HTML elements, which means CSS sits on top of HTML, because after you've defined the HTML, then you can go ahead and define the CSS styles for the different HTML elements. And that's why at the bottom we have HTML, and then on top of that we have CSS. And on top of that, we have JavaScript, because JavaScript is a programming language or a scripting language, and this language can be used to add dynamic behavior and interactivity to any web page or web application. So a web page that is otherwise static, using JavaScript, you can make it dynamic and interactive. And this sits on top of HTML and CSS. And that's because when JavaScript is usually used on the front end or the client side, one of its biggest jobs is to manipulate HTML and CSS. That's one of the most common things JavaScript does on a web page. So you can think of JavaScript as sitting on top of HTML and CSS. Because usually, after you've defined the HTML and CSS, then you can work with JavaScript. And you can use this JavaScript to manipulate HTML and CSS and add dynamic behavior and logic to your web application. So if you think of HTML, CSS, and JavaScript as being different layers of the web, then you can think of HTML as being at the very bottom, defining the very fundamental structure of a web page. Then we have CSS on the middle, which defines the structure, which goes on top of HTML. And then on top of that, we have JavaScript, which defines the dynamic behavior and logic for a web page. And that's how we have HTML, CSS, and JavaScript stacked on top of one another. Now, what does JavaScript look like? Like, we've been talking about JavaScript for a long time, but we haven't actually seen much JavaScript code. So it's time that we actually take a look at what JavaScript looks like, what the syntax looks like, and how JavaScript looks when you actually write it out. So in order to show you how the programming language JavaScript looks in real life, let's create a very simple web application that can be used to illustrate how JavaScript code looks and also show some usage of JavaScript in real life. We will start with some HTML. So first we will have an HTML h1 tag which says say hello. So we basically have an h1 tag which is the first heading in HTML with the text say hello and then an exclamation mark. Then we'll have an input element. Now the input tag in HTML can be used to create a form field where the user can enter text or other data. So in this case we'll create an input tag and we'll specify the type attribute as text. So the type will be text, and we'll also define the placeholder attribute which will contain the text enter your name here. So this is an input field where users can input their names. Then we'll create a button element. So we'll create a button tag with the text say hi and an exclamation mark. So we just create a button tag with the text say hi. And finally, for the HTML, we will create an h2 tag. The h2 tag in HTML is used to create a second level heading. Now in our case, the h2 tag will be empty. It doesn't contain any text. So when you load up the web page, this h2 tag won't be visible at first. However, we will populate this h2 tag with text using JavaScript. So we'll have an empty h2 tag for now. And now it's time to write our JavaScript. Now inside HTML, you can write JavaScript using script tags. You can put the JavaScript code inside a pair of script tags. So in this case, we'll write our opening script tag, and then we'll write our JavaScript, and then we'll finish it up with the ending script tag. So we have our opening script tag here, and now it's time to write some JavaScript. So what will we write here exactly? We will define some code such as document.querySelector button.addEventListener click, and then we'll define a function where we create a variable called name and then assign it the value document.querySelector input.value.trim or the string world. And finally, we select the h2 tag using document.querySelector h2.textContent and set it to hello plus name plus an exclamation symbol. And then we finish off the function and also the addEventListener method. And then finally, we wrap everything up with the ending script tag. So this is the JavaScript that we have written for this application. But what does this JavaScript actually do? In order to find that out, let's actually take this code and execute it inside a browser and test it out. Okay, so here we have the HTML and JavaScript code that we just saw saved inside a file named index.html and loaded inside a browser. So on the left hand side, as you can see, we have a file named index.html loaded locally from the computer. So on the left side here, as you can see, we have a browser, Google Chrome in this case, inside which we've actually opened and loaded up the index.html file, as you can see from the URL bar right here. And on the right hand side, we have our code editor. In this case, we're using Atom. And with Atom, we have opened up the index.html file and we can edit the code here. So first, in the HTML file, we have some basic HTML code such as the document type, defining HTML, meaning it's an HTML5 document. Then we have the HTML tag, then the head tag, and inside the head tag we have defined the character set UTF-8, and then we also have the title tag that says JavaScript practice. And then inside the body tag is where we actually have the code that we just saw, the HTML and JavaScript code that we just saw a few moments ago. So here we have the h1 tag again that says say hello, then the input tag with type text and placeholder enter your name here, then the button tag that says say hi, and then an empty h2 tag. And then we have the script tag with our 4 lines of JavaScript code like we have here. So here inside Atom, we have written all this code and saved it in a file on our computer named index.html. And we have loaded the same file inside our browser here. So as you can see in the browser, we can see the HTML. We have the h1 tag that says say hello, the input form element that says enter your name here, and also a button tag that says say hi. So what does this actually do? Well, in order to test the code out, let's actually input our name here. So in this case, I'm going to input my name, Abrar, and then after entering my name, if I click on the say hi button right here, as you can see, it greets me by my name by saying hello Abrar. So basically what this code does is that it takes the user input from the input field and greets the user by that name. So basically whatever you enter here, if you enter 123 here for example, and then click on the say hi button, it greets you by that name, hello 123. What's even more interesting is that if you leave this input field blank or just put spaces there and then click on the say hi button, then it defaults to the string world. So it says hello world in case you haven't inputted anything valid inside the input field. So it defaults to hello world. But otherwise, it just greets you by whatever name you just input in the input field. So using just a bit of HTML and JavaScript, we've created a cool little greeting application. Nice, right? Okay, so let's get back to where we were. So in this case, this is what JavaScript actually looks like. Now, one thing to remember here is that we're using some pretty advanced level JavaScript code for this example. So we're using a lot of properties and methods and a lot of things that you might not be familiar with. For example, you might not know what variables are or how logical operators work. But don't worry, you don't have to understand this code. This code isn't meant to be understood at this point. This was just a cool example to show you how JavaScript actually looks like and how it appears on the web page. So if you don't understand this code now, no need to worry. As we go through this course together, we will eventually understand everything that's going on here. We will understand what variables are, what logical operators are, how functions and methods work, and all that kind of stuff. For now, just know that this is how JavaScript looks in real life. Now, if you're really interested as to what's actually going on here, here's a brief description. First, we have documented query selector button. Using the query selector method of the document object, we're basically selecting the HTML button element. Then we have .add event listener, click, and a function. Basically, we're adding an event listener for the click event and also defining a function that should be executed when the event occurs. Basically, we're telling JavaScript that this is what you need to do when the button element is clicked by the user. And then inside the function, we declare a variable called name. And we assign it the value document.querySelector.input.value.trim. This basically selects the input HTML tag and selects the value and trims any white spaces out, and then it assigns this value to the variable called name, or if this value is not truthy, it defaults to the string world. And then finally we have document.querySelector.h2.textContent, which basically selects the m2h2 tag that we have in our HTML, and it adds some text inside it. Specifically, it has a string hello concatenated with the name the user has inputted in the input field, so it can be used to greet the user by the name. And this is what this JavaScript code actually does. But again, you don't have to understand every bit of this right now, because we will eventually talk about all of this later on in this course. Now let's talk about JavaScript's characteristics. Now JavaScript is a programming language, but it has a few characteristics. So what are they and what do they mean? For example, when we looked at the description of the JavaScript programming language at the very start of this video, there were a lot of characteristics and you might not know what they all mean. So let's break down some of them in this video right now. First, we'll talk about high-level programming languages versus low-level programming languages. Now, JavaScript is a high-level programming language, but what's the difference? What's the difference between a high-level programming language and a low-level programming language? Well, a high-level programming language is a programming language that is more or less independent of a type of computer or hardware the code is written in, which means you can actually write this code in one type of computer and run it or execute it in another type of computer. So the code itself is not specifically tied to any computer, architecture, or set of hardware. It can run on a wide range of hardwares and devices, and this is called a high-level programming language. High-level programming languages such as JavaScript are closer to human languages. On the other hand, we have low-level programming languages. The assembly language and machine languages are good examples of low-level programming languages. These low-level programming languages are mostly dependent on a specific type of hardware or architecture to run their code on, which means when you write the code on a specific computer, you have to write the code for that specific set of hardware or hardware architecture. And most of the time, you can't take the same code and run it on a completely different type of computer. In order to do that, you first have to convert the code or modify it in some way. And that's because low-level programming languages are very dependent on a specific computer, hardware, device, or architecture. And the code itself is often written for a specific type of architecture or hardware only. And the same code can't run on many other types of hardware. This is in contrast to high-level programming languages, where you can write the code on a computer with an Intel processor, for example, and execute the same code on another computer with an AMD processor. Or, for example, you can write the code on a computer and execute it on a mobile device, such as a smartphone, where the architecture and the set of hardware are completely different. But for high-level programming languages, it doesn't matter, because high-level programming languages are very independent from a specific type of hardware. And JavaScript is a high-level programming language, which in a way is very good and very convenient. Because with JavaScript, because it's a high-level programming language, you can write the code in one computer, and the same code can be executed on a wide range of computers, devices, and set of hardwares. This makes development a lot easier because you don't have to write code separately for different types of hardware that you need to support. You can just write the JavaScript code once, and the same code can be ran and executed on different types of hardware. And that's what a high-level programming language means. And JavaScript itself is a high-level programming language. Now let's talk about interpreted programming languages versus compiled programming languages. Now JavaScript again is an interpreted programming language. An interpreted programming language is a programming language where the commands, instructions, or statements are executed more freely and directly by the implementation of the language. It doesn't need to be converted or otherwise translated into another type of language. The code is usually executed by an interpreter, and the interpreter interprets the code line by line and executes it. This is in contrast to compiled programming languages. With compiled programming languages, the code must first be compiled or converted into a somewhat different language before it can actually be executed. A good example of a compiled programming language would be Java. Now Java code isn't usually executed directly, but instead is first compiled into another language called bytecode, and this bytecode is what's actually executed. So with a programming language like Java, after you write the code, you first have to compile it into a different type of language, and then that compiled code can be executed by the implementation of the language. However, with interpreted languages, you usually don't need to compile it into a different language first. You can just write the code, and then that code can mostly be executed directly and freely by the implementation of the code. It doesn't need to be converted or compiled into a different type of code. So JavaScript is an interpreted programming language, which means you don't need to compile the code into a different type of language first before you can actually execute it. We can just write the code in a code editor, and the statements or instructions inside the code can mostly be executed directly and freely by the browser at runtime. It doesn't need to be compiled first. Now JavaScript is actually also a JIT compiled language. Now JIT compilers, or just-in-time compilers, compile the code just in time, or in most cases in real time. But for now, you can think of JavaScript as mostly being an interpreted language and not a compiled language. Now there are actually advantages and disadvantages to both interpreted and compiled programming languages. For example, interpreted programming languages have the advantage that they are very easy to write because they don't need to be compiled into something different first. You can just write them and the code can be executed more or less directly and freely. They don't need to be compiled into something different first. However, the same feature comes with a downside is that interpreted programming languages often have a higher chance of errors and bugs residing in the code. Because the code is interpreted and executed at runtime, if there's a bug or error in the code, you won't be able to find it until the execution reaches that point. And when it does, it'll usually throw a dynamic error, which sometimes might be hard to find or otherwise annoying. Compiled programming languages solve this problem by compiling the language into a different language first. So in this case, if there's an error in your code, you'll usually find it at compile time. So when you go to compile your code, usually the error will be thrown, and you'll be able to find it and fix it before the code even gets compiled. So this has a better guarantee that the compiled code will be mostly error-free and bug-free. However, it also comes with the downside that compiled programming languages sometimes are a bit complex to work on and sometimes take a long time to actually implement. So there are advantages and disadvantages to both types of programming languages. Now JavaScript is also a lightweight programming language. A lightweight programming language means a programming language that is designed to have a very low or small memory footprint. It shouldn't require a lot of memory to be ran and executed. And it also means that the code syntax should be minimalistic, simple, and it should be easy to write and implement. So JavaScript is an example of a lightweight programming language. And thus we have a simplistic syntax and set of features, and also the language is very flexible. Now before we dive into the language, let's take a moment to look at JavaScript data types. Now every programming language usually have a set of data types. The data types of a programming language are types of data the programming language can work with. Now JavaScript has quite a few different data types. Let's take a look at them. First we have strings. Now strings in JavaScript are used to represent plain old text. And they're also one of the primitive values in JavaScript. Then we have numbers. In JavaScript we have only one type of number, which is used to represent both integers and floating point numbers. And numbers is also one of the primitive data types of JavaScript. Then we have booleans. Now booleans, unlike strings and numbers, can only take one of two values, true or false. And this is also a primitive data type in JavaScript. Then we have symbols. Symbols are a new data type added to the language on the release of ECMAScript 2015. And then we have objects. As you'll learn that almost everything in JavaScript is actually an object. And inside objects, we have all different types of objects. We have some built-in objects such as arrays, dates, and functions, and we also have custom objects that we can define ourselves. And then we have a special value called null. Now null means a deliberate non-value, which means the value is non-existent. And another special value we have is undefined, which represents a value that is not defined yet, which means the value is undefined now, but the value may be defined later. So these are the main data types of the JavaScript programming language. Now let's talk about what JavaScript can actually do. Like, we know JavaScript is a programming language, but what power does it actually hold? What can it be used for? And what things can it accomplish? Well, JavaScript, being a programming language, can do a lot of things. But right now, let's take a look at some key things JavaScript is capable of doing. First of all, JavaScript can add, change, or delete HTML. So when used inside the browser, JavaScript can manipulate HTML to a high degree. And this can be used to build dynamic and interactive web applications. Now remember the JavaScript code that we saw in our greeting application? In that application, we used JavaScript to manipulate HTML. So that's one of the key things JavaScript can do. JavaScript can also add, change, or delete CSS styles. Now we didn't actually do this in our example greeting application, but just like HTML, JavaScript can actually manipulate CSS styles as well. JavaScript can react to certain events. So inside a web application, for example, there are usually a lot of events that can happen. For example, the user is clicking on something, dragging something, inputting something, copying or pasting something, or pressing a key on the keyboard, or maybe something like a resource is being loaded or has finished loading. These are all events JavaScript can react to. So when these events occur inside our web application, JavaScript can actually react to it and run some code in response to these events. We actually saw an example of this in our greeting application, where when the user clicked on the Say Hi button, we ran some code. Specifically, we ran some code which greeted the users by their names. So this is how JavaScript can react to certain events inside a web page. JavaScript can add dynamic logic and behavior. Now we actually saw a little glimpse of this feature inside our application, where we use the logical OR operator to find out whether the user has actually inputted something valid in the input field, and if it has, we use that input. Otherwise, if there's nothing valid inputted on the input field, we just default to the string world. So that is a cool little example of how JavaScript can be used to add dynamic logic and behavior to your code. JavaScript can create interactive web applications as well. So with our greeting application, for example, we created a very simple yet interactive web application where the user can actually input something, click on buttons, and receive feedback for their actions. And this is how you can create interactive web applications using JavaScript. And JavaScript can also communicate with and even run on the server. Now that's also one of the more important things that JavaScript can do. JavaScript can communicate with the server. For example, it can send JSON data to the server using AJAX requests, and this can be used to build single-page interactive web applications using JavaScript. And with runtime environments such as Node.js, JavaScript can actually run on the server as well, which means JavaScript can actually be used as a server-side scripting languages on the server itself as well. Now let's talk about some facts about JavaScript. But these are some cool things that you should know about the language. First, JavaScript is considered the programming language of the web. Now, JavaScript is massively popular in front-end and client-side web applications. Almost every browser supports JavaScript, and JavaScript is used in almost every dynamic web page or web application. And that's how it has gained massive popularity and has become the default and go-to programming language of the web. JavaScript and Java are actually separate programming languages. So despite the similarity in the name, these two are actually separate programming languages. They are not the same. JavaScript is actually inspired from Java, and that's why JavaScript's syntax is actually very similar to that of Java's. However, these two are fundamentally separate programming languages. Java is a class-based, compiled programming language supporting strong static typing, whereas JavaScript is a prototype-based, lightweight scripting language with dynamic weak typing. So while there are similarities between the two languages, these two are actually separate programming languages and they are not the same. Almost everything in JavaScript is an object. Now, you might not understand this right now, but as we go through this course and start learning about JavaScript more and more, we will understand that almost everything in JavaScript is actually an object. Objects are the fundamental building blocks of JavaScript, and that's why objects are very, very important when it comes to the JavaScript programming language. Now, JavaScript is actually officially called ECMA script, and it's a standard maintained by ECMA International or ECMA International. So the official name of JavaScript is actually ECMA script. JavaScript was actually first designed by Brendan Eich in 1995, so you can think of him as the founder of this language. And the latest stable version of JavaScript is called ECMA Script 2017, which, as the name implies, has been released in 2017, and that is the latest stable version of JavaScript. And just like with every stable release, quite a few new features have been added to the language in this release. Now let's take a moment to talk about how JavaScript is actually executed inside the browser. Now JavaScript code is executed from top to bottom, left to right. So the JavaScript interpreter starts the execution at the very top of the code, starting from the first line, and then it continues executing the code line by line. And for each line, the code is executed from left to right. So for each line, the execution starts from left and goes on towards the right. JavaScript is case sensitive, and this is a very important thing to remember because most of the time when writing code, the case matters. So a lowercase letter is not necessarily the same as the uppercase letter. And because the JavaScript language is case sensitive, that means most of the time you'll have to write the JavaScript code as is. You can't change the case, otherwise the code might not work. So if you see some example code in this course and decide to try it out yourself, then make sure that you write the JavaScript code exactly as is. Because most of the time, if you change the case a little bit, or the case is not right, then the code will throw an error and the code won't work. So that's why you have to be very careful when writing JavaScript code, because most things in JavaScript is case sensitive. JavaScript statements are actually commands that are executed by the browser or the interpreter. So in JavaScript, you can think of each statement as a different command or instructions that tells the browser to do something. JavaScript statements should end with a semicolon. Now in some cases you might be able to skip this and the code might still work. However, as good practice, you should always end a statement with a semicolon. This makes the code more readable and manageable. And inside a browser, when JavaScript is executed, it is actually executed along with HTML and CSS in an execution environment called a browser tab. So when you open up a web page, you usually do that in a tab inside the browser. And this browser tab is the execution environment for the JavaScript code. And this is where the JavaScript code is actually executed. Hello everybody, and welcome back to Expert.js. I'm Abrar, and I'm going to be your instructor for this video. In this video, we're going to be talking about becoming a JavaScript programmer. Now, becoming a good programmer is not an easy task, so let's get right to it. Okay, first let's talk about becoming a programmer. So what is a programmer, and how do you become one? Well, a programmer, a developer, or a coder is a person who writes computer programs and scripts. So whether you call yourself a programmer, a coder, or a developer, your job will most likely be to write code and use the code to create computer programs, software, applications, and other scripts. So that's the job of a programmer. A programmer is someone who writes code and creates programs and scripts. Now, a JavaScript programmer in particular must first and foremost understand the language in detail. That's obvious, right? Because if you are a JavaScript programmer, the very first thing that you'll need is to understand the JavaScript language itself. But just understanding the language is not enough. You need to understand the more complex and advanced features and even the more newer additions to the language as well. Because there are a lot of developers who are familiar with JavaScript, who know the basics of JavaScript, who have a good understanding of the language. However, just understanding the language is not enough. If you want to stand out from the crowd and become a really good JavaScript developer, you must understand all the aspects of the language in as much detail as you possibly can. So aim towards becoming an advanced level JavaScript developer. A lot of developers are familiar with JavaScript, however, a great JavaScript developer will stand out because of his or her advanced knowledge and experience. Now, programmers must continue learning and perfecting their craft to stay ahead. The programming landscape is ever changing, and each year new programming languages come to play, new libraries, new frameworks, a lot of new technologies and practices, so you must continue to learn both JavaScript and also other languages if you want to stay ahead and become a great developer. Now, what do JS developers actually do? Like, what are the roles and responsibilities of a typical JS developer? Now, JavaScript developers are generally responsible for writing front-end or client-side JavaScript code for websites, web applications, and other web-related scripts. Because JavaScript is the programming language of the web, it's most often used for front-end or client-side development. And most JavaScript developers often work on the front-end side or the client side of the project that they're working on. Some developers actually work on the full front-end, including HTML and CSS. So these developers don't only write JavaScript, but they also take care of the HTML and CSS. So they're a full-stack front-end developer. Others actually specialize in server-side JavaScript such as Node.js, Express.js, and databases. So although JavaScript is most popular for its uses on the front end, JavaScript can also be used on the back end with runtimes such as Node.js and frameworks such as Express.js. So sometimes these developers specialize on the back-end side of JavaScript and use JavaScript for server-side scripting and manipulating databases. And often you'll find full-stack developers who often use a specific technology stack, such as mean stack. The mean stack stands for MongoDB, Express.js, AngularJS, and Node.js. This is a full technology stack which can be used for front-end and back-end development altogether. In the mean stack, the MongoDB is the NoSQL database that is used for storing data on the server. Express.js is the Node.js framework, AngularJS is the front-end framework, and the Node.js is the JavaScript runtime that is used to run JavaScript on the server. So using such a technology stack, you can build a full-fledged web application using JavaScript. So after learning JavaScript, what type of developer you become will depend on you. If you want to focus on JavaScript specifically, you can become a front-end JavaScript developer who only works on JavaScript for the front end. But if you enjoy full front-end development, including HTML and CSS, you might become a full-stack front-end developer. Otherwise, you might even want to specialize on server-side JavaScript development or a full technology stack such as the mean stack. So what type of a JavaScript developer you become depends on your interest and where you want to go. And specifically what work you'll do as a developer will depend on what your role is and what type of a developer you become. Now let's take a moment to talk about some programmer skills. Now programming is not an easy task, but it's not that hard either. Programming does require some practice and dedication. However, there are some other skills programmers must master as well. For example, programmers must understand the project, the team's goals, and their own roles and responsibilities in the project as well. So programmers must not only know their language and know how to write code, but at the same time, they must be able to keep track with their team, understand their roles and responsibilities, understand the project that they're working on, and also communicate effectively and efficiently. Communication is a big part in working with big projects with other developers. Programmers must also be capable of understanding the scope of the project from a high level. They also need to figure out the challenges and understand the problems that need to be solved. So when a programmer actually starts a new project, before jumping in right away and start writing code, you first need to understand the scope of the project from a high level. Understand what the project is, what are the goals, what exactly are you trying to accomplish. Then you need to figure out the challenges because each project is different. Each application you create will be different, and each application and project will have their own challenges and problems. So you need to figure out those challenges. You need to understand the problems and also be capable of solving them. So often you need to just sit down and thoroughly think about the problems, the challenges, and how they can be solved. A programmer's job is to break big problems down into smaller parts and then figure out how to solve them. Because sometimes a project might be very big, and in those cases, while you always need to have an understanding from a high level, when you're actually working and writing code, you need to break the big problems down into smaller parts. You can use the first principles technique and keep asking questions until you break the problem down into a manageable part. And then once the problem has been broken down into a small and manageable enough part, you need to figure out how to solve it. This is where you might need to think a bit and use your creativity and experience to actually figure out a solution. And then, once you've figured out the solution, the work is not over. Because after figuring out how to solve the problem, you need to actually write the solution in a language that the computer can understand. Which means for JavaScript, for example, you need to write the solution in the form of JavaScript code and programming syntax. And that is actually a vital skill a programmer must have. Now let's talk about a very important topic, thinking creatively. Now in programming, you'll often have to face problems and challenges that you don't understand, that you've never solved and don't know the solution to. However, in those cases, you can't give up. You have to try as hard as you can to understand the problem, and then you need to find a solution. And that requires a bit of creativity, experience, and knowledge. Now one thing to remember here is learning a programming language and syntax is actually easy. Now when you're actually starting to learn a new programming language, it might seem hard. But actually, learning the language is the easy part. What's hard is actually using the language creatively to solve problems and build working applications in real life. So being able to think creatively, find solutions to problems, and writing those solutions in code and programming language requires practice and experience. So if you don't have a lot of experience in programming and you're just starting at a beginner level, you might find it hard to actually think creatively and find solutions to hard problems. But don't worry, those will come with practice and experience. So the more problems that you face, the more challenges that you overcome, And the more experience that you gain in your programming journey, your creativity will automatically improve. Your ability to understand and solve problems will improve as well. And over time, you'll develop the skill easily, and thinking creatively will come naturally to you. Now, a programmer's job is to solve problems. Often that's the biggest and most important challenge programmers face in their daily lives. So understanding how to solve problems is very important and an essential skill to have when you're learning programming. Now, when you're starting with the project, you must first break it down into basic features. Oftentimes, a project might have a lot of features. It might be a big project. You might be working with a lot of other developers and people. So in those cases, it's easy to get overwhelmed. But in those cases, you must calm down and you must break the big project down into basic small features and tackle each feature individually. That'll make actually getting started a lot easier. And then once you start with one individual feature, break that feature down into even smaller steps and continue breaking until the steps are small enough and manageable. Now, a senior and experienced developer might be able to take a big problem and instantly plot a solution. However, if you're a beginner developer, for a big problem, you might not be able to come up with a solution instantly. If that happens, then don't worry, it's okay. If you can't find a solution, then break that problem down into even smaller steps and continue breaking those until the steps are small enough and so specific and you can almost figure out the solution instantly. And then, using your knowledge of the programming language, plot a solution by figuring out how you're going to actually solve the problem. So once you've broken a problem down into its smallest parts, then you need to figure out how you're actually going to solve the problem, and you'll need to plot a solution. And this is where your knowledge of the programming language and your experience will come in handy, because the more knowledgeable you are and the more experience you have, the easier it'll be to actually find a solution. And once you've found the solution, you need to translate the solution into code that you need to write in order to solve the problem. And that is how you can go by when solving problems. Now, before we actually dive into the JavaScript language and start learning all the details, let's first get a few things out of the way. These are some basic things that you need to know about JavaScript before you actually start learning the language. First, let's talk about where do you actually put JavaScript. Now, JavaScript is a programming language, sure, but how do you actually write JavaScript? And how do you actually attach it or make it work with HTML and CSS inside the web browser? These are some basic questions that you might have when you're starting out. So let's tackle them first. Now, when it comes to the placement of the JavaScript code, you have a few options. Specifically, you can put your JavaScript code in one of three places. First is inline with HTML. This is actually a bad practice, so you shouldn't do this. The second option is within script tags. Now, in HTML, you actually have a dedicated script tag for inputting JavaScript. And in an HTML file, you can actually put in a pair of script tags and write a JavaScript code inside this pair of script tags, and those JavaScript will be executed along with the HTML. Or, as is the case for most real-world applications, you can put JavaScript in external and dedicated JavaScript files. Let's take a look at examples of each one of them. First, let's talk about putting JavaScript in line with HTML. Now, a lot of HTML elements and tags actually have JavaScript event handlers as HTML attributes, and you can put JavaScript code inside these attributes. For example, let's say that we have a button tag. So in this case, we've created a button tag, and inside the button tag, we have an onClick attribute. Now, the onClick attribute can accept some JavaScript code that will be executed when that element is clicked. So inside this onClick attribute, we can put in some JavaScript. In this case, we're calling the alert method, which basically alerts a string to the user's browser. And then inside the button tag, we have a text click here, and then we finish it off with the closing button tag. So this is an example of putting JavaScript in line with HTML. However, this is very messy and it's a bad practice. You should never do this. There are a lot of better places to put JavaScript, and inline with HTML is not one of them. You shouldn't mix JavaScript with HTML because it makes the code a lot messier and a lot harder to manage. So don't put JavaScript inline with HTML. This is a very bad practice. A better place to put JavaScript will be inside script tags inside an HTML file. So let's say an example. First, again, we have the button tag in this case, and inside which we have the text click here, and then the ending button tag. But note that we don't have the onClick attribute. And that is because we want to put JavaScript separately in its dedicated script tags. So we just have the button tag with the text click here. And then we put in the starting script tag. And inside the script tag is where we can input the JavaScript. So in this cases, we can write the JavaScript as document.querySelectorButton.addEventListener click, and then a function which basically alerts this is a JavaScript alert to the user's browser. And then we end up the function, and also we end up the script tag. and that is how you can write JavaScript inside script tags. Now the result of this code is exactly the same. When you click the button, an alert will be displayed inside your browser. However, the difference is that we're not mixing HTML with JavaScript. We have JavaScript inside this dedicated script tag, and HTML is completely separate from it. This is a much better practice, and using script tags inside the HTML file is often used for small scripts that you might want to include within your HTML. Now, one thing to note here is that we're using a lot of advanced features of JavaScript and browser APIs in these examples. So if you don't understand the code, don't worry. We will eventually explain all of these in this course. So if you just go through this course, you'll gradually understand everything that's happening here, and you'll be able to understand exactly how this code works. But for now, you don't have to understand the code. This is just an example, and it's here to illustrate that you can put JavaScript code inside script tags. Now for bigger applications where you have a lot of JavaScript code, you might separate them into different files and have their JavaScript code inside dedicated JavaScript files. And these JavaScript files end with a .js extension. So any file that ends with .js is a JavaScript file. So in those cases, you can have JavaScript separated in JavaScript files and HTML separate from it. And you'll need to link the HTML and JavaScript files using a script tag. So how does this work? For this example, we have two different files. One is index.html, which is our HTML file, and we have a dedicated JavaScript file called script.js. And we'll assume these two files are in the same directory inside our computer. So in this case, we put the HTML in the HTML file and the JavaScript separately in its own JavaScript file. So how does this work? So inside HTML, we again put our HTML code. In this case, the HTML code is simply the button element. So we have a button tag that says click here. And then we have the script tag. But instead of inputting the JavaScript directly within the script tag, we have a source attribute. And this source attribute points to the JavaScript file's name. So in this case, the JavaScript file is named script.js, so we refer to that file inside the script tag in the source attribute. So we type in src equals script.js, and this links the script.js file with the HTML file. So when you load this HTML file inside the browser, the script.js file will load alongside with it as well, and the JavaScript inside the script.js file will also be executed. And that is how you can add external scripts with HTML. So now that we have a HTML inside our HTML file, and we also have linked and referred to the script file from our HTML file, now let's actually write the JavaScript inside a script.js file. So in this case, we actually put the exact same code that we saw in the previous slide. document.querySelector-button.addEventListener click, and then a function which basically alerts this is a JavaScript alert to the user's browser. And then we end up the function and wrap up the JavaScript code. Now do note that inside the script.js file, we don't need the script tags. We just put the JavaScript code and that's enough. And that is how you can put JavaScript in external JavaScript files and link them and refer to them from inside our HTML to load those along with the HTML file. And that is how you can put JavaScript in external scripts. Now talking about good coding practices, a very good practice when writing code is to document the code. Documenting code generally means using comments to explain what the code does. Now code can often be complex, right? And if you're working on a project with a lot of other developers and you write some code and the code is a bit complex, other developers might not understand that. In fact, if you write some code and then you come back to that code after a few weeks or a few months, you yourself might not understand what you wrote. So in those cases, you might have to look at the code all over again in order to find out what exactly is going on, what the code does and how it works. All of these problems can be solved if you just document the code, which means you explain what the code does along with the code itself. So whenever someone or you yourself look at the code later on, then you'll instantly understand what the code does and you won't have to spend time actually figuring out and going through all the bits and pieces of the code yourself. And this actually helps a lot when working on big projects with a lot of other developers. And in those cases, documenting code is actually a very good practice. So how do you document code? Usually in JavaScript, you can use comments to document the code. Now comments in JavaScript code are not executed. They're treated as white space, and the browser actually ignores them when the JavaScript is executed. So you can put in almost anything inside the comment, and it won't affect other JavaScript code. Now in JavaScript, we have two types of comments, a single line comment and a multi-line comment. This is a single line comment. In order to write a single line comment, you first type two backslashes side by side. So when you type two backslashes side by side, you are starting a JavaScript single line comment. And anything you put after these two backslashes will be completely ignored for that specific line. So in this case, we put two backslashes side by side, and then we have some text that says this is a JS comment. And that is how you can create a comment in JavaScript. And you can put almost any text inside this comment. Most often, you'll be using these comments to document the code. So before you start one bit of the code, for example, you can write a quick comment that explains what the code does and how it works, so other developers and you yourself can figure out later on how that code actually works. Now we also have multi-line comments in JavaScript. Multi-line comments span more than one line, and you'll often use multi-line comments if you want to explain something big or write a comment that spans more than one line. And you can start a multi-line comment by putting in a backslash and then an asterisk symbol. So when you type in a backslash and an asterisk symbol, a multi-line comment starts. And that comment will continue on until you end the comment with another asterisk and a backslash. So anything in between these two backslashes and asterisks is regarded as a comment, and it'll be completely ignored when the JavaScript is executed. And this is how you can create a multi-line comment to document your code in JavaScript. Now, comments are often used for another thing as well, and that is to mute out code for debugging purposes. So for example, if you have some JavaScript code and you put in a double backslash in front of that code, then that whole line is regarded as a comment, and any code you put in after that is not actually executed. So for example, here we have some JavaScript code that says console.log JavaScript is fun, which basically logs some text to the JavaScript console. However, if we put in a double backslash in front of that, then that line is regarded as a comment, and that code won't be executed. And oftentimes you'll be using this trick to mute out certain portions of your code for debugging and testing purposes. Now let's talk about using developer tools. Now in front-end development, browser developer tools are often used extensively, and they're really helpful. So let's take a look at what they are. Now most browsers these days come with a very helpful set of inspection and debugging tools, often called developer tools or dev tools. Web browsers such as Chrome and Firefox comes built in with these set of developer tools, and these tools are very useful when it comes to debugging and inspecting JavaScript code and also HTML and CSS. And these developer tools allow a developer to inspect code, including HTML, CSS, and JavaScript. So using these developer tools, you can actually inspect the code in detail that you have loaded inside the browser. You can inspect HTML, CSS, JavaScript, and even other resources and assets. These tools are really helpful in finding errors and bugs, and they can even help you test out code before you write them. So for example, the JavaScript console can be used to find errors and bugs, and you can use that console to run some quick JavaScript code before you actually write them. And these tools make the development process a lot easier. The developer tools also allow you to monitor network usage, performance, and even security features. So as you can see, they're useful in a lot of ways. And using these developer tools can improve development productivity. Now oftentimes, if you don't use developer tools, it might take a long time to find an error, write the code, or test it out. And using developer tools can actually improve development productivity and make development a lot faster, easier, and simpler. Now oftentimes, if you encounter an error or if your JavaScript code contains an error, it'll be logged to the JavaScript console in the developer tools. However, sometimes you might have some logical errors in your code. In those cases, you might need to debug your code in order to figure out exactly what is wrong. There are a lot of ways of doing that. Here are a few tips. Now when something goes wrong and no error is actually logged to the console, you can log the different values that might be related to that error to the console in order to test those out. And you can do that using the console.log method. Now the console object is part of the browser API, and it has a method called a log method which can be used to log values and text to the JavaScript console. So here for example, console.log, the string hello I'm JavaScript actually logs this string hello I'm JavaScript to the JavaScript console. And you can use this console.log method to log certain values to the console in order to test them out and make sure that your application is working as expected. Most browsers also have the debugger tool, and this debugger tool can be used to pause the execution of JavaScript and to test your code out in a certain state. So if you want to pause your script in a certain place, in that place in your script you can put in the debugger keyword. You just type in debugger and then a semicolon. And when you load that script inside your web browser, whenever the browser encounters the debugger statement, it'll pause the execution of the script and it'll let you test all the values and code in that specific state, which is very helpful if you're working in big applications and you need to pause the execution in a certain place to test out all the values to make sure everything is working correctly. And that is how you can debug JavaScript code if you encounter some problems or errors. Hello everybody, and welcome back to Expert.js. I'm Abrar, and I'm going to be your instructor for this video. In this video, we're going to be talking about strings. Now, strings are a fundamental part of JavaScript, and you'll be using them a lot in your JavaScript programming. So let's get right to it. First of all, what are strings? Well, in its most basic concept, strings are text enclosed in a pair of quotation marks. So whenever you write a piece of text, a word, a sentence, or pretty much anything, and then at the beginning and at the end of this piece of text, if you put in a pair of quotation marks, then that becomes a string. Here's an example. Okay, so here we have a simple sentence that says JavaScript is fun, then a period. And note that at the beginning and at the end of this sentence, we have put in double quotes. This makes this piece of text a string. And then we end the statement with a semicolon. So this is a JavaScript string. So whenever you write a piece of text and wrap it around in a pair of quotation marks like this, it becomes a string. Strings are just one of the few different data types available in JavaScript. So you might be wondering, well, why do we need to put quotation marks around text anyways? Like, why can't we just write them as is, as we normally do? And there's a very good reason for that. See, in JavaScript and most programming languages, we write strings enclosed in quotation marks so that the programming language can understand and treat the text as strings. Otherwise, it might get mixed up with actual code that needs to be executed in a different way. So if we don't put in the quotes, JavaScript might get confused as to whether we're just writing simple plain text or we're actually referring to some JavaScript code that should be executed in a different style. That's why in order to avoid this confusion, we write simple text enclosed in quotation marks, so they become strings. Now in this first example, we're using double quotes at the start and end of this piece of text, but you can also use single quotes like this. So in this case, we have another sentence that says, I love JavaScript, and then an exclamation mark. And at the beginning and at the end of this piece of string, we have single quotes. So instead of double quotes, we can also use single quotes, and then we end the statement with a semicolon. There's not much difference between single quotes and double quotes. It's mostly a matter of personal preference, but oftentimes you'll see developers using double quotes because that has become an industry standard. But it's also perfectly okay to use single quotes because it really doesn't matter that much and it really comes down to your own preference. Now strings can also contain symbols and languages. We've already seen strings contain letters and punctuation marks, but they can also contain special symbols and even other languages, non-English languages, like we see a few examples here. We have some special symbols and even some Arabic text which is non-English. These are all perfectly valid strings. Finally, sometimes you might come across a code written as new string and then inside parentheses you have the actual string. This actually creates a string object. Whenever you're using the new string syntax, you're actually using the string constructor to create a new string object, which means this way you're actually creating a string object and not a string primitive or a string literal. And this has its own side effects and complications. It's also slower and less effective. So this is not a very good syntax to use. So try to avoid this new string syntax. Instead, just write the piece of text and wrap it around in a pair of quotation marks. This is the string literal syntax and it's much faster and much more effective. So avoid using the new string syntax whenever possible. Now here's a very important thing. We already know that in order to write a string in JavaScript, we need to enclose the text in a pair of quotation marks. But what if the text itself contains quotation marks? Wouldn't that get confused with the actual quotation marks of the string? Well, how do you tackle with that? In this case, we have a simple solution. So if you have quotation marks inside the string itself as part of the string, as in this case we have a sentence that says, I'm a programmer. Now in this case the word I'm actually has single quotes inside it. So if we use single quotes outside the string as well, JavaScript will get confused as to where the string starts and where it actually ends. So in this case, if we're using single quotes inside the string as part of the string, we actually need to use the opposite quotes, as in double quotes outside the string, so JavaScript doesn't get confused. So in this case, if we're writing a sentence like I'm a programmer or pretty much anything that has single quotes inside the string itself, then outside the string we wrap it around using double quotes. The opposite is also true. So if we have double quotes inside the string, in this case we have a piece of text that says, he said I love coding. And I love coding, it's itself in quotation marks, in double quotes. So in this case, we can't use double quotes outside the string. In this case, the string itself contains a pair of double quotes. So you can't use the same double quotes around the string as well. In this case, we need to use single quotes around the string. So whenever we use single quotes inside the string, we use double quotes outside, and vice versa. Now there is a way of using the same quotes inside and outside the string as well. In this case, you can see we're using the same quotes, double quotes, inside and outside the string as well. But in this case, we need to specifically tell JavaScript to escape or otherwise ignore the inside quotation marks. And we do that using the backslash character. So whenever we put a backslash before the quotation marks, as we're doing here, that means JavaScript disregards those at the end of the string, and it kind of escapes those characters, so it skips over them and doesn't treat them as the end of the string. So in this case, we need to put a backslash in front of every single character we need to skip. In this case, we need to skip the double quotes. So we put a backslash in front of the first double quote and at the front of the last double quote as well. And once we've skipped the double quotes inside the string, we can use the same double quotes outside the string as well, and it'll work just fine. Now there are a few other characters that you can escape in JavaScript. For example, the backslash character itself needs to be escaped in JavaScript if you wanted to use it correctly. So in this case, if you want to display one backslash inside the string, then because backslash is a special character, then you actually need to put another backslash in front of it, so double backslashes, in order to escape the backslash and show one backslash in the output string. So in this case, we have a string that says escaping a backslash and then double backslashes in JavaScript. The double backslashes will actually be converted into a single backslash when this string is actually output and processed by JavaScript. So, because backslash is a special character, just like double and single quotes, you need to escape it by putting in another backslash in front of it, effectively creating double backslashes. But the output string will only contain one backslash. Now, similar to the double and single quotes and backslashes, there are a few other characters that you can escape in JavaScript. These characters need to be inputted using the special backslash syntax, otherwise they will not work. Here are some of them. So first we have the null character. If you want to enter the null character, which is actually nothing, you need to put in \0. That's the notation for the null character. Then we have the single quotes. So if you want to put in single quotes inside a string, you need to escape it using the backslash and then the single quotes. And that will actually output a single quote in the outputted string. Then we have the double quotes. So we saw this in the previous example. You need to put in a backslash and then the double quotes. And the output string will only contain the double quote itself. This is how you escape double quotes in JavaScript. And of course, escaping backslashes is effectively putting in double backslashes side by side. And that becomes single backslash in the output string. You also have new line characters. The new line characters are sometimes used for plain text formatting. In this case, you need to put in a backslash and then lowercase n in order to actually input a new line. Similarly, you have backspace, which is \b, and then tab, which is \t, and even a vertical tab, which is \v. And finally, caret return, which is \R. There are a few more of these special characters, but these are the ones that you will be using most often. Now, when you create a string by writing a piece of text and enclosing it in a pair of quotation marks, you are using what's called the string literal syntax. And the string literal syntax actually creates a string primitive. And by definition, primitives can't have properties or methods because they are not objects. Thankfully, when you create a string primitive in JavaScript, JavaScript actually automatically creates an instance of the string object, so your string primitive actually has access to the properties and methods of the string object. Some of these properties and methods we'll look at right now. One of these properties is the length property. The length property will tell you how long a string is. In order to use it, you type in the string and then you type in dot length and then you end the statement with a semicolon. The length property will count all the characters inside the string and will output how many characters are there inside the string. In this case, on the right hand side, as you can see, we have the output in a comment. We'll be using comments like this in order to tell you the output of certain piece of code, or otherwise just tell you how the code works or what it does. In this case, the output is 19. And if you count all the characters, white spaces, and punctuation marks inside the string, you'll see that there actually is 19 characters. So the length property of a string will tell you how long the string is. Strings also have different methods available. In this case, one cool method is the toLowerCase method. The toLowerCase method will actually take a string and output the same string but with all characters in lowercase. So in this case, we have a string that says JS is great, and JS and the G in great are actually capitalized, they're uppercase. But when we use the toLowerCase method by typing in .toLowerCase and then a pair of parentheses, the pair of parentheses is what actually executes the method. Then the output string on the right hand side in the comment, as you can see, it's the same string, JS is great, but all the letters have been turned into lowercase. So JS and G in great have been turned into lowercase. So the toLowerCase method can be used to convert any characters inside a string into lowercase characters. Do remember that JavaScript is case sensitive, so in order to use the toLowerCase method, you have to write it exactly as shown right here, otherwise it might not work. The opposite of the toLowerCase method is the toUpperCase method. The toUpperCase method takes a string and outputs it, but with all letters and characters in uppercase, so they are capitalized. In this case, we have another string that says JS is awesome. And when we use the toUpperCase method, the output string on the comment on the right hand side, as you can see, is the same string, but with all letters are capitalized. So the toUpperCase method is effectively the opposite of the toLowerCase method. Now another cool method is the char_at method. The char_at method can be used to pull out a character from a string. In this case, we have the string YOLO, and then we're typing in .char_at, and then instead of a blank pair of parentheses, inside this parentheses, we actually input the number, the character that we want to pull out. In this case, we have inputted 4, and char_at4 actually returns the character O from the YOLO. So it extracts the O character from the YOLO sentence. But how does this work? You see, whenever you create a string, each character inside the string is actually assigned an index. The index starts at 0 and then goes on to 1, 2, 3, 4, and so on. The first character in a string has the index 0. The second character has the index 1. The third character has the index 2, and so on. So in this case, we have a string YOLO, and index 0 of this string is the first character, which is capital Y. Index 1 is the second character, which is lowercase e. Index 2 is the third character, which is lowercase l, and so on. In this case, the char_at method inside the parentheses accepts the index as its parameter. In this case, we have inputted 4 as the index parameter. And if you start counting from 0 to 4 inside the string, you'll see that you'll end up at the letter O. So this is how you extract a character from a string. If we input a char_at 0, then it will return the uppercase Y. If we had inputted char at 5, it would have outputted the last W. This is how you can extract a certain character using its index from inside a string. Another method using indexes of strings is the slice method. Now, the char at method only extracts one character, but what if you need to extract a portion of a string from inside another string? In this case, we can use the slice method. The slice method, instead of just one parameter, actually accepts two different parameters, and they're separated by a comma inside the parentheses. In this case, the first parameter is the index where the slicing will start, and the second parameter is the index where the slicing will end. And JavaScript will return the resulting piece of string. In this case, we have a string that says apples are red, and we're slicing it from index 7 all the way up to index 10. So if you count from 0 to 7, you'll see that 7 is actually the A in the R. So in the middle word, we have R, and A is the index 7. And index 10 is just after R. After R, we have a white space, and that is index 10. So when we slice from 7 to 10, we slice in the whole R word, and on the output, as you can see on the right-hand side, we have the word R. So this is how you can slice out a part of the string using the slice method. You input the start of the slice as the first parameter, and where it ends as the end parameter. The result is a part of the string has been sliced out. Another cool method is the repeat method. The repeat method can be used to repeat a string again and again and again a specific number of times. In this case, we have a small string that says red, and then we type in dot repeat, and then inside the parentheses, we type in the number of times we need to repeat the string. In this case, we have the parameter 4, and in the output, as you can see, it says red, 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 red. So you can tell JavaScript how many times to repeat a string inside the parentheses of the repeat method, and the output string will repeat this input string the specific number of times. Another cool method of strings is the search method. Now the search method can be used to search for a search term inside a string. In this case, we have a string that says I love coding, and then we're typing in dot search, and inside the parentheses, the search method accepts a parameter. That is the search term that we are searching for. In this case, we're searching for the word love. And in this case, we have the word love inside the string, right? So the output is the index where the search term starts. In this case, we have the string I love coding, and the word love actually starts at index 2 because the first character I is index 0, the second white space is index 1, and then the love L starts at index 2. So the search method can be used to search for a search term inside a string. And if it finds it, it will return the index where it found the search term. In this case, it returns 2, so we know the word love comes in inside the string at index 2. If the search method can't find the search term it's looking for, it will return -1, which will tell you that the search term wasn't found inside the string. Now you can input a string as the parameter inside the search method, but it has its limitations. For example, it's case sensitive, and it can't really search for multiple instances of the same word. Thankfully, you can have more powerful pattern matching and searching using regular expressions. We'll talk more about regular expressions in the later lessons of this course. But for now, you can use the search method and use a string instead. Similar to the search method, we have the replace method, which actually takes in two strings as its parameters, separated by a comma. In this case, the first string is the string that you need to search for, and the second string parameter is the thing that will be replaced with. So in this case, we have a string that says I love cakes, and we're typing in dot replace cakes with chocolates. So JavaScript will search for the word cakes inside the string, and it will replace it with chocolates. So in this case, the output string on the bottom, as you can see, is the output I love chocolates. So in this case, the replace method works similar to the search method. But instead of just telling you whether it found the string or not, you can actually use it to replace the found string with another string. In this case, we have replaced the cakes in I love cakes with the word chocolates. So the output is I love chocolates. The replace method can also accept regular expressions, which can be used for more powerful pattern matching and searching. Another cool method is the trim method. Now, oftentimes you might have white spaces at the beginning and end of a string. In this case, we have a string that says I'm learning JS. But at the beginning and end, we have multiple unnecessary white spaces. Using the trim method, JavaScript will actually trim out these white spaces. So as you can see on the right hand side, we have the same string as output, but all the unnecessary white spaces from the beginning and end of the string has been trimmed out. There's also the trim left method, which only trims out the left portion of the string and not the right hand side. So in this case, we have a string hello, and using the trim left method, as you can see on the right hand side, only the left portion of the hello string has been trimmed out, but all the white spaces in the right hand side is still visible. And the opposite is the trim right method. It does the exact opposite. It trims the white spaces from the right hand side but not the left hand side. So in this case, using the same string, we have the output, but all the left white spaces are preserved while the right white spaces are trimmed out. So you can use the trim left method in order to trim from the left hand side or start of the string, or the trim right method to trim from the right hand side or the end of the string, or use the general trim method to trim from both ends. Now, in the latest version of JavaScript, which is ECMAScript 2017, some new cool methods have been added to strings. One of these is the pad start method. Now, the pad start method can be used to actually take a string and output the string in a certain length. So in this case, we have the string violet. And if you count down all the characters, you'll see that violet actually contains 6 characters. So the length of the string is 6. But you can use the pad start method, and then you can specify the output length of the string, and the output will be the string, but the string will be padded to the specific length. So in this case, we have pad start 10. So inside the parentheses, we specify the length of the string. In this case, we want the string to be of length 10. So we want 10 characters. And JavaScript will actually pad the string in order to achieve the specific length. In this case, we have violet.padStart10. Now, violet itself only contains 6 characters, so its length is 6. But the output length must be 10. In this case, JavaScript puts in extra white spaces at the start of the string in order to output a string with a length 10. But if you input a length that is actually lower than the original length of the string, in this case we have padStart2, which doesn't make sense because 2 is actually lower than the actual string that we have, then it doesn't really do anything. It outputs the string as is. Now the cool thing is that you can actually specify a second parameter inside the padStart method. By default, JavaScript will pad using the white space, but you can also pad using a specific string or other character. In this case, we have the same method, but instead of padding using white spaces, we want to pad using the character A. So we type in padStart10, A. And as you can see on the right hand side, instead of 4 extra white spaces as we had in the first example, we actually have 4 extra A's in order to achieve the 10 total string length. So you can actually specify which character or string JavaScript will use in order to pad the string. Now if you input a padding string that's actually bigger, then only the usable portion will be used. In this case, we have violet padStart9, apple. But the whole word apple is not required because in order to achieve a string length of 9, we only need 3 extra characters. So in this case, JavaScript just uses the first 3 characters in order to achieve the total string length of 9 and then outputs it as is. You can also pad the end of the string using the padEnd method. It works almost the same as the padStart method. So in this case, instead of padding the start of the string, you can pad the end of the string. So padEnd, then inside the parentheses, you input the desired length. In this case, it's 10. And instead of padding the start, it'll actually pad the end. In this case, add 4 white spaces at the end of the string, inputting violet and then 4 white spaces. padEnd3, which is actually lower than the input string length, will output the string as is without any padding. You can also specify which character you'll use for the padding. So by default we use white spaces, but in this case we can use zeros. So pad n 10, 0 actually gives you violet 0, 0, 0, 0. So instead of padding using white spaces, it pads using the character 0. And of course, if the pad string is bigger than required, it'll just use the portion it needs. So pad n9, purple, actually uses the first three characters, violet, then per. Hello everybody, and welcome back to Expert.js. My name's Abrar, and I'm going to be your instructor for this video. In this video, we're going to be talking about numbers. Just like strings, numbers are a fundamental data type in JavaScript. So let's get right to it. So first of all, what are numbers? Well, unlike strings that we just learned, numbers are written as is, with or without decimals. So in order to write a number in JavaScript, you just write it as is. In this case, we have the number 1, 2, 3, and then we end the statement with a semicolon. We don't need to put in quotation marks or anything like that around it. We just write the number as we usually would. In this case, we have a whole number because we don't have decimals. It's just 1, 2, 3, which is an integer in JavaScript. You can also use decimals. So in this case, we have 253.87. And this is a decimal or a fraction number, which in JavaScript is described as a floating point number. Now, just like strings, you might see a number created using the new number syntax. But again, this uses the number constructor in order to create a number object and not a number primitive. You don't need to use this method because just like the new string method, it's not effective, it's not faster, and it's not efficient. It also has various side effects. And because JavaScript automatically gives you access to all the properties and methods of numbers, you don't need to create a new number object. So avoid using this syntax, as almost always it's a bad practice. In JavaScript, we also have scientific notation. So 45e4 actually means 45 multiplied by 10 to the fourth power. In this case, it's 450000. So, unlike strings, you write numbers in JavaScript as is. Don't put in quotation marks around numbers, because otherwise JavaScript will actually treat them as strings and not numbers. Now at this point, you might be thinking, well, we can write numbers inside strings as well, right? Then why do we need a different numbers data type? And that's because the numbers written as strings are actually treated as strings and not numbers, which means the different methods available to numbers are not available to numbers written as strings. Also, certain mathematical operations can be done with numbers written as strings. They can only be done on the numbers data type, and that's why we need numbers. Now, JavaScript can also have negative numbers. In order to write a negative number, you just put in a minus symbol in front of it. So minus 5 creates a negative number. JavaScript also has the word infinity. The keyword infinity is what returned when the result calculation returns infinity. For example, if you divide a number by 0, infinity is what JavaScript will return, and infinity is also a number. You can use the typeof operator in order to find out the data type of a certain value. In this case, if you type in typeof and then 1, 2, 3, 4, 5, but enclosed in quotation marks, as you can see on the right hand side, it outputs a string because it's actually a string. Although we have 1, 2, 3, 4, 5, because we have quotation marks around it, it's actually regarded as a string. But if you type in typeof 1, 2, 3, 4 without quotation marks, then JavaScript outputs number because this is a numbers data type. There's also the special keyword nan. N-A-N stands for not a number, and this is what JavaScript will output if the calculation results in not a number or the calculation is not valid. You'll see more examples of nan returned in later lessons. Now, JavaScript numbers are actually only accurate up to a certain digit. In this case, normally JavaScript numbers are accurate up to 15 digits. So if you put in 99999 up to 15 nines side by side, it's regarded accurately. But if you put in 16 nines side by side, JavaScript actually rounds it up into 100000. So be careful with that. Now, just like strings, when you write a number as is, you're using the number literal syntax and it creates a number primitive. And number primitives can't have properties or methods because they're not objects. But just like with strings, when you create a number primitive, JavaScript automatically creates an instance of the number object, and the number primitive inherits all the properties and methods of the number object. So you have a lot of properties and methods available to numbers. Let's take a look at a few of them. First, here are some numbers you can use when working with decimals. The first method is the toFixed method. Now, the toFixed method can be used to take a number and actually output it with a specific number of decimals. In this case, we have the number 3.4 and we use the toFixed method. And inside the parentheses, we tell JavaScript the length of the decimals, in this case 4. And JavaScript will return the number as a string, but with the specific number of decimals. In this case, 3.4 gets turned into 3.4000. So we actually have 4 digits after the decimal, because JavaScript padded the number in order to include 4 digits after the decimal. Similar to the toFixed method, you have the toExponential method. The toExponential method also accepts a parameter, which is the length of the digits after the decimal, but it also uses a scientific notation along with it. So in this case, 4.27 to exponential 5 returns the number as a string, but with 4.27000. So after the decimal, we have 5 digits, but then we have e plus 0. So it uses the exponential or scientific notation, and also at the same time allows you to specify the number of digits after the decimal. We also have the toPrecision method, which takes in a number and it can be used to specify the exact length of the total number. In this case, toPrecision2 is the total length of the number we want. So 5.74, which actually has 3 digits, but if we use the toPrecision2, we have returning string, which is 5.8. So 5.78 has been rounded up into 5.8 because 5.8 has 2 digits, which is what we specified in the toPrecision method. Do note that these methods actually turn the number into a string. So if you want to use the output of these methods as numbers for different calculations, you need to convert them into numbers again. Now there are a few methods of the number object itself as well. One of them is the isFinite method. The isFinite method will tell you whether a number is finite or not. In this case, you use the method by writing in number.isFinite, and inside the parentheses, you type in the number you want to test. In this case, 17 is definitely a finite number, so isFinite returns true, as you can see on the right hand side. But if we type in isFinite and then 45 divided by 0, which is infinity, then isFinite returns false because a number divided by 0 is infinity, which is not finite. We also have the isInteger method. The isInteger method will tell you whether the number is an integer or not. In this case, isInteger 67.247 is definitely not an integer because it has a decimal or a fraction. So in this case, it returns false. We also have the isNaN method. The isNaN method can be used to check whether a number is nan or not. In this case, isNaN nan almost returns true, but isNaN a certain number would return false. So in this case, we have isNaN 45, and because 45 is definitely a number, isNaN returns false. There are some properties available of the number object as well. One of them is the max value property. So number.maxValue will tell you the absolute maximum value JavaScript can normally work with. And it's a very, very big number, as you can see on the right hand side. We also have the min value, which is the lowest positive value JavaScript can work with. and it's a very, very small positive value, as you can see on the right hand side. Now oftentimes you might have a number as a string. So in this case, let's say we have a number 34, but it's actually wrapped around in a pair of quotation marks. How do we convert this string into a number? So how do we convert the 34 string into the 34 number? In this case, we can use a method called parse float. The parse float method can be used to convert a string into a number. In this case, inside the parentheses, we input the string we need to convert. In this case, we input 34, the string. And on the output, as you can see on the right hand side, it actually outputs 34, but without the quotation marks, which means it's been converted into a number. Parse float can also accept decimals. In fact, the parse float method is actually used for decimals. So 4.87, the string, actually returns 4.87, the number, using the parse float method. Now, if you input a string that's not actually a number, in this case we have inputted parse float boat, then JavaScript can convert boat into a number. So it just outputs nan. So it's just one of the examples where JavaScript outputs nan because it's not a number, because the operation is invalid. JavaScript can convert boat into any number. There's also the parse int method, which actually gives you an integer. Now, it's a bit less flexible and complex than the parse float method, but it has its own uses. The parse int method actually accepts two parameters. The first one is the string you want to convert into an integer, and the second is the base you'll use. Now, there are a lot of bases used in computer programming. The most common one we use is base 10. Base 10 uses numbers from 0 to 9, and this is the normal number we humans use. So in this case, you can input parse int for the string, comma 10, and it'll use the base 10, which is the normal human numbers, in order to output the 4 string as the 4 number. Now the parse int method can't work with decimals. So in this case, unlike the parse float method, if we type in 35.7, the output number is only 35, so the 0.7 has been completely ignored. So the parse int method only outputs integers and not floating point or decimal numbers. Now, as I said, the last parameter can be used to define the base. In this case, normal humans use base 10, but computers use binary or base 2. And if you have a number which is a binary string, you can actually convert it into a number using the base 2. In this case, we have parse int, and inside the string we have 101, which is a binary number as a string. And using base 2, we have the output 5. 101 in binary is actually 5 in human base 10. So you can use the parse int method in order to actually convert a string into a number with a different base, something other than base 10, like base 2 or base 16. Hello everybody, and welcome back to Expert.js. I'm Abrar, and I'm going to be your instructor for this video. In this video, we're going to be talking about booleans. Now, just like numbers and strings, booleans are another fundamental data type in JavaScript. So let's get right to it. So first of all, what are booleans? Like, we've learned numbers and we've learned about strings. Booleans are the other fundamental data type in JavaScript. Now, unlike numbers or strings, booleans can only have one of two values, true or false. So if you type in true just like that, as is, without any strings or anything, then you've created a boolean. Now, just by typing in true and semicolon, this is actually a boolean. Similarly, you have false, which you can create by typing in false and then semicolon, and that's as a false boolean. Now, you might be wondering, well, we have numbers, okay, we have numbers, and then we have strings, but why do we need booleans? Like, why do we even need true or false? As you'll see in later lessons, booleans actually have a very, very important use in JavaScript, because you'll often need true or false confirmations in conditionals and in loops. Now, in JavaScript, the values 0, -0, null undefined, nan, and empty string are false, and every other type of values are true. Now, when you're creating a boolean, remember to type in the keyword true or false as is. We don't need any quotation marks around them, because if we write quotation marks, they'll actually become a string and they'll not be booleans. So in this case, in order to create a boolean, you just type in true or false. Now, just like with strings and numbers, sometimes you might see booleans created using the new boolean syntax. And just like strings and numbers, this is not a very good practice, and you shouldn't use it most of the time, because the new boolean method actually creates a boolean object. So by typing in new boolean and then inside parentheses true or false does create a boolean, but it creates a boolean object and not a boolean primitive, and it has its own side effects. So it's better not to use the new boolean syntax and just use the traditional literal syntax where you just write in true or false. Now, if you have a value, you can actually evaluate it whether it's true or false. In other words, you can convert a value into a boolean. You can do that using the boolean method. Now, previously we said that 0, minus 0, null, undefined, nan, and empty strings are false values. You can verify that by using the boolean method. So in this case, you just type in boolean. Remember, don't type in new, because new will actually create a boolean object. So it's not new boolean, it's just boolean, and then inside the parentheses, you type in the value you want to convert to a boolean. In this case, we have boolean 0, which outputs false, because 0 is regarded as false in JavaScript. Negative 0 or minus 0 is also false. Similarly, boolean null is also false, and boolean undefined is false. Boolean nan is false as well. And finally, an empty string, which is just a pair of quotes without any content, is actually false in a boolean context. And all other values except the ones that we just mentioned are true. So in this case, boolean, a string, any string, in fact, ABC, XYZ, 1, 2, 3, any string evaluates to true. Any number also evaluates to true. In this case, boolean 675, or any number, in fact, evaluates to true. And of course, boolean true will always evaluate to true as well. So except for the ones that we just mentioned, all other general values are true in a boolean context. Now, you'll learn much more about booleans and how they're used when we get to more advanced topics like conditionals and loops. But for now, just know that there's a data type in JavaScript called booleans, and it can only take in the value either true or false. Hi there, and welcome back to another video of Expert.js. My name's Abrar, and I'm going to be your instructor for this video. In this video, we're going to be talking about arithmetic operators. Now, mathematics and arithmetic operations in general are often done in programming, including JavaScript programming. So let's see how they work. Now, in order to do basic mathematics like addition, subtraction, multiplication, and division, JavaScript provides some basic arithmetic operators. Here's a list of a few of them. So first, we have the addition operator, which is a plus. This addition operator adds operands together, just like in basic math. And then we have the subtraction operator, which is the minus symbol. It minuses operands from one another. Then we have the multiplication operator. This is actually written as an asterisk in JavaScript. The multiplication operator multiplies the operands. And of course, we have the division operator, which divides the first operand by the second one. It is written using the forward slash. Now, addition, subtraction, multiplication, and division are the four basic arithmetic operators, but there are a few more of them in JavaScript as well. For example, We also have the modulus, which returns the remainder after a division. And we also have the exponent, which raises a value to a power. It is written using the double asterisk symbol. And we have double plus, which is increment, which increases a value by 1. And the opposite, we have double minus or decrement, which decreases a value by 1. Now let's see some real-life examples of basic arithmetic in JavaScript. We'll start with some simple examples. So first, let's take a look at simple addition. So 1 plus 2 equals 3, right? It's basic math. We're using the plus operator or addition operator in order to add 1 to 2, getting the result 3, as you can see on the right-hand side. We also have subtraction. For example, 9 minus 3 equals 6. Similarly, we have multiplication. So 5 multiplied by 4 or 5 asterisk 4 equals 20. And of course, division. So 30 divided by 12 equals 2.5. We write the division symbol using the forward slash. And of course, we have exponents. So 3 double asterisk 2 actually means 3 square, or 3 raised to the second power, or 3 to the power 2. So 3 square equals 9. So that's how you can do exponent-based calculations in JavaScript. And of course, we also have modulus. So 40 modulus 6 equals 4. How does this work? Well, first we divide 40 by 6. As you can see, 40 divided by 6 does not result in a whole number. The biggest that we can get is 6 into 6, which is 36. So 36, when minus from 40, gives us 4. So after division, 4 is what's remained, and that's the result of this modulus calculation. Now, if you know basic math, you might be familiar with the order of operations. Basically, if we have multiple operations side by side, then there's a certain order in basic mathematics. In order of operations, when you have multiple operations side by side, you first do the division ones. Then you move on to the multiplication ones. And then you do the subtraction and addition. This is the order of operations in mathematics. And of course, you have parentheses, and calculations inside parentheses are executed before any of these. JavaScript also follows these order of operations. So for example, if we have 1 plus 3 into 6 divided by 3, then we get the result 7. So here, the division, which is 6 divided by 3, is calculated first. So 6 divided by 3 equals 2. Then the multiplication, so 3 into 2 equals 6. And finally, the addition, 1 plus 6 equals 7. Of course, you can change the order of operations using parentheses. So in this case, if you want the addition to be specifically executed first, then you can put parentheses around them. In this case, the result changes from 7 to 8 because now we don't start with the division, but we start with the addition because that is in parentheses. So anything that's inside the parentheses is executed first. So 1 plus 3 is executed first. 1 plus 3 gives us 4. And then the division is executed. 6 divided by 3 gives us 2. And 4 into 2 equals 8. Now in basic mathematics, you have the normal parentheses, but you also have other type of brackets, such as the curly braces and square brackets. In JavaScript, you don't need to use curly braces or square brackets. You can actually nest the same parentheses one inside the other. For example, you can do something like this. So in this case, we're telling JavaScript to specifically execute 3 into 6 first because that's the innermost parentheses. Then it'll calculate 1 plus whatever is left over from 3 into 6. And finally, it'll divide it by 3. So in this case, 3 into 6 is executed at the very first. So 3 into 6 gives us 18. And 18 plus 1 gives us 19. And finally, 19 divided by 3 gives us 6.333, and so on. So in this case, you can nest parentheses inside another, and the deepest nested parentheses will be executed first, and then the execution will move up the parentheses chain. Now in basic mathematics, we only work with numbers, right? But in JavaScript, we can also do certain calculations with strings. So let's take a look at a few of them. So in this case, we have a string ABC, and we're adding it to the string XYZ. This is very similar to adding numbers. We can type in 1 plus 2 and it returns 3. But we can also use strings, ABC plus or added to XYZ. So these are two strings and we're adding them together. In real-world mathematics, this doesn't make any sense, but in JavaScript, this is a perfectly valid operation. In this case, whenever you add a string to another string, JavaScript just adds these two strings together. This is called concatenation in programming. And the result of this on the right-hand side, as you can see, is a string returned ABCXYZ. So JavaScript basically takes the two strings side by side and adds them together. This is how you can concat strings in JavaScript. Now what if you add a string to a number? In this case, we have a string ABC and we're adding it to a number 12. Now again, in real life, this doesn't make any sense. But in JavaScript, when you add a string to a number, JavaScript actually automatically converts the number into a string. So in this case, ABC plus 12 is treated as ABC plus 12 in strings. So when strings are added together, JavaScript just adds them side by side. So in this case, ABC plus 12 equals ABC12, the whole string together, as you can see on the right hand side. So whenever you add strings with numbers, the numbers are automatically converted into strings and concatenated together. Now of course, not every operation is valid with strings and numbers. For example, you can't minus a number from a string. In this case, we have a string that says ABC minus 9. Now, this doesn't even make any sense, even in JavaScript, and that's why it returns nan, which is not a number, meaning the operation is not valid. So you can't minus a number from a string. You also can't minus a string from a string. It doesn't make any sense as well. So the string ABC minus the string XYZ doesn't make any sense. And it also results in nan, means not a number. The operation is invalid. Now here's a very important thing to remember. When you're adding numbers together, you have to make sure that both of the numbers are actually in number form and not strings. Because if the numbers are actually in string forms, then they won't be added together, but they'll just be concatenated side by side. So in this case, we have two numbers, 2 plus 6, but both of them are strings. Because 2 and 6 are strings, JavaScript treats them as strings. So just like ABC plus XYZ results in ABCXYZ, similarly, 2 plus 6, because both of them are strings, results in 26, and not 2 plus 6 equals 8. So in this case, you have to be careful with JavaScript, because if your numbers are actually in string form, then they will just be concatenated side by side. So 2 plus 6 won't return 8, but 2 plus 6 will actually return 26. We'll see how to solve this in just a minute. But before that, let's take a look at another thing. Sometimes, the strings are actually converted into numbers and not the other way around. So we just saw that ABC plus 12, in this case, when you add a string to a number, the number is automatically converted into a string. But in this example, we have 5 the string minus 7. In this case, because we're minusing 7 from 5 the string, the 5 is actually converted into a number. In this case, When 5 is converted into a number, 5 minus 7 gives us the actual result minus 2. Now that's about strings and numbers, but you can also do mathematical operations with booleans. In JavaScript, boolean true holds a numerical value of 1 and boolean false in a numerical context holds a value 0, and you can actually use it in mathematical operations. You won't be using it that much in real life programming, but it's fun to know. So for example, true plus true is actually 2 because true in a numerical context is treated as 1. So true plus 2 is the same as 1 plus 1, which results in 2. Also, false is 0. So false minus false results in 0 because false minus false means 0 minus 0, which equals 0. True minus false, which is 1 minus 0, results in 1. And of course, false minus true, which is 0 minus 1, results in minus 1. Now, as you just saw, if you're trying to do mathematical calculations, but your numbers are actually in string form, so they're numbers written as strings and not numbers data type themselves, then it might cause problems. The calculations might not work correctly. JavaScript might try to convert strings into numbers or vice versa, but that is not always reliable. So in this case, it's just better to convert the data type yourself, so the calculation always produces predictable results. You can do this in many ways. Now here we have 2, the number, plus 2, the string. Now because we have a string, JavaScript automatically converts the first 2 number into a string as well. So we have 2 plus 2, which should result in 4, but because JavaScript converts the first number into a string, the strings are just concatenated together, producing the string 22 and not the number 4. You can solve this by using the parseFloat method. It works like this. You can use the parseFloat method in order to convert a numerical string into a number. So in this case, we have parseFloat, and inside the parentheses, we input the string we want to convert into a number. And that string will be converted into its appropriate number. In this case, we have parseFloat 6 plus 4. Now, using the parseFloat method, the 6 string is actually converted into the 6 number. So 6 plus 4 results in the accurate value 10. Otherwise, 6 plus 4 would result in the string 64 because they'd be concatenated together. But using the parseFloat method, we convert 6 the string to 6 a number, and 6 plus 4 then results in 10. You can also use the number method. The number method can be used to convert strings into numbers as well. It works very similarly to the parseFloat method. You just type in number, and then inside the parentheses, you input the string number as a parameter. In this case, we have 56.2. And it converts the string 56.2 into the number 56.2. And when you add 4 to it, it results in 60.2 and not 56.24. This is how you can convert strings into numbers so your calculations actually produce the accurate and right result. Hello everybody, and welcome back to Expert.js. I'm Abrar, and I'm going to be your instructor for this video. In this video, we're going to be talking about the JavaScript's math object. So let's get right to it. Now first of all, what is the math object? Now in the previous video, we talked about basic mathematical operations such as addition, subtraction, multiplication, division, and much more. And while these are great, oftentimes you'll need to work with much more complex mathematical calculations in JavaScript. Sometimes you might be required to use advanced mathematics in JavaScript. Thankfully, JavaScript has the math object, which provides a lot of properties and methods that make advanced mathematical calculations a lot easier and more convenient. The math object has a lot of properties and methods. Let's take a look at a few of the properties of it. First, we have some properties. Now, the math object properties are often constants that the math object provides. For example, math.e provides us with the Euler's number, which is approximately 2.718. In advanced mathematics, you might often use the Euler's number for different calculations. In this case, instead of writing out the number manually, you can just use math.e and it'll automatically give you the Euler's number. Similarly, we also have math.pi. Now, pi in mathematics is the ratio of a circle's circumference to its diameter. And in this case, math.pi returns the pi value, which is approximately 3.1416. So, just like the Euler's number, instead of manually typing it out every time, 3.1416, you can just use math.pi. Math also has the square root of 2. So often in mathematics, you'll use the value square root of 2. And instead of again writing it down manually, you can just use math.sqrt2. This means square root 2, which is approximately 1.414. Math also provides the square root of 1 divided by 2, another constant that's often used in mathematics, and you can access it using math.sqrt1_2. That's math square root of 2, which is approximately 0.707, and so on. Now, the real power of the math object is in its methods. It has a lot of methods. We won't be looking at every single one of them, but here are the most important and most frequently used ones. First, one of the most common things you'll do in JavaScript is rounding up numbers. And you can do that using the math.round method. The math.round method takes a value as its parameter and it converts it or rounds it up into an integer. So in this case, math.round 3.57, which is a floating point number or a decimal fraction number, you can round it up into a nearest integer. So in this case, 3.57 results in the integer 4 because 3.57 is rounded up to 4. Now, of course, the math.round method follows the basic mathematical rules of rounding numbers. So in this case, we have 56.2 and it's not rounded up, but it's actually rounded down to 56. So in this case, if the decimal is anywhere from 0 to 4, it's rounded down, and if it's 5 or more, so from 5 to 9, it's rounded up. That's why 3.57 is rounded up to 4, while 56.2 is rounded down to 56. Now, of course, sometimes you might explicitly want to round up numbers. In this case, JavaScript provides the math.ceil method. The ceil method will always round up the numbers up to the highest integer. So in this case, 5.2 results in 6. But using math.round, 5.2 would result in 5. But the ceil method always rounds the numbers up to the nearest integer. So in this case, 5.2 results in 6. Similarly, math.ceil 6.89 results in 7. Now the opposite is the floor method, which always explicitly rounds down the numbers. So in this case, math.floor 42.7 results in 42, and math.floor 10.02 of course results in 10. So while 47.2 using the normal round method would have resulted in 43, but with math.floor we always go to the nearest last integer. So in this case, 42.7 is rounded down always to 42. Now, another cool thing that you'll often do in JavaScript is generating random numbers. Generating random numbers might be required to solve a particular problem or might be required for some applications. In this case, JavaScript provides the math.random function. The math.random function can be used to calculate a random value between 0 all the way up to but not including 1. So in this case, math.random provides a random value each time you call it. So in this case, the example value might be 0.625844 and so on. Remember, the math.random function will always return a value that's between 0 inclusive and 1 exclusive. That means at the very least it will be 0 and it'll go up all the way up to 1 but not including 1. Now generating a random number between 0 and 1 is pretty cool, but it's not very flexible. Thankfully, you can actually modify the random method a bit in order to suit your needs. For example, you can use math.floor and then inside its parentheses you can type in math.random into 10. This actually generates a random integer between 0 and 10. So how does this work? In this case, we're using math.random, which results in a random number between 0 and 1. So it's basically a fraction. But then we are multiplying it by 10. So we're basically turning a random number from 0 to 1 to a random number from 0 to 10 because we are multiplying it by 10. Finally, we're using the math floor function in order to floor this calculation to the nearest integer. The result being that we get a function that we can use in order to generate a random number between 0 and 10. The lowest will be 0 and the highest will be 9. So this is how you can generate a random integer between 0 inclusive and 10 exclusive. You can also use the same strategy in order to generate a random integer between 0 and 100. In this case, instead of math.random into 10, you just type in math.random into 100. And then when you floor the result of this calculation, you get a random integer between 0 inclusive and 100 exclusive. So the lowest it will be 0 and highest it'll go all the way up to but not including 100. So it'll be a random number between 0 and 99. Now oftentimes you might be given a list of values, a list of numbers perhaps, and you need to find the smallest and largest of these values. The math object provides the math.min and math.max functions for this exact purpose. So the math.min function can be used to find the smallest value amongst a list of specified values. So in this case, you type in math.min and then inside the parentheses, you define the list of values, the list of numbers separated by a comma. Each of these are actually parameters of the min function. So in this case, we type in 5, 6, 2, and 9. And of course, we know that amongst this, 2 is the lowest. So in this case, math.min will return 2. Another example, we have math.min, but this time we have 3, 1200, minus 67.3, and 56. In this case, negative numbers are always the smallest. So in this case, math.min function gives us minus 67.3 as the smallest value. Of course, the opposite of the min function is the max function, which can be used to find the maximum or the largest value amongst a given set. So in this case, math.max 45, 2.3, and 77 of course results in 77 because amongst this, 77 is the largest. And of course, if you have all negative numbers, then the largest one will be the one that's closest to 0. So in this case, math.max minus 3, minus 4.5, and minus 8 gives us minus 3 as the largest value because that is closest to 0 and is the maximum largest value. Of course, there are a few other cool functions of the math object as well. One of these is the math.abs method. The math.abs method gives you the absolute value of a number. So in this case, math.abs minus 5.6 gives us the absolute value of 5.6, which will be the positive version, 5.6. Of course, math.abs 0 results in 0. And we also have the sign method. The math.sign method can be used to test whether a number is negative or positive. In this case, if it's positive, it returns 1. So math.sign 34, which is a positive number, it results in 1, indicating that the number is positive. Of course, if we input a negative number, such as math.sign minus 9.7 or any negative number, it results in minus 1, telling us that that number is a negative number. And math.sign 0 returns 1. So the sign method can be used to tell whether a number is negative or positive depending on the outcome, whether it's 1 or minus 1. We also have the trunc or trunc method. Math.trunc method can be used to slice out the decimal portion of a number and give you only the integer part. So in this case, math.trunc 237.68 trunks out the 0.68 portion and only gives you the integer portion, so 237. So it basically gets rid of the decimal portion or everything after the decimal point. If you use it on a negative number, it works as expected as well. So math.trunc minus 3.59 results in minus 3. The decimal portion is removed. Now let's take a look at more complex mathematical calculations. For example, calculating square and cube roots. You can do that using the dedicated math.sqrt method. The math.sqrt method gives you the square root of a number. So in this case, math.sqrt, and then inside the parentheses 4, so you're trying to calculate the square root of 4, gives us 2. Because of course, 2 square is 4 and the square root of 4 is 2. The math.square root of 2 results in the square root of 2, which is 1.4142, and so on. Now negative numbers doesn't have a square root. So in this case, math.square root minus 67 results in nan because it's not a number. The operation is not valid. Similar to the square roots, we also have cube roots. So in this case, math.cbrt, which is cube root, gives you the cube root of a number. So math.cbrt 8 gives us 2 because 2 to the third power is 8 and the cubic root of 8 is 2. Now of course, negative numbers can have cubic roots. So in this case, math.cubic root minus 27 results in 3. And math.cubic root 0 results in 0. Now let's talk about calculating powers and exponents. MathObject again provides some dedicated methods for this purpose. For example, we have math.pow method, which is the power of method. The first parameter in the power of method is the base, and the second parameter is the exponent. You can use the power of method to calculate powers and exponents. So for example, math.pow 4 and 2, which means 4 to the second power or 4 squared results in 16. Remember, the first parameter is the base and the second parameter is the exponent. So math.pow 4, 2 results in 4 squared or 16. Of course, we can also use negative numbers. For example, math.power of minus 4, 4, which means minus 4 to the fourth power results in 256. Because negative numbers, when raised to an even power, results in a positive number. Now, of course, we can also calculate cubes. So for example, math.pow minus 2, 3, which means minus 2 to the third power or minus 2 cube results in minus 8. Odd powers of negative bases results in negative numbers. That's why minus 2 cube results in minus 8. Now here's the thing to remember. In JavaScript, you can't really calculate fractional exponent powers. So for example, math.pow minus 8 to the 1.5 power results in nan. JavaScript can't really calculate minus 8 to the 1.5 power. We also have the exp method. In the exp method, the parameter you provide will be the exponent and the base will always be the Euler's number. So you can use the exp method to calculate a power of the Euler's number in quick and easy fashion. So for example, math.exp3 means the Euler's number to the power 3. So it's e cubed, which results in 20.0855 and so on. You can also use negative powers. So math.exp minus 2 means Euler's number to the power minus 2, which results in 0.1353. Finally, you might want to calculate logarithms in some cases. Again, the math object also provides some dedicated, very helpful methods for this purpose. First, we have the math.log function. This calculates the natural logarithm, meaning the base is the Euler's number, or e. So math.log 35 means the base is the Euler's number, and we're calculating the logarithm of the number 35, which results in approximately 3.555. You can also have different bases. For example, math.log 2 has 2 as its base instead of the Euler's number. So in this case, math.log 2, 10 gives us a logarithm with base 2, and we're calculating the logarithm of 10. So the base 2 logarithm of 10 is 3.321, and so on. We also have logarithms with base 10. So, for example, math.log 10, 62 calculates the logarithm of 62, but with logarithm base 10, which is also called the common logarithm. In this case, it results in 1.792, and so on. Hi there, and welcome back to another video of Expert.js. My name's Abrar, and I'm going to be your instructor for this video. In this video, we're going to be talking about variables. Now, variables are an important part of JavaScript, so it's essential you know what they are and how they work. So let's get right to it. First of all, what are variables? Variables in JavaScript are containers that you can use to store values. You can think of variables as boxes where you can store and save a certain value and reference it later on. In order to create a variable in JavaScript, you need to declare it, and you do that using the var keyword. So you type in var and then you type in the variable name. In this case, we're going to be calling the variable x. So in order to create a variable named x in JavaScript, we type in var x. And now a variable named x exists in JavaScript. You can access the value of a variable by just typing in the name. So because we have created a variable named x, now we can type in x and we can access the value of it. But we just created this variable. We haven't assigned a value to it yet. That's why the value of this is currently undefined. So let's assign a value to it and let's see what happens. This is how we assign a value to a variable. You type in the variable name, and with an equal sign, you type in the value you want to assign to this variable, and the variable will store this value. In this case, we want the variable x to equal to the number 5. That's why we type in x equals 5. And after the statement is executed, the value of x has changed from undefined to 5. So let's double check that. Now, if we type in x again, in order to access the value of this variable, we get 5 instead of undefined, because we have assigned the number 5 as the value to this variable. So now x equals 5. Now you can also declare a variable and assign it a value on the spot as well. In this case, we're creating another variable y. And instead of just declaring a variable in one statement and then assigning it a value in another one, we're directly assigning a value to it in the same statement we're declaring it. And you do that using this syntax, where you type in var and then you type in the variable name. In this case, we're calling it variable y equals the value. So in this case, instead of assigning it a number, we're assigning it a string. So in this case, variable y equals the string blue. And now, if we type in y in order to access the value of this variable, we get the string blue in return. You might notice that variables in JavaScript are very similar to variables in basic algebra, and that is correct. In algebra, we use different variables such as x, y, and z, or a, b, and c, and we assign different values to them so we can work with a lot more complex expressions in a lot simpler way. Variables in JavaScript work kind of the same way. You declare a variable and then you assign a value to it so that you can reuse that value later on. Now let's take a closer look at the syntax of how you declare variables. We already saw that you can declare a variable by typing in var followed by the name of the variable, and optionally also giving it a value in the same statement. But you can also declare multiple variables and the same statement as well. In this case, instead of creating just one variable in one statement, we're creating three different variables in a single statement. In this case, the variable names are separated by a comma. So in this case, var x, var y, and var z are three variables that we are creating. And the variable z, we're assigning it a value that's true. So z equals true. So variables can not only hold numbers or strings, they can hold booleans and even other more complex objects as well. In this case, variable z equals true. However, variable x and y are still undefined because we haven't explicitly assigned any value to them. We've just declared them. So in this case, we have declared variable x, which is undefined, variable y, which is undefined, and variable z, which we've assigned a value true. In this case, we declare another set of variables. The first variable is color, so we declare var color and we instantly assign it a value, the string red. Then we declare another variable, year, and we assign it the number 2018. And finally, we declare another variable named city. We don't assign it any value, so its value is currently undefined. So using this syntax, we can declare multiple variables and assign different value to them. So here we have declared the variable color with the value red, variable year with the value 2018, and a variable city with no defined value. So its value is undefined. And of course, you can double check the value of a variable anytime by typing in the name. In this case, typing in color gives us the string red because that's the value we assigned it. Typing in year gives us the number 2018 because that's the value we assigned it in the previous statement. And typing in its city gives us the value undefined because we haven't assigned a value to the variable city yet. Now, global variables are variables that you declare outside a function. We'll talk more about functions later, but for now, just know that global variables are actually properties of the window object inside a browser. So in this case, if we create a global variable such as var x and we give it a value, let's say 4.5 or any valid value for example, then of course we can access and reference this variable by its name. So if we type in x, we can actually access the value 4.5. But that's not the only way. Whenever you create a variable, it actually becomes a property of the global object. Inside the browser, this global object is the window object. So variable x is actually a property of the window object, and you can actually access it like this. So window.x also gives us 4.5 because window.x is the same as the variable x. Whenever we declare a variable in the global scope, it becomes a property of the global object. Inside the browser, this global object is the window object, and x, the variable, becomes a property of it. Now let's talk more about variable values. Now we've only seen some simple examples here. For example, we've seen variables contain values that are numbers, that are string, that are booleans. But they can contain much more complex values and expressions as well. So in this case, let's start with the simple variable a equals 10. So we're declaring a variable named a and we're assigning it the value, the number 10. And let's create another variable, variable b, and assign it the value 7. Now, just like you can use the arithmetic operators on numbers and strings in order to do mathematical calculations and concatenations, you can actually use variables in place of the numbers and strings as well. So in this case, typing in 10 plus 7 would give us the result 17. And the same result can be achieved by typing in a plus b, because a equals 10 and b equals 7. So this works just like basic algebra. In algebra, we have different variables with different values, and we can use the variables in an expression, such as a plus b. The same thing works in JavaScript. So because we have two variables, a and b, with values 10 and 7 respectively, we can use and refer to these variables instead of the numbers themselves in any expression in JavaScript. So a plus b is the same as 10 plus 7, which gives us the result 17. Of course, other arithmetic operators work as well. So b multiplied by a, which is b asterisk a, means 10 asterisk 7. 10 multiplied by 7 is 70, and that's the result we get. Now you can also declare a variable, and instead of assigning it a simple value, you can assign it an expression. So in this case, we're declaring a variable, variable c, and instead of assigning it a straight value, we are assigning it an expression, and that is a minus b. Now a minus b equals 10 minus 7, which is 3. So whenever JavaScript executes this statement, it assigns the value 3 to the variable c, because it executes a minus b, and a minus b returns 3, and that's the value variable c will have. And now, if we type in c in order to access its value, we get the value 3, because c equals a minus b, and a minus b equals 10 minus 7, and 10 minus 7 equals 3. So c equals 3. Now there are a few rules you have to follow when naming the variables. For example, variable names are case sensitive. So in this case, if we have a variable named car and we assign it the string Tesla, then we can refer to this variable by, of course, typing in the variable name car, and it'll give us the value Tesla. However, because variable names are case sensitive, any variation of the case of the variable name will not work. So for example, all these variable names will throw a reference error. So car with a capital C doesn't work, car with all letters capitalized doesn't work, or with any single or multiple letters capitalized doesn't work as well. These are all different variables. And because these variables are not declared in our script, it throws a reference error. So when you declare a variable, you have to be careful with the name, because in order to access and refer to that variable, you must type in the name exactly as is. Changing the case won't work because variable names are case sensitive. Now there are a few rules when it comes to naming variables. For example, a variable can only contain numbers, letters, the dollar sign, and the underscore. Furthermore, a variable name can only start with the letter, the dollar sign, and the underscore, but not a number. So in this case, the variable named hello is a valid variable name. Variable named O2 is valid as well, because although it contains a number, it starts with a letter. So variable names can contain numbers, but it must start with the letter, underscore, or the dollar sign. Now variable $sky is also a valid variable name, and so is underscore clouds. These are all valid identifiers in JavaScript. Now, although these are valid variable names, you should avoid starting variable names with a dollar sign, because a lot of JavaScript libraries use this convention, and it can mess things up and confuse people. So it's better not to start variable names with a dollar sign or an underscore. And here are some examples of invalid identifiers. For example, variable 2n is an invalid identifier because the name 2n starts with a number 2, and variable names can't start with a number. It must start with a letter, underscore, or dollar sign. So variable 2n is invalid. Variable names can't also be reserved keywords of JavaScript. So class, for example, is a reserved JavaScript keyword, and you can't use it as a variable name. So using reserved keywords as variable names will also throw in an error. Also, invalid characters such as A and B will result in an error being thrown. Now, if you're wondering why these names are not valid in JavaScript, well, there are a lot of reasons for that. For example, there's a very good reason not to allow starting a variable name with a number, Because in JavaScript, numbers are written as is, if you start a variable name with a number, JavaScript might get confused as to whether you're just typing in a number or you're referencing to a variable. That's why variable names can't start with numbers or only contain numbers. And of course, using reserved keywords as variable names would also create a lot of confusion, because if you use a reserved keyword as a variable name, then when you refer to that variable, JavaScript would get confused as to whether you're referring to the variable or actually the JavaScript keyword itself. That's why these names are invalid identifiers in JavaScript. Now, variable values can be changed. So once you declare a variable and assign it a value, it's not permanent. You can change the value as many times as you want. So for example, let's have a variable fruit equals the string orange. So we have a variable named fruit which equals the string orange. Now currently, if we type in fruit in order to access the value of this variable, we get the string orange because that's the value we assigned it in the previous statement. However, we can reassign a new value to this same variable. So now fruit equals orange, but we can reassign a new value to it. So fruit equals apple. So we've changed the value of fruit from orange to apple. And now if we type in fruit, in order to access the value of this variable, we can see the value has been changed from orange to apple. So variable values can be changed. So when you create a variable and assign it a value, it will store that value until you assign it a new one. So in this case, we've assigned a new value apple to the variable fruit. And from now on, the value of fruit has changed from orange to apple. Now, redeclaring an already declared variable doesn't do anything to it. So we already have a variable named fruit. But if you redeclare this variable var fruit, so we try to create that variable again, it doesn't have any effect. It doesn't change the value of the variable as well. So the variable fruit still has the value apple. The value hasn't changed or been deleted to undefined. So redeclaring an already declared variable doesn't do anything to it, and it doesn't change the value of the variable as well. Now there's a very important concept you need to understand in JavaScript when it comes to variables, and that is variable hoisting. Now in JavaScript, you can declare variables anywhere you want in your script, but when that script is executed, all the variable declarations will be automatically moved to the top, which means you can actually reference a variable before it's even declared. This is how it works. Now let's type in a variable food. Now we haven't even declared a variable named food yet, so it should throw an error. And if this is all you have, it will throw an error because JavaScript won't find any variable named food, so it'll throw a reference error. But if we actually declare the variable in a later part of the script, so for example, if we eventually declare that variable food, and even assign it a value, in this case eggs, then the first statement where we try to access the value of food won't return a reference error. It'll actually return undefined. And if we try to access the value of a variable after we've declared and assigned it, then it will give out the correct value, eggs. So when you write a code like this, it's actually treated somewhat like this. So when you write code that's similar to the example on top, it's actually treated as the example on the bottom. In the top example, we're declaring a variable in the middle. Variable food equals eggs is in the middle of our script. But no matter where we declare the variable in our script, the variable declaration, which means var food, it'll be moved to the top automatically by JavaScript. So although we declare the variable food in the second line, the variable's declaration, which is var food, is actually moved to the very top. So this 3 lines of code is actually treated as variable food first, then we're trying to access food, which currently contains undefined because we haven't assigned it a value yet, and then we assign the value eggs to food, and then we try to access it, it gives out eggs. So this is called variable hoisting. So whenever you declare a variable, no matter where it's declared in your script, whether it's on the middle or even at the end, when that script is executed, all the variable declarations is moved to the top automatically, which means even if you declare a variable in the middle of the script, you can actually reference that variable before the declaration, although it'll return undefined because only the variable declaration is hoisted, but not the assignment of the value. So in this case, var food equals eggs, only the var food part is actually hoisted to the top, but not equals eggs. Food equals eggs is stated where it's meant to be. But the variable declaration, which is var food, is automatically hoisted to the top, which means if you eventually declare a variable later in your script, you can actually reference that even before you've declared it, and it will only return undefined. It will not return a reference error. Now, with all the talks about variables, you might be thinking, well, why do we need to use variables? Why do we need them in JavaScript anyways? Well, variables in JavaScript serve kind of the same purpose as variables in algebra. They're used as containers for values. They're used to refer to something else. They're used to refer to a more complex values. They're also used to make the code more readable, more optimized, and faster to execute. Variables can be used where you have to use the same value multiple times, so you don't need to repeat yourself. For example, let's see, we have a variable var colors which equals black plus white. So in this case, we have a variable named colors and we're assigning it the value black plus white. Now black plus white, these are two strings and these will be concatenated into a single string black white, and the black white string will be the value of the variable colors. Now we can actually use string methods on this variable. So for example, because variable colors is actually a string and is just a container for a string value, we can use all the string methods on the variable. So just like we can use the string methods on the strings themselves, for example by typing in a string and then typing in .to lowercase, and it'll turn the string into lowercase. Similarly, if we have a variable which in turn contains a string, we can use the variable name and apply different string methods to it. So in this case, because the variable colors actually contains a string black white, we can use colors.to lowercase in order to apply the to lowercase method to the colors variable, meaning to the string black white, and it returns the string black white but with all the letters in lowercase. We can also use string properties. So in this case, colors.length gives us 10 because colors, the variable, equals the string black white and black white has the length 10. So because colors variable contains a string, colors.length returns the length of the string. In this case, it's 10. Now, if we had to do the same thing but without using variables, then that would be inefficient because then we'd have to write the same code like this. So we had to write it using black plus white in a parentheses, then .to lowercase in order to get the to lowercase black and white, and we had to write the same thing again, black plus white in parentheses .length in order to get the length 10 of the whole string. Now in this case where we're not using variables, JavaScript has to create two strings every time. So when it encounters the first statement, it creates a string black and it creates another string white, and then it adds them together, calculates the value black white, and then applies the to lowercase method to it. And in the second statement, it again creates another string black and another string white. It adds them together and calculates the result again, and then it calculates the length property of this string. This is very, very inefficient because JavaScript has to create a new string and calculate the value of the concatenation every single time. Compare that to the code on top where we only create two strings once. So when JavaScript encounters var colors equals black plus white, it only creates the strings black and white once and calculates the resulting expression black plus white, which equals black white, once, and it instantly assigns the value black white to the variable colors. And then when we type in colors.to lowercase, it doesn't have to create a new string and evaluate the expression once again because the variable colors already contains the value black white. So it doesn't need to create the new string and evaluate the expression every time we call in a method or a property. So colors.to lowercase works much more efficiently, and colors.length gives us the length of the string without creating the new string and adding them together again. Now the difference won't be that much when you're using just a handful of methods or properties. But in real life code, when you'll be using hundreds of methods and properties, you'll see that without variables, the code becomes very inefficient and hard to deal with. That's why we have variables, so that we can store values that we're going to be reusing later on. Now just like variables declared using the var keyword, there's another type of variables in JavaScript called constants. Now constants work just like variables, but with one exception. That is, the value of a constant, once declared, can't be changed. You declare a constant using the const keyword. So you type in const, const, and then you type in the constant name. In this case, we're going to be naming it pi, and you assign it a value on the spot. So unlike variables, which you can declare once and then reassign a value again and again and again later, for a constant, you have to declare the constant and assign it a value on the spot. So in this case, we are declaring a constant pi, and we have to assign it a value at the same time. In this case, the value will be math.pi, which will equal to approximately 3.1416. Now, just like variables, you can access the value and refer to that constant by its name. So in this case, py gives us the value of math.pi, which is 3.1416, and so on. However, unlike variables, you can't change the value or reassign a different value to a constant. So in this case, pi equals 5 or any other value throws in a type error, because once you've declared a constant and assigned it a value, it can't be changed. So the constant pi will always contain 3.1416. It can never be reassigned a different value. You can't also redeclare a constant as well. So we already have a constant pi, and we can't redeclare it unlike variables. So if you try to redeclare it, const pi equals 5, it gives out a syntax error. You can't also declare a constant and not assign it a value. So unlike variables, which we can declare once and then we can assign it a value later, with constants, because the value can't be changed, you can't just declare it and not assign it a value. Whenever you declare a constant, you must assign it a value on the same statement as well. So just declaring a constant like constant x throws in a syntax error. You must assign it a value on the spot. And no matter how much we try to change the value of the constant pi will still remain 3.1416. The value of a constant just can't be changed. Now you might notice that we're using all capital letters when writing constant names, and that's a good convention to have, because writing constant names in all capital letters will help you differentiate between a constant and a variable when you reference it later on in the code. So try to follow this good practice. So unlike variables, constant declarations are not hoisted. So for example, in this case, we first refer to a variable food, which doesn't exist yet, but we declare the variable later, var food equals eggs, and the variable declaration, which is var food, is automatically hoisted to the top. That's why the first statement, food, returns undefined and not a reference error, because the variable declaration is hoisted to the top. But constant declarations are not hoisted to the top. So if you try to refer to a constant before it's declared, it throws in a reference error. So when you type in food, the constant, and declare the constant later, constant food equals eggs, it doesn't work, because the constant declaration is not hoisted to the top. So when the first line is executed, JavaScript can't find a constant named food, and it throws in a reference error. So unlike variables, constant declarations are not hoisted. Hello everybody, and welcome back to Expert.js. My name's Abrar, and I'm going to be your instructor for this video. In this video, we're going to be talking about assignment operators. Now in the previous video, we talked about variables and how you can use the equal operator to assign a value to a variable. But there are a few more assignment operators as well. So let's take a look at a few of them. Now in JavaScript, we can use assignment operators on variables in order to assign them to different values. We already saw an example of assignment operators in the previous video. In the previous video, we used the equal assignment operator, but there are a few others as well. So the first one is the basic assignment operator. On the leftmost column, you'll see the symbol of the operator. In this case, the symbol is a simple equal to sign, and the name is assignment operator. This is the operator we saw in the previous videos when we talked about variables. An example of this is a equals b, which means the value of b, whichever it is, will be assigned as the value of the variable a. Now we also have the addition assignment operator, and it looks like plus equals. So you type in a plus symbol and then an equal symbol together. This is the addition assignment operator, and it looks like this. So instead of a equals b, you type in a plus equals b, or a addition assignment b. And this actually means a equals a plus b. So it's a shorthand operator for a more complex expression. So you can use this as a shortcut. Instead of writing a equals a plus b, you can just type in a plus equals b. Similarly, we also have the subtraction assignment, which looks like minus symbol and then an equal to symbol. So minus equals. And you can write it as a minus equals b, which means a equals a minus b. It's also another shortcut. And then of course we have the multiplication assignment, which looks like an asterisk and then an equal to sign. So a asterisk equals b means a equals a asterisk b. And then division assignment, which is a forward slash and then an equal to sign. So a forward slash equals b, or a divide equals b, actually means a equals a divided by b. And we also have the remainder assignment. So remainder symbol, or the percentage symbol, and then an equal to sign. This is the same as all the other ones as well. So a remainder assignment b actually means a equals a remainder b. And lastly, we have the exponentiation assignment, which looks like double asterisk equals. So a double asterisk equals b, or a exponentiation assignment b, actually means a equals a exponent b. Now let's take a look at real-life examples of how these works. First, we'll start with the basic assignment operator, which is the simple equal to sign. So let's declare some variables. We'll declare two variables for each example, variable a and variable b. Currently, these are undefined, but we can use the assignment operator in order to assign a value to them. So a equals 5. Here we're using the assignment operator. So whenever we use the assignment operator, whatever the value that's on the right side, in this case the right side value is 5, gets assigned as the value for the left side. So in this case, on the left hand side of the assignment operator, we have the variable a. On the right hand side of the assignment operator, we have the value 5, which means the value 5 gets assigned as the value of the variable a. And now a equals 5. That's how you can use the assignment operator. Similarly, b equals 10. So now we're changing the value of b from undefined to 10. This works just like simple algebra. So when you type in b equals 10, the value of b changes from undefined to 10. You're assigning whatever on the right hand side, which is 10, as the value to whatever is on the left hand side, which means b equals to 10. And now if you type in a equals b, then a equals 10 too, because again, a equals b means the value of b gets assigned as the value of a. The value of b currently is 10, so it is equivalent to a equals 10. So a equals b, where the value of b is 10, which means a gets assigned the value 10 as well. And now a and b both equals 10. Now let's take a look at an example of how the addition assignment operator works in real life. So again, let's declare two variables, variable a and variable b, and assign variable a the value 5 and variable b 10. So a equals the number 5 and b equals the number 10. This will be our basic setup for these examples. Now we can use the addition assignment operator. So we type in a plus equals b. Now a plus equals b, as you can see on the right hand side in the comments, actually means a equals a plus b. This is a shortcut. So instead of typing in a equals a plus b, you type in a plus equals b. Now a equals a plus b actually means a equals 5 plus 10, because the value of a is 5 and the value of b is 10. So a equals a plus b is equal to 5 plus 10, which means a finally has the value 15. And if you check that by typing in a, as you can see, a indeed has the value 15, because a plus equals b gives the value a 15. Now, a equals a plus b doesn't really make sense in basic algebra. This is not actually a valid expression in algebra, but it's perfectly valid in JavaScript. A equals a plus b basically means that JavaScript will calculate the value of a plus b, and because a equals 5 currently and b equals 10, then a plus b will be 15. And this 15 will be assigned as the new value to a. So you're actually calculating the value using a, and you're assigning it the final value to the variable a as well. So a plus equals b means a equals a plus b, which in turn means 5 plus 10. So 5 plus 10 or 15 gets assigned as the value of a. This is just a shortcut way of adding and assigning it a value at the same time. That's why it's called the addition assignment operator. Now let's take a look at the subtraction assignment operator. If you understand the addition assignment, all the others become a lot easier to understand. So first, we're starting with two variables, again, variable a and b. And in this case, variable a will be 20 and variable b will be the number 7. And now we can use the subtraction assignment operator. A minus equals b, or a subtraction assignment b, as you can see on the right hand side in the comments, in the explanation, a minus equals b actually means a equals a minus b. Now a is 20 and b is 7, so a minus b means 20 minus 7, which means the final value of a is 13. And if you check that by typing in a, the value is indeed 13. So a minus equals b is actually a shortcut for a equals a minus b. In this case, when JavaScript code is executed, JavaScript treats a minus equals b as a equals a minus b. Then it calculates the value of a minus b, which currently a equals 20 and b equals 7, which means a minus b results in 13, and that is assigned as the new value to a. And that's how a equals 13. The multiplication assignment operator works in a very similar way. So again, we have the two variables a and b, and variable a will equal 10, and variable b will this time equal 2. Now, a multiplication assignment b, or a asterisk equals b, actually means a equals a asterisk b. Now a asterisk b means 10 asterisk 2. So 10 into 2 is 20, which means the final value of a will be 20. And if you check that by typing in a, indeed the value of a is 20. So in this case, again, a asterisk equals b means a equals a asterisk b. Now a asterisk b, or a into b, because a is 10 and b is 2, the calculation results in the value 20. And this 20 value is reassigned to the variable a. So variable a's final value is 20. It's been changed from 10 to 20. So we assign a new value to a while at the same time doing a multiplication calculation. It's just a shorthand for doing both at the same time. We also have division assignment. It works very similar to all the other examples. So variable a and b, a equals 10, and b will again equal 2. Now A slash equals B, or A division assignment B, means A equals A divided by B. Now A currently is 10 and B currently is 2. So 10 divided by 2 results in 5. And that's the value that's finally assigned to the variable A. And if you check that, A indeed equals 5. So what's going on here? JavaScript calculates A divided by B as 10 divided by 2, so it calculates 5 as the result, and it assigns 5 to the variable A. So it's just a shorthand for doing division and assignment at the same time. That's why it's called the division assignment operator. Remainder assignment works in the very same way. So we have again variable A and B. Variable A will equal 10, and variable B this time will equal 4. Now we have A remainder assignment B, or A percentage equals B, which means A equals A remainder B. Now A is 10, B is 4, so A remainder B means 10 remainder 4. And 10 remainder 4 equals 2. So A gets assigned the value 2. And if you check the value of A, it is indeed 2. So the remainder assignment operator is a shorthand for doing remainder calculations and assignment at the same time. Finally, we have the exponentiation assignment operator. So we have variable A and B. A will equal 2 and B will equal 3 for this example. Now A exponentiation assignment B, or A double asterisk equals B, actually means A equals A exponentiation B. And A is equal to 2, B is equal to 3, so A exponentiation B means 2 exponentiation 3, and 2 to the power 3, or 2 cubed, means 8, and that's the value that's assigned to the variable A. So variable A currently equals 8. So the exponentiation assignment operator is just a shorthand for doing an exponentiation calculation and assigning the value to the variable at the same time. Do note that the exponentiation assignment operator is new in JavaScript, which means it might not be supported by all browsers, especially the older ones. And because it's new, the syntax is not final as well. It might change in the future, so you might be a bit careful while using these. Hello everybody, and welcome back to Expert.js. I'm Abrar, and I'm going to be your instructor for this video. In this video, we're going to be talking about arrays. Now, arrays are very fun to work with in JavaScript, so let's get right to it. Okay, so first of all, what are arrays? How do they look like, and what do we do with them? Now, arrays are a type of objects that lets you store multiple values at the same time in a single variable. So previously, we knew that variables could contain numbers, they could contain strings, booleans, and a lot of other things. But numbers, strings, booleans, they can contain only one value at one time. So variable A can equal a single string or a single number or a single boolean, but they can't contain multiple booleans or multiple values, numbers, or strings at the same time. That's why we have arrays. Arrays allow us to store multiple values at the same time in a list-like object in a single variable, so that they stay together and they can be used in much more efficient ways. This is how an array looks like. So this is how you declare and create an array. We're using the array literal syntax, where you type in the values of the array. In this case, we have 3 values, or 3 elements or items inside this array. The first item or first element is the string red. Then we have the string green, and then we have the string blue. We separate these elements by a comma, and we wrap this whole thing up in a pair of square brackets. That's how we create an array. So whenever you see a square bracket at the start and end of a list of values, that is an array. Now, arrays can contain much more than strings. They can contain numbers, booleans, and even other things. For example, here's a more complex array. So as you can see, in this array, the first value, car, is a string. The second value, separated by a comma, is 34, a number. then the third value, if you look correctly, is actually another array. So you can actually have an array as an element in another array. So you're basically nesting an array inside another array. And in this array, we also have two other elements. So the nested array contains the value 2 and also math.random, which executed will give us a random number. And finally, the fourth value is true. So as we can see that arrays can contain a lot of different types of values, even other arrays inside them, effectively creating nested multi-level arrays. Now oftentimes you'll actually be assigning an array to a variable because an array without assigning it to a variable is not very useful. So oftentimes you'll declare a variable and assign an array as its value. So in this case we have the variable named food and equals an array, and this array contains three elements. The first is a string meat, then the string fish, and then the string vegetables. So the var food equals an array which contains three elements. Now you can also create arrays in a different fashion. You can use the new array constructor. So if you want an array with 3 items, 1, 2, and 3, then you can do so using the new array constructor. In this case, you have to type in new array, and then inside the parentheses, you have to define all the elements as parameters. So in this case, new array 1, 2, 3 creates a new array object with elements 1, 2, and 3. However, this is not very efficient. Just like the new string, new number, and new boolean examples, you should try to avoid using new array. Just use the array literal syntax like we have in the first examples. New array is not very optimized and it's not very performance friendly. So avoid using it whenever you can. Now an array is actually an object. In fact, like we said in the very first videos, that almost everything in JavaScript is an object, which means numbers are objects, strings are objects, booleans are objects, and of course, the arrays themselves are objects. So if you type in the type of operator, then type of food, remember the food variable contains the array, then type of food equals object, because an array is an object. However, if you want to find out whether a value is an array or not, you can use the isArray method of the array object. So you can type in array.isArray, and then inside the parentheses, you can type in the array to test. In this case, array.isArray food equals true, because food is definitely an array. So you can use the isArray method in order to check whether a value is an array or not. Now after creating an array, you must be able to access the individual elements inside that array. Otherwise, it won't be very useful. There are ways of accessing and retrieving the elements of an array. Here's how it's done. So first, let's have a variable food again and assign it the array with 3 items. The 3 elements will be 3 strings, meat, fish, and vegetables. And this is the array, that's the value of the variable food. Now how do we access the individual elements inside this array? You can use the bracket syntax in order to access these elements. This works kind of like this. So whenever we create an array, every single element or item inside that array is assigned an index number. The very first element inside an array has an index 0. The second element has an index 1. The third element has an index 2 all the way up to the last element. So you can use this index number with the bracket notation in order to access the individual items inside an array. So if you type in food and then square brackets, and inside the square brackets you specify the index number, in this case 0, which means the first element, it retrieves the first element, which is in this case meat. So that is how you can access and retrieve the different elements inside an array. You can use the index number of that element in order to retrieve the value. Similarly, if you want to retrieve the second element, you need to type in food and then 1 inside square brackets. Now index 1 is actually the second element because indexes start at 0. 0 is the first element and 1 is the second element. So food and 1 in square brackets means you're accessing the second element inside the array. So food 1 equals fish because that's the second element. And of course, food 2, which means the third element, equals vegetables. So this is how you can access the individual items inside an array. Now let's take a look at a more complex example. So here we have a complex array that we just saw a few slides back. So var a equals car34 and another array which equals 2 and math.random, and finally the boolean true as the last element. So this is a very complex array. It contains numbers, strings, booleans, and even other arrays inside it. So how do you access the different elements? Well, the syntax is pretty much the same. So the first element has the index 0. So a in square brackets 0 means we're accessing the first element. In this case, the first element is car. The string car is retrieved when we type in a0 in square brackets. Similarly, 1 means the second element because the second element has the index 1. So a in square brackets 1 retrieves 34 because that is the second element. Now here's where things get interesting. Now a in square brackets 2 means we're retrieving the third element. Now the third element inside this array is actually another array with two different elements. So when you type in a square brackets 2, it retrieves the third element. Now the third element is an array itself, so it just retrieves the array. It makes sense, right? Because a square brackets 2 means we're accessing the third element. Third element is an array. Now because we have math.random, the array contains the value 2 and a random number. Now in this case, the array might look like 2, comma, a random number in an array. So this is the third element inside the array. And of course, a square bracket 3 means the last element or the fourth element, which is the boolean true. Now remember, a square bracket 2, which means the third element, is actually an array itself, which means you can actually use the square bracket notation again, nesting it on top of each other to access the individual elements inside the nested array as well. So A20 means we're first retrieving the array, the third element, the array, and then we're accessing the first element, the 0 index of that array. So it retrieves 2. 2 is the first element of the nested array. So by using the double square bracket notation, you can actually access the individual elements inside a nested array. So a square brackets 2 means the third element, which is the array itself, and then 0 means the first element of that nested array, which is 2. And of course, a21, which means the third element of the array a, which is a nested array, and then square brackets 1 means the second element inside the nested array, which is the random number. In this case, it can be something like 0.453 and so on. So this is how you can use nested arrays and access the elements inside the nested arrays by nesting and doubling square brackets. Now, when working with nested arrays, remember not to go too deep and complex. Arrays that don't have any nested arrays in them are called one-dimensional arrays. Arrays that have one level of nested arrays inside them are called two-dimensional arrays. So the array in this example is a two-dimensional array because it has one array and another array inside it. Now, if there's another array inside this array, it's called a three-dimensional array. And then if you have another array inside that array, it will be a four-dimensional array. Now you can go on, but you have to remember not to go too deep. Most of the time you'll be working with one-dimensional arrays. Sometimes you might need to use two-dimensional arrays, and that's okay. In very complex examples, you might use three-dimensional arrays, but anything over than 4 or 5-dimensional arrays gets very, very complex and too hard to manage, so don't go that far. So now that we know how to access the different elements inside an array, how do we manipulate arrays themselves? So what if we want to change one element or delete it? How do we do that? Well, let's take a look. So first, again, we'll have a simple variable food, which equals an array that contains 3 items, meat, fish, and vegetables, all strings. Now, of course, as we learned from the previous slide, food square brackets 1 means we're accessing the element with index 1. Index 1 means the second element, which retrieves fish. Now, if you want to change the value of the second element, you can actually assign it a different value. So food square bracket 1 means the second element or the element with index 1, and you can assign it a different value. For example, instead of fish, we can assign it equals bread. And now if you type in food, As you can see, the element has been changed. So now it's no more meat, fish, vegetables, it's meat and then bread and vegetables. So just like you can use the index and the square bracket notation to access array elements, you can use it to change and manipulate the array values themselves. Now when manipulating arrays, you must be careful that you always manipulate elements that actually exist, unless you're specifically doing it for some other reason. So for example, here we have a variable n and it equals an array. This array has three values, 1, 2, and 3, with index numbers specifically 0, 1, and 2. We have three elements ranging from index 0 to 2. Now, if we type in n square bracket 5 equals 4, which means we're accessing the element with index 5 and assigning it a value 4. Now, an element with index 5 doesn't actually exist because the array only has 3 elements, right? So we have indexes 0, we have index 1, and we have index 2. Index 5 is so far away. It doesn't actually exist yet, but we can nonetheless assign a value to it. So n square bracket 5 equals 4 means we'll add an element in the array with index 5 and a value 4. However, this leaves undefined elements inside the array. So now if you type in n, it actually looks like this. It's not 1, 2, 3, 4, but it's actually 1, 2, 3, undefined, undefined, and then 4. Why is that? That's because in the second statement, we typed in n square bracket 5. Now index 5 means the sixth element. So the sixth element inside this array will have the value 4. Now we didn't define what the fourth and fifth element will be, so they're automatically undefined. So that's why if you use a very high index number, you'll actually end up with undefined values inside the array, which might cause problems later on. So be careful with this. Hi there, and welcome back to another video of Expert.js. My name's Abrar, and I'm going to be your instructor for this video. In this video, we're going to be talking about array properties and methods. Now, in the previous video, we talked about arrays. We talked about what arrays are and how they work. Now, just like numbers, strings, booleans, and almost every other object in JavaScript, arrays have different properties and methods available that make using and handling arrays a lot easier in JavaScript. So let's take a look. So first, let's create an array. This array will have 3 items. All of them are strings and they are A, B, and C respectively. And we'll assign this array as the value to the variable letters. So variable letters contains the array with items A, B, and C. Now, just like strings have a length property, arrays have a length property as well. In the case of arrays, the length property will tell you how many items or elements are there inside the array. So the array's length property always contains a number that'll tell you how many items are there inside the array. In this case, the array letters have 3 items, A, B, and C. So letters.length returns 3. You can use the length property to do some pretty cool tricks. For example, here's a fun way of retrieving the very last item in any array. In order to retrieve the very last item of the letters array, you can type in letters and then in square brackets letters.length minus 1. Now for the letters array, the last element is the string C, and the string C has the index 2. So letters and square brackets 2 should give us the last element. Now letters.length is 3, so letters.length minus 1 means 3 minus 1 or 2, and this works for any array. And that's because any array's length property contains the number of how many items are there inside the array. And because the counting starts from 1 and all the way up to the last element, if you minus 1 from this number, then you get the index of the last element, which you can put inside the square brackets in order to access the element. So in this case, letters.length minus 1 means 3 minus 1 or 2. And when you put 2 inside the square bracket in letters, that means letters square bracket 2 or the last element, which is C. Now you can also use this to add an item at the very end of the array. Now currently the array has 3 items with index 0, 1, and 2. Now if we wanted to add another item, that would probably be on index 3. And we can use the letters.length property in order to find that index, because letters.length property contains 3, which is the index that we need. So letters and square brackets letters.length equals D, which means we're adding another element, the string D, on the index 3 of this array, which means at the very end. And now the letters array contains 4 elements, A, B, C, and D, respectively. Now for our next example, let's start with the same array. Var letters equals A, B, and C. 3 strings, 3 items in the letters array. Now letters have a shift method, which you can use to remove the very first item from the array. So letters.shift, and then if you type in parentheses, which means to execute the method, it'll return A, which is the first element. But it actually mutates or changes the main array. So by using the shift element in the letters array, you have removed the first element, which is A. So now the letters array only contains B and C. So if you type in letters, then as you can see, previously it was A, B, and C, but now it only contains the strings B and C. The first string, or the string A, has been removed. So you can use the shift method to remove the first item from any array. Now if we use the shift method again on the letters array, then B will be removed and only C will be left. And if we use letters.shift final time, then the C string will be removed as well and the array will be empty. In other words, the letters.shift method removes the element with index 0 inside the array, which is the first element. Now the opposite of the shift method is the unshift method. Makes sense, right? The unshift method can be used to add a new item at the start of the array. So letters.unshift, and of course because you're adding a new item, you need to specify what that item is inside the parentheses as a parameter. So in this case we want the new item to be the string new. So letters.unshift new will add the string new as the first element in place of A. So now the letters array contains 3 elements, new, B, and C. So you can use the unshift method to add a new element at the very start of the array. And you can do it as many times as you want. The new items will be added and all the other items will be pushed back. Now for our next example, let's have an array 1, 2, 3. And let's assign it to the variable n. So variable n equals the array 1, 2, 3. Now similar to the shift method, we also have the pop method. So n.pop actually removes the last element from the array. So it's kind of like the counterpart of the shift method. The shift method removes an element from the start of the array, and the pop method removes an element from the end of the array. So n.pop should remove the element at the very end. And now the n array contains only the elements 1 and 2. So the last element, or 3, has been removed from this array. And that's how the pop method works. You can use the pop method to pop out or remove the very last element from an array. And similar to the shift method, if you use the pop method again on the n array, then 2 will be removed and only 1 will be left. And the opposite of the pop method is the push method. The push method can be used to add an item at the very end of the array. And of course, you have to specify the element value inside the parentheses as a parameter. So n.push 2.5 will add 2.5 at the very end of the array. And as you can see, it is true because now the n array contains 1, 2, and 2.5 has been added at the very end in the place of 3. So you can use the pop method to remove the item from the end of the array, and the opposite push method to push an item at the end of the array. These two methods are counterparts of the shift and the unshift method. Now for our next example, let's have a variable ABC with an array ABCD. So we have an array with 4 elements, 4 strings, A, B, C, and D respectively, and we're assigning it to the variable named ABC. Now a very cool method for arrays is the splice method. Now the splice method is very powerful, as you'll see in just a moment. The splice method can be used to remove items from an array. It can be used to add items to an array. It can also be used to remove and add items simultaneously to an array when used correctly. So the splice method is actually very powerful and very capable. First, we'll look at the removing feature of the splice method. Now, if you specify only one parameter, then the splice method can be used to remove elements from an array. Now, in this case, the parameter inside the parentheses tells JavaScript where to start the splice or where to start removing the elements. This is the index of the first removed element. And if you don't specify anything else, JavaScript will continue removing the elements from the starting index to the very end of the array. So in this case, abc.splice2 means we're starting the splice at index 2. And because we're not specifying anything else, the splice will continue up until the end of the array, which means the element with index 2 will be removed, and all elements after that until the very end of the array will be removed as well. Now for the ABC array, index 2 means the third element or the string C. So the splice will start at string C and will continue until the end of the array, which means the string C will be removed and the string D will be removed as well, leaving us with only A and B. And if you double check with typing in ABC, as you can see, the array now only contains the elements A and B, but not C and D, because abc.splice2 means we're starting the splice at index 2, which is the third element, the string C, and we're continuing the splice until the very end of the array. So the element C and anything after that has been removed, and only the first few elements are remaining. Now let's redefine the ABC array again. So ABC equals the new fresh array A, B, C, and D. Now you can specify how many items to remove with the splice method. So if you don't specify anything, it'll start removing the elements until the very end. But you can specify an optional second parameter that tells you how many elements to remove. So in this case, abc.splice1, 2 means the splice will start at index 1 and it'll remove 2 elements including index 1. So in this case, ABC contains the elements A, B, C, and D, the strings, and abc.splice1, 2 means the splice will start at index 1. Now index 1 is the second element or the string B, which means string B will be removed, that's the first one, and then we have another element to remove because we want to remove 2 total elements. So the string B will be removed and the string C will be removed as well. These 2 elements will be removed, and that's what we're specifying in the second optional parameter. So you're starting the splice at index 1 and we're removing 2 elements, index 1 and index 2, which means the strings B and C. And now the ABC array only contains the elements A and D because B and C have been removed. So as you can see, using the splice method, you can start a splice at the specific index and continue on until the very end of the array, removing all the elements, or you can start a splice at a specific index and only removing a specific number of elements and leaving all others intact. Now for some more powerful examples of splice, let's have our ABC array once again. So var ABC equals A, B, C, and D, the strings. Now in this case, you can type in abc.splice2, 0, and then new to actually add an element inside the array. So in this case, the first parameter tells us where the splice will start. In this case, the splice will start at index 2, or the string C in this case, which is the third element. So the second parameter again tells us how many items to remove. In this case, we've actually inputted 0 as our second element, which means no items will be removed. So by inputting 0 as the second element, you can actually tell JavaScript not to remove any elements. And in this case, the splice method will only add elements and not remove them. So the splice starts at index 2, which is the string C. It removes no items, but it adds a new item, the string new, at the index 2. So the resulting ABC array looks like this. So as you can see, currently the ABC array contains the strings A, B, and then at index 2, the element new has been added, and then C and D. So no items have actually been removed in this case. We're just starting the splice at index 2, we're removing 0 elements, which means we're not actually removing any elements, and then at index 2, we're adding the string new as a new element. So in this case, the resulting array is A, B, new, C, and D. Of course, you can add as many elements as you want from the starting index. So in this case, abc.splice 4, 0, new 2, and new 3, which means we're adding 2 new elements, new 2 and new 3, starting at index 4. So the resulting array looks like this. So now we have A, B, new, C, new 2, new 3, and then D. Now previously, the array only had A, B, new, C, and D. But now we're starting the slice again at index 4. Now index 4 is the very last element on the string D in this case. So we're starting the splice at index 4, we're removing 0 elements, and we're adding 2 new elements starting at index 4, which means the 2 new elements are added in between C and D. And this is how you can use the splice method in order to add one or multiple new elements at any index inside the array. So just for recap, this is what our ABC array looks like right now. We have A, B, new, C, new 2, new 3, and then D. Now you saw the splice method remove all or a specific number of elements from a specific index. You also saw how you can use the splice method to add new elements. Now the splice method, with some clever parameter settings, can also be used to add and remove elements simultaneously in one operation. For example, if we have abc.splice 3, 1, new 1, which means we're starting the splice at index 3, which in this case is the string C, which is the 4th element. So we're starting the splice at index 3, or the string C. We're removing one element. The second parameter specifies how many elements we want to remove. So we're removing one element, which means we're removing the string C element itself. And in that place, on index 3, we're adding a new element, new 1. And now our ABC array looks like this. So now, as you can see, the 4th element, or the string C, has been removed and is replaced with new 1. So in this case, the full array is A, B, new, new 1, new 2, new 3, and then D. So using the splice method, you can specify where to start the splice, how many items to remove, and what new element or elements to add in their place. Hello everybody, and welcome back to Expert.js. I'm Abrar, and I'm going to be your instructor for this video. This video will be about array properties and methods part 2. Now in the previous video, we already looked at a lot of different properties and methods for arrays. And in this video, we're going to continue on from there and take a look at more useful methods. So let's get right to it. Now let's talk about getting indexes of array elements. Now we already know that if we have an index of an element, we can use that index in the square bracket notation and retrieve the element with that index. But what if it's the other way around? What if we have an element and we want to know what the index of that inside the array is? Well, you can do that using built-in methods. So first, let's define an array. In this case, we're going to be calling it var meat. So we have a meat variable which contains an array with 3 elements: chicken, beef, and lamb. Now in this case, you can use the index of method of arrays to retrieve the index of an array element. So meat.index of beef will retrieve 1 because beef has an index inside the meat array of 1. So just like if you have the index, you can type in meat square brackets 1 in order to get beef as a result. The opposite is you can type in meat.index of beef and get the index of the beef element. And because the string beef is the second element inside the array, we get 1 because it has an index of 1. Similarly, meat.index of chicken retrieves 0 because chicken is the first element inside the array and it has an index 0. So meat.index of chicken gives us 0. Now if you enter something that's actually not present inside the array, for example, in this case we've typed in meat.index of salmon, which is not actually in the array because it's an array about meat, then we get -1. So -1 tells us that JavaScript can't find the specific element inside the array. So, by using the index of method, if you have an element value, you can use that to retrieve the element index inside a certain array. Now, we just learned about arrays and we've talked about strings in previous modules. Now, you can convert between these two in a lot of different ways. Here are a few of them. So first, let's have a variable called letters and let's assign it a value which is an array containing A, B, and C, 3 strings. Now in this case, you can use the join method in order to convert an array into a string. So letters.join and then parentheses to execute the method retrieves a string A, B, C. So it basically takes all the elements inside the array, concatenates them together and separates them by a comma. And that's how letters.join method works. So you can use the join method in any array in order to convert that array into a string. However, having A, B, C doesn't actually look very good because we usually put a space after a comma. Thankfully, the join method can accept an optional parameter, which allows you to specify exactly what you'll put as the separator between the element values. So in this case, letters.join and then a string, which is just a comma and then a space, tells JavaScript to separate the elements using comma and space. So the resulting string is A, B, C, but with proper spaces after the commas, which looks better. In fact, you can actually put in almost any valid string in the join method, and JavaScript will use that to join all the different array elements. So in this case, letters.join, then a blank white space gives us A, B, and C without any commas. So whatever string you specify in the join method will be used to join together the different elements of the array. If you specify a white space, then a white space will be used to join the elements. Or you can specify a comma and a space to join them using a comma and space. And if you don't input anything, it just defaults to a comma. In this case, we're using letters.join, so space dash space gives us the result A, space dash space B, space dash space C. So now all the different elements A, B, and C are separated by a space dash space. And that's how the join method can be used to convert arrays into strings and can be even used to specify how you'll separate the different array elements inside the string. Now just like you can convert arrays into strings, you can also do the opposite. So if you have a valid string, you can convert it into an array. So in this case, we have a valid string var s, which equals A, B, C. Now this is a string right now, but what if we want to convert the string into an array? So in this case, we want to convert the string into an array with 3 elements, A, B, and C. But currently, it's actually a string. So how do we convert the string into an array? We can do that using the split method. So in this case, we're declaring another variable A, which equals s.split, and then a comma and a white space. So it works almost opposite to the join method. In this case, the split method takes a string and splits it into different array elements using the separator you specify. So in this case, var s equals A, B, C, and now we're using that string s.split and then comma and a white space. Basically, we're telling JavaScript to separate the string into different array elements and use the separator comma and a white space to do that. And the resulting array is stored in the a variable. And now if you check the value of the a variable, we get the array a, b, and c. So the string a, b, c has been successfully split into different array elements. And in this case, we needed to specify that JavaScript should split the string using comma and a white space as a separator. Now what separator you use depends on the string. So in this case, we have another string var s2 which equals a, b, and c. So now we don't have a comma and a white space. The elements are separated using just a white space. So in this case, if we want to convert this into an array, we need to type in s2.split and then just a white space. This tells JavaScript to convert the string into an array and use white space to separate the different elements. So in this case, the result is the same, a, b, and c array. But we needed to specify a different string as a separator in this case. Now let's see, we have another string, var w equals JavaScript. So w is a variable which contains a string JavaScript. Now if we don't specify a separator in the split method, then what does it do? It basically takes the whole string and puts it as one element inside the array. So the w string only contains the word JavaScript. And w.split without any specific separators gives us an array with only one element, the string itself. And what if we put in an empty string as the separator? So w.split and then an empty string. That actually separates every character inside the string and puts it as a different element. So in this case, we have JAVA, ACRIPT. So JavaScript has been split into separate characters, and each character as a string has been put as a different element inside the array. Now, in some cases, you might want to join two arrays together. So in this case, let's say we have an array that is 1, 2, and we have another array 3, 4, and we want to join them. You might think of using the plus operator or the concatenation operator. But unfortunately, JavaScript converts the arrays into strings, so the concatenation is not exactly what you would expect. So the result of this operation is actually just a string 1, 2, 3, 4. Not exactly what we wanted. We wanted the result to be an array that contains 1, 2, 3, and 4. How can you do that? For that, we need to use the concat method. Now the concat method can be used to join an array at the end of another array. So in this case, we have the same array 1, 2, and we're using the concat method of this array, and we're specifying the array to join as the parameter inside the concat method, 3, 4. And now the result is what we would expect, an array that has the two arrays concatenated together to form 1, 2, 3, 4. And that's how you can use the concat method to join two arrays together. Now the concat method can accept more than one parameter as well. So let's say we have a variable x which equals the array with strings a and b. And we have another variable, variable y, which equals uppercase a and uppercase b. And finally, we have a variable z, which equals 1, 2, 3. So in this case, we're using the concat method on the x array, which is the first array, and we're concatenating the arrays y and z to the x array. So what's the result? The result is a big array containing lowercase a, lowercase b, then uppercase a, uppercase b, and finally 1, 2, 3. So first we have the x array, which is lowercase a and lowercase b, which has been concatenated to the y array, uppercase a and uppercase b, and all of this has been concatenated into the z array 1, 2, and 3. And that's how you can add multiple arrays together using the concat method. Now sometimes you might want to search an array for a specific value and know whether that value exists inside the array or not. And you can use that using different methods. For example, let's say we have a variable x, which equals an array. And this array contains 3, 6, 2, and minus 11. So 4 different numbers as 4 elements. Now arrays have an includes method, which can be used to search for a specific value inside the array. So x.include6 tells JavaScript to search for the value 6 inside the x array, and if it finds it, it'll return true. So of course, obviously we do have the x value inside the array, so x.include6 returns true. However, we don't have 5 inside the array, so x.includes5 returns false. And that's how you can use the includes method in order to search for a specific value inside the array and find out whether it exists inside the array or not. Now sometimes you might want to sort a certain array, and JavaScript has methods available for that. So for this example, let's redefine our previous array again. Var x equals 3, 6, 2, minus 11. Now you can use the sort method in order to sort all the values inside the array from the smallest to the biggest. So x.sort gives us the array which starts with minus 11, then 2, then 3, then 6. So it starts with the smallest element first, which is minus 11, then 2, then 3, then 6. So it sorts the array in an ascending manner. And arrays also have a reverse method. So x.reverse can be used to reverse all the elements inside the array. So you can use the reverse method on any array to flip the position of all the elements inside it, which means the first element will become the last one, the second element will become the one before last one, and so on. So in this case, the x array is currently sorted as minus 11, 2, 3, and 6. And by using the reverse method, it reverses the order of the elements. So it starts from 6, 3, 2, and minus 11. Now if you use the sort method first and then the reverse method, you can actually reverse sort the array. So starting from the largest number and going on to the smallest number. Otherwise, the reverse method will just reverse the position of all the elements inside the array. Now the sort method not only works on numbers, it works on string-based values as well. So for example, let's define another array, var y equals tomato, carrot, and spinach. Now we have an array with 3 strings, but they're not sorted in any specific way. Now we can use the y.sort method to sort the specific array from A to Z. And the result is first we have carrot, then we have spinach, and then we have tomato. So you can use the sort method on string-based values as well, and it will be sorted from A to Z in an ascending order. Now what if you have multiple types of values inside an array? So in this case we have another variable, variable z, which equals an array uppercase A, then true, then 2, lowercase a, and false. So what will happen if we use the sort method on this array? So as you can see, the result is 2, uppercase A, lowercase a, false, and then true. So JavaScript's internal sorting algorithm, when it's presented with different types of values, will always sort numbers first. So it'll start from 0, which is the smallest, and then 1, 2, 3, 4, and so on. And after that, it'll start with strings, starting with uppercase strings first. So it'll go from uppercase A to uppercase Z and every string that starts with it. Then it'll go from lowercase a to lowercase z. And finally, false and true will be at the very end of the sorted array. And that's how JavaScript treats different data types in its sorting algorithm. Now, in some cases, you might want to find the smallest or the largest number inside an array. So let's say we have an array var x, which equals 3, 6, 2, and minus 11. We already saw this array in previous examples. Now, if we want to find the minimum value inside this array, which means the smallest value of all the values inside the array, then you might think of using the math.min method. You might think that you can use the math.min method. So you might type in math.min and then x as the array inside the parentheses. Unfortunately, it returns nan, so it's not a number. So why is it like that? I mean, we saw the math.min method at work in previous modules, right? Where we inputted different numbers and it correctly told us what's the smallest value. So why isn't it working now? Well, if you go back to that module and rewatch the video, you'll see that we actually use math.min method in a different syntax. This is how we actually use the math.min method. Inside the math.min method, we define the list of values as separate parameters inside the method separated by a comma. So in this case, we type in it as 3, 6, 12, minus 11. And we put this all inside parentheses inside the min method as different parameter values. And that correctly returns the smallest number, which is the negative minus 11. However, in the second example, where we are using math.min and then in parentheses x, we're actually passing the whole array as a single parameter value inside the min method. But the min method doesn't work that way. The min method needs all the values separated by a comma as different parameters. But when you type in math.min and then x inside the parentheses, you're just giving it one parameter value, the array itself. But the math.min function doesn't accept an array. It accepts a list of values as separate parameters. That's why math.min and then x doesn't work. It returns a nan because the operation is invalid. In this case, if you want to find out the smallest number out of the list, you need to input them as different parameters inside the math.min method. And that works exactly how it's expected. However, that's not very useful. Like, we might have an array and we might want to find the smallest value inside the array. But if the array is too big, we might not be able to input the different elements as separate parameters for the math.min function. And in some cases, we might not even know exactly what values an array contains. So how can we solve this? For this problem, JavaScript offers the spreader operator. Now the spreader operator is just 3 dots or period symbols side by side. And you can use that in a parameter to convert an array or spread an array into parameter values. So math.min ... x gives us the correct result, which is minus 11. Basically, ... x takes the array and spreads all the different elements out as separate parameters for that method. So math.min ... x is actually equivalent to the previous statement, where we're inputting the list of values as separate parameters. So you can kind of think of it as essentially removing the square brackets from the start and end of the array. And that's how you can use the spreader operator to input an array as a value in a method that usually accepts separate parameters for different values. And of course, the max method works as expected with the spreader operator as well. So math.max just x would give nan, but ... x spreads the array into 3, 6, 2, minus 11, and it gives us the largest value, which is 6. And that's how you can use the spreader operator with arrays in order to spread an array into different parameter values for a specific method that requires it. Hello everybody, and welcome back to Expert.js. My name's Abrar, and I'm going to be your instructor for this video. In this video, we're going to be talking about dates. Now, in JavaScript programming, you might often be working with dates and time. Thankfully, JavaScript provides a date object for this specific purpose. So let's see how that works. First of all, how do you work with dates in JavaScript? Well, sure, you can write a date as a string and it'll store it like a string, but you don't have to do that because in JavaScript we have the dedicated date object, which allows you to work with dates and times in a much more flexible and more powerful way. Now, you have to remember that in JavaScript, dates are actually stored as milliseconds since the Unix epoch time. And the Unix epoch is actually a specific time in history, which is January 1, 1970 at midnight UTC. So this is the time that is called the Unix epoch. And dates in JavaScript are stored as milliseconds since this specific time in history. Now, in order to create a new date object, you declare a variable in order to store the object. In this case, variable d equals new date. Now you have to type in d as capitalized because otherwise it won't work. So new date creates a new date object. In this case, variable d, or the new date object, will hold the current date and time as its value, which means it'll hold the specific date and time when this code is executed. In this case, it might look something like this. So if this code is executed at Tuesday, April 10, 2018 at 21:24:53 UTC time, then this is the value variable d will have with the new date object. Now do note that this date is static. So once this code is executed, this is the specific time value that this variable and the object will have. In real world, the time and the seconds will move on, but the variable d will always contain this specific time. So it's a static value. It's not dynamically updated. Now, if you type in d in order to access the value of the variable, you'll get something like the example below. Tuesday, April 10, 2018, then the time and time zone. Now this might come off as a string, but internally, JavaScript, the date object, actually stores this date as milliseconds since the Unix epoch time. But when you actually access the variable, the value is given off as date and time in strings. Also note, if you're using JavaScript in a website or a web application, then when you call new date, the specific date and time created will depend on the specific user's browser and system. So different users will get different dates as their value. So just by calling in new date, you can create a date object with current date and time. But that's not exactly useful. Sometimes you might not want the current date and time. Sometimes you might want to create a date object at a specific date and time. JavaScript allows you to do that as well. In this case, there are a few ways to do that. The first way is to create a new date object, and then instead of a blank pair of parentheses, inside you can actually put in a parameter. You can put in a number, and this is the number which will be the number of milliseconds since the Unix epoch. So in this case, if you put in new date 0, then the date will be exactly the Unix epoch time, which is January 1, 1970 UTC midnight. But in this case, we have inputted new date 86.4 million. 86.4 million milliseconds, if you calculate, is exactly 1 day or 24 hours, which means this date object will be 1 day after the Unix epoch time, or something like this. So Unix epoch is January 1, 1970, and new date 86.4 million, which means 1 day after the Unix epoch, is Friday, January 2, 1917, midnight UTC time. So by specifying the number of milliseconds since the Unix epoch time, you can create a new date object with a specific date and time. Now you can also input the date and time separately in different parameters. In this case, we're using new date, and instead of inputting the number of milliseconds since the Unix epoch, we are inputting the date and time specifically in different parameters. The first parameter will be the year. In this case, it's 2016. The second parameter will be the month. In this case, it's 2. But in JavaScript, actually months start from 0 to 11 and not from 1 to 12. So 2 doesn't actually mean February, but 2 actually means March. We'll see how this works in just a moment. Then the third parameter is the date. In this case, it's 21. The fourth parameter is the number of hours. In this case, it's 15 or about 3 p.m. Then we have minutes, so it's 3:30 p.m. And then we have minutes, so it's 30 minutes, and the value after that is seconds, so it's 12 seconds, and finally the last value is the number of milliseconds. In this case, it's 200. if you create a date object like this, then the value will be somewhat like this. So as you can see, we have a new date object with the value Monday, March 21, 2016, 15:30:12 UTC time. So in this case, we have created a date object which is March 21, 2016, 15:30:12. You don't see the millisecond here, but JavaScript has calculated the millisecond internally as well. Now, if you create a new date object like this, you can input up to 7 different parameters, starting with the year, then month, then date, then hours, minutes, seconds, and milliseconds. However, you don't have to specify each one of them. At minimum, you have to specify only 2 of them, which is the year and the month, and it'll create a date object like that. So in this case, if you only specify the year and month, as in this case we are specifying 1975 and 7, then we're telling JavaScript to create a date with the year 1975 and month is 7, which is August. And because we're not specifying all the other values, JavaScript just defaults to 1 or 0. In this case, because we didn't specify a date, we have 1 as the date and time is 000 GMT 0. Now when it comes to the year, you don't have to input the full year. You can input 1 or 2 digits, and in that case it will be treated as a 19 and then those 2 digits. In this case we have new date 83/2/14, which is actually equivalent to March 14, 1983. So just by inputting 83, JavaScript treats 83 as 1983. So if you input just 1 or 2 digits instead of the 4-digit year, JavaScript will treat them as 20th century dates. Now when defining months for the date object in JavaScript, you have to remember that in JavaScript, the months start from 0 all the way up to 11 and not from 1 to 12 like we usually use. So in this case, January is actually 0, February is 1, and so on. So it's helpful to take a look at a table with all these index numbers. So this is how JavaScript actually treats months. 0 is January, 1 is February, 2 is March, 3 is April, and so on. So the months actually start from 0 and go all the way up to 11. This is very important to remember because oftentimes we calculate months starting from 1 in real life, which means when creating a date in JavaScript, we might actually create the wrong date. So for example, if we want the month of a date object to be in April, we might mistakenly type 4 because 4 is April when you count from 1. But in JavaScript, because month counts start from 0, April is actually 3. So be careful with that. Now days in JavaScript, although we don't define them when creating a new date object, also start from 0, starting with Sunday. And they also work towards 0 to 6. So 0 is Sunday, 1 is Monday, 2 is Tuesday, and so on. Starting with 0 and all the way up to 6. This is how days are represented in JavaScript. Now when creating a specific date and time, you already know that we can specify the number of milliseconds since Unix epoch. We can also specify the date and time as separate specific parameters. But in JavaScript, we can also use a string and parse it as a date object, kinda like this. So in this case, we have var d equals new date. Instead of specifying the number of milliseconds since the Unix epoch, or specifying the date and time separately as different parameters, we can type in a date string, basically a string that contains a date or a time. So in this case, we have 25 March 2012, and most of the time, JavaScript will actually create the right date for you. In this case, new date results in Sunday, March 25, 2020, 000 UTC time. So it can parse a lot of different strings and format, and most of the time it'll return the correct result. So if we have a different format such as 1999, then a -02 -15, which means 15th February 1999, JavaScript also parses this correctly and will give you Monday, February 15, 1999, 000 UTC time. You can also specify the time as well. So, new date, 5 August 2005, 1850-20 will create a date object with value Friday, August 5, 2005, 1850-20 UTC time. Now, having a date as a string and converting it into a date object like this may seem very convenient and helpful. Unfortunately, when you parse a string as a date, the result is inconsistent among browsers. Different browsers support different formats, and the results are not very reliable. That's why it's strongly recommended not to parse strings as dates. Instead, define the number of milliseconds since the Unix epoch, or specify each of the date and time parameters separately in the date object. But parsing them as strings is not a very good idea because the result can be inconsistent and unreliable. Same goes for the date.parse method. They work almost similarly to the new date method and can accept different formats, and most of the time it'll return the correct result. You can also specify time as well. In this case, we're using the ISO format, and most of the time, again, it'll return the correct result. But because these two methods are very similar, it's strongly discouraged to use the date.parse as well. Instead, use the new date object and specify the number of milliseconds or the date and time parameters separately, because using date.parse or parsing a string as a date can have certain unexpected outcomes. Now sometimes you might have two different dates and you need to calculate the difference between them. So how many days or months or seconds or whatever is the difference between two date objects. You can calculate date differences very easily in JavaScript. So first, let's have a start date. In this case, it's new date 2017 5/17 10/30/00. And we have an end date, which is 2018 1/3/6/20. So we have a start date and we have an end date. These two are several months apart. So how do we calculate the difference between them? So how many days are the difference between the start and end days? Well, you can actually just minus the end date from the start date. And because JavaScript stores the date object internally as the number of milliseconds since the Unix epoch, minusing end from the start date will give you the number of milliseconds that's the difference between these two date objects. So when you have the number of milliseconds, you can format it as you like. For example, because we know there are 86.4 million milliseconds in a day, so if we divide the end minus start by 86.4 million milliseconds, then we get 230.826 days, or almost 231 days. So that's how we can minus and divide in order to find out that the differences between these two dates are almost 231 days, which is about 8 months. Hello everybody, and welcome back to Expert.js. I'm Abrar, and I'm going to be your instructor for this video. In this video, we're going to be talking about getting and setting dates. In the previous video, we talked about how to use the date object with the current or a specified date and time. In this video, we're going to be talking about how you can use the different methods available to the date object in order to get and set dates. So let's get right to it. So first of all, let's talk about getting dates. So in this case, let's define a date. Var date equals new date. It will contain the current date and time. In this case, let's say, for example, it is like this. Tuesday, April 10, 2018, 22:30:53 GMT 0000. It also has a millisecond, but it's not displayed here. But internally, the JavaScript date is accurate up to the millisecond as well. So in this case, we have a date object with an example date time, which is this. Now, the date object has a lot of methods available that allows you to get the date in different formats or get different sections of the date as well. The first method that we're going to be looking at is the getTime method. Now, det.getTime will give you the number of milliseconds since the Unix epoch for that specific date. And in this case, this is actually about 1.5 trillion milliseconds since the Unix epoch. So if you have a date object, you can use the getTime method in order to convert the date into the number of milliseconds since the Unix epoch. But there are a lot of other methods available as well. So using the same date object from the previous example, let's take a look at a few more of them. First, we have the getDay method. So using the date object, which we stored and created in the variable date in the previous example, if we type in .getDay, then we get 2. Now remember, in JavaScript, dates start at 0, which is Sunday. So 2 calculates to Tuesday. And if you remember from the previous example, the date in the previous example was indeed Tuesday. So using the getDay method, you can retrieve the day of a specific date object. We also have the getDate method. The getDate method allows you to retrieve the date. So in this case, the date was 10 April. So in this case, it's 10. We also have the month. In this case, .getMonth method will retrieve 3. And because JavaScript months start from 0, 3 is actually April. And if you remember, in the previous example, the actual date was April 10th, 2018. And if you remember from the previous example, the actual date was 10th April 2018. So you can use the getMonth method in order to retrieve the month of a date object. We also have the getFullYear method. Date.getFullYear will give you the full year of the date. In this case, it's 2018, like in the previous example. We also have getHours. So in this case, .getHours gives us 22, because remember in the previous example, the hours was 22. Of course, we have getMinutes, which gives us the minute of the date object, which is 30. And we have getSeconds as well, which is 53 seconds in this case. And although we didn't see it in the previous example, we also have getMilliseconds. In this case, we can see that the milliseconds for this specific date object is 921. Now we just saw 8 different methods for 8 different portions of the date object, starting with day, and then date, month, year, hours, minutes, seconds, and milliseconds. Now there are UTC versions of all these methods as well. In this case, they look something like this. So instead of getDay, you type in getUTCDay, and then getUTCDate, and so on. We have getUTCMonth, getUTCFullYear, getUTCHours, getUTCMinutes, getUTCSeconds, and of course, getUTCMilliseconds. Now, in this case, because we're assuming that the date object we created has a time zone of UTC, the UTC methods result in the same values as we just saw. It doesn't really change it. But in case the code is executed from a different time zone where the new date object returns their local time zone, you can use the getUTCDay in order to actually convert the date object and get the UTCDay and all the UTC based values in here. Now in this case, all the values returned are the same. But in the case where the new date object is created inside our user's browser in a different time zone, then the value of the date object will be based on that local time zone and not UTC. And in that case, using the UTC methods will return the different results. Especially the UTC hours is what is usually different, because the hours is different depending on the time zone. So in this case, if your date object created has a different time zone, you can use getUTCHours in order to retrieve the time in UTC time and not the local time. But in this case, we're assuming that the code is executed in a UTC time zone. That's why the results are the same. But in the case where the dates will be executed in a local time zone, these methods, especially date UTC hours, will return different times based on the local time zone. Now, just like using the get methods, we can get different portions of the date object in different formats. We can also set different portions of the date object separately. In this case, we'll start again with the new date object. So var date equals new date. In this case, the example will be the same as previous one. So Tuesday, April 10, 2018, 22:30:53 GMT. And again, the millisecond is not displayed here, but we know that the millisecond is 921 from the previous example. Now, the first method that we can look at is the set time methods. So this is basically the same as get time method, but it's opposite. It's the set method. So it's the set equivalent of the get time methods. So the get time method tells us the number of milliseconds since the Unix epoch for a specific date. And the set time method can be used to set the number of milliseconds since the Unix epoch. So you can actually use it to change the value of the date object. In this case, we're inputting minus 86 million. So in this case, you can type in a positive number for a number of milliseconds after the Unix epoch. You can also type in 0 for the Unix epoch and a negative number for the number of milliseconds before Unix epoch. So you can input negative numbers as the milliseconds as well. In this case, date.setTime minus 86.4 million gives us 1 day before the Unix epoch. So Unix epoch is 1 January 1970. In this case, minus 86.4 milliseconds, which is minus 1 day, gives us December 31, Wednesday, 1969, UTC time, midnight. So you can use the set time method to actually manipulate the value of the date object. You can specify the milliseconds in order to create a new date time. Now, most of the methods we saw previously also had their set versions. For example, we saw the getDate method, and we also actually have the setDate method. So just like the getDate gives you the date, the setDate can be used to actually set or change the date. So in this case, we have the setDate method, and we're changing the date from 1 day before Unix epoch to 14. So in this case, instead of being 31 December, it'll be 14 December. We also have set month. So in this case, we're setting the month to 8. We also have set full year. In this case, it'll be 2003. Set hours, we can also set the hours, then minutes, of course seconds, and again milliseconds. Now, after using all these methods on the date object, what's the value of the date object right now? Well, the value of the date object has changed to September 14, 2003, 21:56:13 UTC time. So all the methods that we applied actually changed the date object from 1 day before Unix epoch to Sunday, September 14, 2003, 21:56:13, and of course it also have 593 milliseconds, although it's not showing here. And that is how you can use the set methods in order to actually modify and change the value of the date object. And of course, all the set methods also have their UTC equivalents. So set UTC date, also have set UTC month, set UTC full year, set UTC hours, set UTC minutes, set UTC seconds, and of course set UTC milliseconds. And again, because our date object is actually created in the UTC time zone, these methods are more or less equivalent. They don't really change anything that much. But in the case where the new date object is actually created in a time zone other than UTC, then using the normal non-UTC set methods will set the date and time in the local time zone. But using the UTC methods, you can set the time and date based on UTC time and date. So in this case, although the result is the same, but if the time zone was different, the UTC methods could be used to set the time and date based on UTC time and not the local time zone. Now, you can also format the date outputs. So when you have a date object, you're not just limited to outputting it in the standard ISO format. You can actually change the format and output the date in a different way and style. For example, in this case, we're creating a new date again, so var date equals new date, which in this case will be again the same date as the previous examples. And now let's take a look at different date output methods. First, we have the toDateString method. The toDateString method will output the date portion of a date object in a human-readable format. So in this case, it results in Tuesday, April 10, 2018. So the first part of the example above. We also have the toTimeString, which outputs the time portion of the date object, also in a human-readable format. So in this case, it's 22:58:55 UTC time. So by using the toDateString and the toTimeString, you can extract the date portion or the time portion from a date object. We also have toISOString. The toISOString method can be used to output the date in a standard ISO format, which looks kind of like this. It starts with the year, and then with a dash or a hyphen we have the month, and then the date. So in this case it's 2018 4/10, and then the time is specified with capital T, and then we specify the time 22:58:55.309, which is the number of milliseconds, and then finally Z. Z means it's UTC time. We also have date.toUTCString, which outputs it like the UTC string that we just saw. In this case, it's Tuesday, 10 April 2018, 22:58:55 GMT. So using these methods, you can change the output of a date object and specify how you want the date or time to be displayed. Hello everybody, and welcome back to Expert.js. I'm Abrar. In this video, we're going to be talking about comparison and logical operators. These operators are used in conditional statements in JavaScript, and they're important for adding dynamic logic to your code. So let's see how they look. So JavaScript has a lot of comparison operators. These operators usually compare two values and tell you whether the comparison is true or false. So let's take a look. The first comparison operator is the equality operator, and it's written as double equal signs. So double equals is the equality operator in JavaScript, and this is used to test for equality in two values. So it's used to test whether two values are same or not. So if the two values are equal, then the result is true. If they're not, then the result is false. So in this example, we have 3 equals 3, which means 3 is equal to 3. And of course, we know that 3 is indeed equal to 3. That's why the result returns true. But if we wrote 3 equals 4 or anything other than 3, then it would have been false. Another operator is the strict equality operator, and it's written as 3 equal signs side by side. Now the strict equality operator also checks for equality, which means it also checks whether the two values are equal or not. But it takes into account the data type of values as well. So for the equality operator, the data type doesn't matter. If the values are the same, then it will return true. But with strict equality operator, the value must be the same and the type must be the same as well. So 5 the number, strict equality 5 the string returns false. However, this would have returned true if we used the normal equality operator. But in strict equality, we need to take into consideration the data type as well. So numbers cannot be equal to strings and vice versa. That's why strict equality operator also takes into consideration the data type along with the value when evaluating the equality. And that's why 5 is strictly equal to string 5 is false. The opposite of the equality operator is the inequality operator. The inequality operator works exactly opposite as the equality operator, returning true if the values are not equal and returning false if the values are equal. The inequality operator is written as an exclamation sign and then an equal sign. So in this case, we have two strings. String A is not equal to string B, and the result is true because string A is not actually equal to string B. So you can read it as string A not equal to string B, and that is true. The opposite of the strict equality operator and the counterpart of the inequality operator is the strict inequality operator, and it's written as an exclamation sign followed by two equal signs. And the strict inequality operator, just like the strict equality operator, also takes into consideration the data type when evaluating inequality. So if the two values are not the same and the data type is not the same as well, then it returns true. Otherwise, it'll return false. So in this case, string A is not equal to string A, which returns false because string A is indeed equal to string A. So string A not equal to string A is not true. That's why it returns false. Then we have the greater than operator, which is written as a greater than symbol. And this operator will tell you whether a value is greater than another value. So for example, 7 is greater than 3 will return true because indeed 7 is greater than 3. The opposite of the greater than operator is the less than operator, which is written as the less than symbol. The less than operator, just like the greater than operator, will tell you whether a value is less than another value. So for example, 4 is less than 2 is false because 4 is not less than 2. 4 is bigger than 2. So 4 less than 2 returns false. Then we have the greater than or equal to operator. This works just like the greater than operator, but it'll also return true if the values are the same. So the greater than or equal to operator is written as a greater than symbol and then an equal sign. So 10 greater than or equal to 10 is true because 10, while it's not greater than 10, it is equal to 10. That's why it returns true. However, if we use just the greater than operator, so for example 10 is greater than 10, then it will return false because 10 is not greater than 10. 10 is equal to 10. And similarly, we have the less than or equal to operator, which is written as a less than symbol and then an equal sign. And this operator will return true either if the first value is smaller than the second value or they are the same. So for example, 9 is less than or equal to 7 is false because 9 is not equal to 7 and it's not less than 7 as well. So ultimately it returns false. These are a few comparison operators available in JavaScript, and these are the ones you'll be using most often. So let's take a more detailed look at each one of them. First, we'll start with the equality operator, and we'll see some examples. So let's start with some simple examples. 3 is equal to 3, so 3 equals 3, which returns true because 3 is indeed equal to 3, right? So that's how the equality operator works. It checks whether the two values are equal or not. However, the data type doesn't matter. So in this case, we have a 3 string and a 3 number, and they're still equal in the equality operator. So string 3 equals 3 is still true because the data type doesn't matter. If the values are the same, then it'll return true. So in this case, although one is a string and another is a number, the value of both are the same, which is 3. That's why it returns true, regardless of the data type. Now the equality operator doesn't only work on numbers, it can also work on strings. So for example, string apple equals string apple, which is true because string apples is equal to string apples. In order for two strings to be equal, they must be exactly the same with the same case, same letters, and same sequence. Now the Boolean value false, if you remember, is actually treated as 0 in JavaScript and in general computer programming. That's why 0 is equal to false returns true, because false is treated as 0 as well. That's why the data type doesn't matter. One is a number, another is a Boolean, but the values are the same. That's why it returns true. And similarly, the boolean true is regarded as 1 in JavaScript and in general computer programming. That's why the string 1 is equal to true also returns true, because string 1, which has a value 1, and the true boolean, which also has a value 1, they're the same. That's why it returns true. Now do remember that with equality operators, null is equal to undefined. So although they're not the same, there's difference between null and undefined, because null means a deliberate non-value and undefined means the value is just not defined yet, but with equality operator, it is treated as the same. That's why they're treated as equal, and it returns true. And finally, it works on booleans as well. So false is equal to false, which returns true, because false is equal to false. Of course, if the values are not the same, the equality operator will return false. So for example, 3 is equal to 4 returns false, because 3 is not equal to 4. The values don't match. Also note that the string true is not equal to the boolean true. These don't have the same values. That's why it's false as well. Now here's a very important thing to remember. In JavaScript, two different objects, even if they're identical, can never be equal to one another. Okay, remember that. Two objects, even if they're identical, they can never be equal. Objects can only be equal if one is referenced by another. But if they're two separate objects, even if they're identical, they're not equal. So arrays are a type of objects in JavaScript. So here we have two identical arrays. The first array has the value 1 and 2. The second array has the value 1 and 2 as well. But although they have the same values, they're not the same, because no two objects in JavaScript can be the same, even if they contain the same values. And this might come off as a surprise if you're using the new string method instead of just using the string literal method. So remember, in the very first modules of this course, we told you that not to use the new string method because it creates a string object and not a string literal. And because objects are not equal to one another, if we have two string objects with the same value, for example, we have variable a which contains new string abc, so it contains a string object with the value abc. And then we have a variable b which also contains a string object with the value abc. So you might think that variable a and variable b are equal to one another. Unfortunately, they're not. A equals to b returns false, because variable a contains a string object, variable b contains another string object. That's why two objects in JavaScript can never be the same. That's why although they contain the same value, both has the value the string abc, but because they're objects, the different objects are never equal to one another. That's why a is not equal to b. A equals to b returns false. So here we created two variables with two string objects. However, if we created one variable with a string object, say var a equals new string abc, but instead of var b equals to another new string abc, if we wrote var b equals a, so b is referencing to a, then a equals to b would have returned true. That's why we shouldn't use the new string syntax and just use string literals instead, because that might cause a lot of problems and bugs. Okay, now let's talk about strict equality operators. First, a simple example. 5 is strictly equal to 5, which returns true because 5 is strictly equal to 5, right? And of course, it works on strings as well. So the string orange is strictly equal to the string orange, and because they're identical, they're also true. And false is strictly equal to false, and because they are indeed equal, it returns true. However, this is where things get interesting. The number 5 is not strictly equal to the string 5. So if you remember from the equality operator, in the equality operator, this would have returned true because the equality operator only cares about the value and not the data type. So the number 5 would be equal to the string 5 and it would return true. However, with strict equality operator, not only the values will have to be the same, but the data type will have to be the same as well. So a number can never be equal to a string, even if they contain the same value. That's why it's strict equality, because it doesn't only take into consideration the value, but also the data type of the values. So the number 5 is not strictly equal to the string 5, and that returns false, because number 5 and string 5, although they have the same value, 5, they're different data types. That's why they're not equal. And of course, JavaScript is extremely precise with numbers. So 23 is strictly equal to 23.001 will return false, because they're not exactly the same. In order for two numbers to be equal, they must be exactly the same. And in order for two strings to be the same, they must be exactly the same as well. So the string apple with lowercase letters is equal to string apple with uppercase letters returns false, because these two strings are not the same. They need to be exactly the same for the equality operation to return true. And of course, because the strict equality operator doesn't only take care of the value but also the data type, things such as 0 is strictly equal to false returns false, because 0 and false are different data types and they can never be the same. 0 is a number, false is a boolean, and that's why they're not the same. Although the same comparison with the equality operator would have returned true, however with strict equality it returns false. Similarly, string 1 is strictly equal to true also returns false, because they're different data type. One is a string and another is a boolean. However, with the equality operator, it would have returned true. And because null and undefined is different values in JavaScript, they're not strictly equal. So null is strictly equal to undefined, or the other way around, returns false. And again, two separate objects can never be the same in JavaScript. So two objects, array with value 1, 2, and another array with value 1, 2, is not equal to one another. It returns false. And the same thing happens with string objects. If you have two string objects with the same value, even then they're not the same. So var A contains a new string with value ABC, and var B contains another string object with value ABC. But A is not strictly equal to B. A is strictly equal to B returns false. Now let's talk about inequality. So you can think of the inequality operator as completely the opposite to the equality operator. So where the equality operator would return true, the inequality operator would return false. And where the equality operator would return false, the inequality operator would return true. So it works exactly the opposite as the equality operator. So in short, the equality operator returns true if the values are not equal, and returns false if the values are indeed equal. So 4 is not equal to 5 returns true, because 4 is not equal to 5, right? 4 is a different number, 5 is a different number. So 4 is not equal to 5 is true. And similarly, the string orange is not equal to string apple. It's also true because they're different strings. And again, objects, even if they have the same values, are never the same. So here we have two identical arrays, but because they're different objects, the first array is not equal to the second array, and it returns true. Now, if the values are indeed equal, then the inequality operator actually returns false. So for example, 3 is not equal to 3 is false, because 3 is indeed equal to 3. That's why 3 is not equal to 3 returns false. And just like the equality operator, the inequality operator only takes into consideration the value and not the data type. So the string 3 is not equal to the number 3 is false, because they are the same. They're regarded as the same. Although the one is a string and another is a number, because they have the same value, they're treated as equal. And the string 3 is not equal to the number 3 returns false, because the inequality operator considers them the same. So similarly, a string apple is not equal to another string apple is false as well, because apple is equal to apple. So the apple is not equal to apple returns false. Now 0 is not equal to false, which is also false, because with equality operations, 0 is equal to false, right? Because both have the value 0. The number 0 has a value 0, and the boolean false is regarded as 0 as well. So 0 and false are equal, and 0 is not equal to false is false, because they are indeed equal. And similarly, string 1 is not equal to true is also false, because these two values are considered equal with the inequality operator. And similarly, null is not equal to undefined is also false, because with the inequality operator, just like the equality operator, null and undefined is equal. That's why they're not equal returns false. Similarly, booleans such as false is not equal to false is also not true. They return false, because false is equal to false. And that's why false is not equal to false returns false. Now the counterpart of the inequality operator and the opposite of the strict equality operator is the strict inequality operator. So just like the inequality operator, the strict inequality operator will return true if the two values are not equal, but it also takes into consideration the data type along with the values themselves. So for example, 3 is not strictly equal to 5 returns true because these two are not the same. However, the number 3 is not strictly equal to the string 3 returns true because the strict inequality operator regards these two values as different. Although the value is the same, they're different data types. That's why number 3 is strictly not equal to the string 3 returns true because these are not actually equal. Similarly, a string pineapple is not strictly equal to the string banana returns true because these two are different strings, they're not equal. And of course, two different objects can never be equal. So two arrays with values 1 and 2 is not equal to one another and it returns true. However, if we have the same value, for example 60 is not strictly equal to 60, it returns false because 60 is indeed equal to 60. That's why 60 is not equal to 60 is not true, it's false. And similarly, if the two strings are exactly the same, so banana is not strictly equal to banana returns false because they are indeed equal. And similarly, 0 is not equal to false actually returns true because they are different data types, that's why they're not equal. They're not regarded as the same. So 0 is not equal to false actually returns true. And similarly, the string 1 is not equal to true also returns true. Because although their value is the same, both have value 1, but they're not the same data type. That's why they're not equal. And null is not strictly equal to undefined, which returns true, because these two values are different with strict inequality. And false is not equal to false returns false, because false is equal to false. That's why false is strictly not equal to false is not true, it returns false. Now let's talk about the greater than operator. The greater than operator returns true if the first value is greater than the second value, otherwise it returns false. So starting with a simple example, 5 is greater than 2, which is true, that's why it returns true, because 5 is indeed bigger than 2. And similarly, positive numbers are always bigger than negative numbers. So 8 is greater than minus 3, which is true. And when it comes to negative numbers, the smaller the number is, or the closer it is to 0, the bigger it is. So minus 2.5 is actually bigger than minus 22, and it returns true. Now this also works with strings as well. So just like with numbers, you can do this on strings. With strings, A is the smallest, then B, then C, then D, and all the way up to Z. So B is greater than A returns true, because B is indeed greater than A. Similarly, if numbers are actually typed as strings, for example the string 2 is greater than string 1, is true, because even with numbers inside strings, 0 is the smallest, then 1, then 2, then 3, and so on. However, if the first value is actually not greater than the second value, the greater than operator returns false. For example, 6 is greater than 90, which is not true, returns false. And similarly, minus 45 is greater than minus 7, also returns false, because minus 45 is not greater than 7. And of course, if the two values are equal, they're not greater than one another, they're equal to one another. That's why 5 is greater than 5 returns false, because 5 is not greater than 5, they're equal. Now when it comes to strings, if you have numbers and letters at the same time, the numbers are smaller. So 0, 1, 2, 3, these numbers are smaller. After these numbers, then we have uppercase letters. For example, uppercase A, uppercase B, and after those, we have lowercase letters, lowercase a and lowercase b. That's why the string 0 is greater than string b returns false, because that's not true. String 0 is a lot smaller, and string lowercase b is actually a lot bigger. However, this can cause some problems. For example, with strings, the greater than calculations are actually done character by character. So the first character, then the second character, then the third character, and so on. So with numbers, 12 is greater than 2 would return true. But if they're typed as strings, so for example, string 12 is greater than string 2 is actually false. Why? Because string 12 starts with 1 and string 2 starts with 2. And because strings are matched from left to right, character by character, 2 is actually bigger than string 12. And that's why if you want correct numerical comparisons, you should convert the strings into numbers. Otherwise, because of character by character matching, the expression might return false. Now the opposite of the greater than operator is the less than operator, which returns true if the first value is less than the second value. So 6 is less than 90 returns true because 6 is indeed smaller than 90. And as with negative numbers, minus 45 is less than minus 7, which also returns true because minus 45 is indeed less than minus 7. And it works on strings as well. So remember, with strings, 0, 1, 2, 3, these are the smallest, then uppercase letters, and then lowercase letters. And with strings, characters are matched from left to right, character by character. That's why the string 0 is less than the string b returns true, because in string comparisons, 0 is smaller than b. And similarly, the string 12 is less than string 2, which returns true, but if they were numbers, it would have returned false. But because they're strings and the matching is done from left to right, character by character, 12 is actually smaller than 2. Now, if the first value is actually not smaller than the second value, the less than operator returns false. So 5 is less than 2 returns false. Similarly, 8 is less than minus 3 also returns false because 8 is bigger than minus 3. It's not less than minus 3. And with negative numbers, for example, minus 2.5 is less than minus 22 is also false. And if the numbers are the same, then the less than operator, just like the greater than operator, returns false. So 5 is less than 5 is false because 5 is equal to 5. Because the first value is not even a bit less than the second value. They're exactly equal. And with strings, string b is less than string a returns false because b is bigger than a when it comes to strings. And similarly, string 2 is less than string 1 returns false. Now let's talk about the greater than or equal to operator. The greater than or equal to operator works exactly like the greater than operator, but it also returns true if the values are equal. So it's pretty simple. So 5 is greater than or equal to 2, it returns true. Because 5 is indeed greater than 2. It's not equal to 2, but it doesn't matter. 5 is greater than 2, and that's why it returns true. 7 is greater than or equal to 7 returns true. If we wrote 7 is greater than 7, it would return false because 7 is not greater than 7. But 7 is greater than or equal to 7 returns true because although 7 is not greater than 7, it is equal. So if it's either bigger, it'll return true, or if they're the same, it'll return true as well. And it works for strings as well. So the string z is greater than or equal to the string c, which returns true because z comes after c. And similarly, string b is greater than or equal to string b also returns true because although it's not greater, they are the same. However, if the first value is not greater than the second value or they're not equal as well, it returns false. So 4 is greater than or equal to 6 returns false because 4, first of all, is not greater than 6 and it's not equal to 6 as well. So neither returns true, so it's false. And similarly, string C is greater than or equal to string D returns false, because string C is not greater than string D and they're not equal as well. The opposite is the less than or equal to operator. So 2 is less than or equal to 5 returns true, because 2 is indeed less than 5. And if they're the same, it returns true as well. So 3 is less than or equal to 3, which returns true, because while 3 is not less than 3, it is equal to 3. And string C is less than or equal to string Z, which also returns true. Similarly, string V is less than or equal to string V, returns true because they are the same. And 6 is less than or equal to 4 returns false, because 6, first of all, is not less than 4 and it's not equal to 4 as well, so ultimately it returns false. And string D is less than or equal to string C returns false as well, because D is bigger than C. They're not equal either. Now let's talk about logical operators. Now we've seen comparison operators, which compares two values and returns true or false depending on the condition. However, you can mix and match these using logical operators. So here's how they look. First of all, we have the logical AND, which is written as two AND symbols. So the logical operators, such as the logical AND, can be used to bind two comparison operators together. And it will only return true if all conditions return true. So in this case, 1 is less than 3 and so in this case, 1 is less than 3 and 2 is strictly equal to 2 returns true, because both of these conditions are true. So in order for logical AND to return true, all of the conditions defined must be true. Even if one of them returns false, the whole condition will return false. And you also have the logical OR operator, which is written as double pipe symbols. And the logical OR operator returns true if at least one condition returns true. So in this case, 3 is less than 2 or 6 is not equal to 6 ultimately returns false. Why? Because neither of them are true. 3 is less than 2 is false and 6 is not equal to 6 is false as well. That's why ultimately the full calculation results false. But if among several conditions only one of them returned true, then the whole value would return true. And we also have the logical NOT, which means condition must be false. So in order for the logical NOT condition to be true, the condition actually must be false. So for example, not 5 is strictly equal to 6 returns true, because 5 is strictly equal to 6 returns false, and logical not false means true. So logical NOT actually inverses the result of the condition. If it's false, it returns true. If it's true, it returns false. Let's take a deeper look at each one of them. We'll start with logical AND. So the logical AND only returns true if all the conditions defined return true. Even if one of them returns false, the whole condition becomes false. So for example, 4 is less than 5 and 3 is strictly equal to 3 returns true, because both of these conditions are true. And you can also chain as many conditions as you want. Here we have 3 conditions side by side. So 5 is greater than 3 and 2 is strictly equal to 2 and 8 is less than or equal to 8 returns true, because fortunately all these conditions return true. Even if one of them returned false, the whole condition would have been false. So here, for example, we have 6 is less than 5 and 3 is not equal to 4. Now unfortunately here, although the second condition is true, 3 is not equal to 4, it returns true, but the first condition is false. And because in order for the logical AND operator to return true, all conditions must be true, this returns false, because one of them has returned false. All of them must be true in order for the whole condition to be returned true. And similarly, if you have the boolean false in a logical AND condition, it'll always and automatically return false. Because false means the condition returned false, and even if the second condition returns true, which is in this case, it doesn't matter, it returns false. Also note that when it comes to logical AND, just like normal JavaScript, is executed from left to right. So the first condition is executed, then the second one, then the third one, and so on. And during this execution, if one of these return false, then the condition automatically defaults to false, because if one of them returned false, then it doesn't matter what the other values return. If one of them is false, then the whole condition will be false. That's why it's a shortcut that JavaScript uses to script through all the other conditions, and if a false condition is incurred, it automatically stops execution and returns false. Now we have the logical OR. The logical OR operator returns true if at least one of the conditions return true. So for example, 5 is greater than 3 or 6 is less than 6 returns true, because although the second condition is not true, the first one is. And in order for a logical OR condition to return true, only one true condition is required. And just like logical AND, you can chain operations side by side as many as you want. So 3 is greater than 3, or 4 is strictly equal to 4, or 8 is not equal to 7 returns true. Here, the first condition is false. However, the second condition and the third condition is true. That's why it returns true. And just like with logical AND, when this code is executed from left to right, the first condition returns false, and then the second condition returns true, and the execution is immediately stopped. Because we've incurred a true value, which means the whole condition is true, which means 8 is not equal to 7 doesn't even need to be executed. JavaScript shortcuts and defaults to true for this condition. Similarly, if you have true or 3 is strictly equal to 4, it returns true. Because the first condition returns true, so the second condition is not even executed, it doesn't even matter. However, if none of the conditions return true, then ultimately the result is false. So for example, 8 is greater than 10 is false, or 4 is less than or equal to 2, which is also false. So if both of them are false, meaning all the conditions are false, it returns false. Finally, we have the logical NOT. The logical NOT actually inverses the result of the calculation. So if the condition is true, it returns false. If it's false, it returns true. So for a logical NOT to be true, the condition must actually return false. So for example, logical NOT 5 is greater than 7 is true, because actually 5 is greater than 7 is false, and logical NOT inverses that false into true. Similarly, logical NOT 4 is greater than 2 returns false, because 4 is greater than 2 is true, and logical NOT true means false. And of course, logical NOT false is true, because remember, logical NOT inverses the Boolean value. So logical NOT false actually inverses false to true. And similarly, logical NOT true is false. Logical NOT 5 is false as well, because 5, although it's not a condition, 5 is a number. And remember, in JavaScript, anything that is not 0, -0, null, undefined, nan, or an empty string is truthy, which means it has a value true. So the 5, the number, actually is true. So logical NOT 5 means false. Similarly, not null is true, because null is regarded as false. So not null is true. And not undefined is true as well. Now here's the funny thing. If you have two logical NOT operators side by side, they actually cancel out one another. So logical NOT 5 is greater than 9 ultimately returns false, because 5 is greater than 9 returns false, logical NOT false returns true, and logical NOT true returns false, which means they cancel each other out, and logical NOT 5 is greater than 9 is actually the same as 5 is greater than 9, which ultimately returns false. Hi there, and welcome back to another video of Expert.js. My name's Abrar, and I'm going to be your instructor for this video. In this video, we're going to be talking about the if conditional in JavaScript. Now, conditionals are used to add dynamic behavior to your code, and that's why they're very, very important. So let's see how they work. First, we'll talk about the most common type of conditionals, the if conditional. Now, the if conditionals, or the if statements, can be used to run a block of code only when a condition is true. So, only if a predefined condition is true, only and only then the code inside the if block will run. Otherwise, the code will not run. So let's see an example. So first, we define the if block and the condition, and we do that using the if keyword. The if keyword is how we start the if block. So first we type in if, And then inside parentheses is where we define the condition. So in order for the code inside the if block to be executed, the condition inside this pair of parentheses must return true. So if the condition inside the pair of parentheses returns true, the code will be executed. Otherwise, the code will not be executed. So in this case, the condition is very simple. The condition is 2 is less than 5, which we know is true. And then we start the curly braces. And then inside the pair of curly braces is where we add the code that we want to epoch. So in this case, the code is simply logging to the console 2 is smaller than 5. So console.log the string 2 is smaller than 5. And then we put in the ending pair of curly braces. And all this together creates an if conditional block. So how does this work? Well, when JavaScript encounters the if conditional, it'll first execute the expression inside the parentheses. So inside the parentheses, we have 2 is less than 5. Then it'll convert it into a Boolean. So in this case, 2 is less than 5 will return true because it is true, right? We're using the less than comparison operator inside the if block. So this condition will return true. And thus, the code inside the block, which is the code inside the pair of curly braces, will execute. And the result in this case will be the string 2 is smaller than 5 is logged to the console. So the code inside the curly braces did execute, and that was because the condition inside the parentheses was true. If the condition had been false, this code would not execute. This is how you use if blocks and conditionals in JavaScript. You're telling JavaScript to execute some code if and only if a certain condition is true. If that condition is true, that code will get executed. Otherwise, it won't. And as for the condition inside the if block, this is where you can use all the comparison operators and the logical operators we learned in the previous video. Now let's take a look at another if block. So in this case, we're starting the statement again with if, and then inside the parentheses, we're defining the condition. In this case, the condition is 7 is less than 5. Now we know that 7 is not less than 5, 7 is greater than 5. So this condition will return false. But we'll go ahead with the if block anyways, and let's see what happens. In this case, we have another statement inside the curly braces, which logs to the console 7 is smaller than 5. So console.log the string 7 is smaller than 5. And then we end the pair of curly braces. However, because the condition inside the if block is not true, this code is never executed. So if you run this code, nothing will be logged to the console, because the code inside the pair of curly braces, which logs to the console, it's never executed. The code is there inside the JavaScript file, but it's never executed. Why? Because the condition inside the if block did not return true. It returned false. Because as we know from the previous video, 7 is less than 5 will return false. And that's what it did. The condition inside the parentheses returned false. And that's why the code inside the curly braces was not executed. Now do note that we're using console.log inside the pair of curly braces just for demonstration purposes. You can run almost any type of code in there, anything you want. We'll see more examples in just a minute. Okay, now let's step things up a little. Let's define a variable x, and give it the value, the number 9. So var x equals 9. And then we can use some more comparison operators that we learned in the previous video. For example, the strict equality operator. Now, if you remember from the previous video, the strict equality operator returns true only if the two values are the same and the two valued data types are the same as well. So in this case, we're defining if, and then inside the parentheses, we're saying x is strictly equal to 9. And then we're starting the pair of curly braces. And inside the curly braces, we're logging to the console the string x is 9. So console.log x is 9. And then we end the pair of curly braces. And the result of this code is we get the string x is 9 logged to the console. So how does this work? Well, we have a variable x which has a value 9. So x is equal to 9. And then inside the parentheses, we define the condition. The condition is x must strictly be equal to 9. Now because x is equal to the number 9, then x is strictly equal to 9 returns true. And because the condition inside the parentheses returns true, the code inside the if block, that is the code inside the curly braces, is executed. And that's why we get the string logged to the console. However, if x had a different value, anything other than 9, then x is strictly equal to 9 would return false, and the string would not be logged to the console. Now let's see some more examples. So here we define another variable, var fruit, which equals the string banana, okay? Okay, now we're defining our if block, and the condition is fruit is strictly equal to apple. And then inside the pair of curly braces, we are logging a string to the console. And then we end the pair of curly braces. Now this string is never logged to the console. This code is not executed. Why? Because fruit is equal to banana. So fruit is not strictly equal to apple. So the condition inside the if block, that is the condition inside the parentheses, which says fruit is strictly equal to apple, returns false, because fruit is strictly equal to banana, not apple. So fruit is strictly equal to apple returns false, and that's why the code inside the curly braces, which is the code inside the if block, does not run. So console.log code never runs, and we don't get any string logged to the console. But if fruit was equal to apple, then fruit is strictly equal to apple would return true, and we would get the string I love apples logged to the console. Now one good thing about JavaScript code is that it's often human readable and intuitively understandable. So if you're still confused, you can almost read the if block such as if fruit is strictly equal to apple, then log to the console I love apples, right? It's almost in a human readable form. We have a pair of parentheses and curly braces, but you can almost read this JavaScript code as if fruit is strictly equal to the string apple, then log to the console I love apples. And that's how the if statement works. Now let's see some more complex examples. So we'll define two variables in this case, x and y. Var x will equal 8 and variable y will be equal to 3.42. So we have two variables x and y which equals 8 and 3.42 respectively. Now let's define a bit more complex condition inside the if block. So in this case, as you can see, we're not only using comparison operators, but we're binding two comparisons together using a logical operator. So in this case, we're defining if, and then inside the parentheses, we're saying x is less than 10 and y is strictly equal to 3.42. Now, again, in order for the code inside the if block to be executed, the condition inside the parentheses must return true. And in this case, we have two conditions inside the parentheses binded together by a logical AND. And just like we learned from the previous video, if a condition has a logical AND, then in order for the whole condition to return true, all the individual conditions must return true. Even if one of the conditions return false, the whole condition will become false. Now in this case, x is equal to 8. So the condition x is less than 10 will return true because x is less than 10 is equal to 8 is less than 10. And 8 is indeed less than 10. So x is less than 10 will return true. So the first condition will return true. Now for the second condition, which is y is strictly equal to 3.42, also returns true because y is equal to 3.42. That's why y is strictly equal to 3.42 returns true. So the first condition on the left hand side returns true, and the second condition on the right hand side also returns true. And because both of these conditions return true, bounded by the logical AND operator, the whole condition returns true. So this whole condition inside the if block returns true, and that's why the code inside the curly braces will be executed. And in this case, the code is simply console.log condition is true. And then we end the pair of curly braces. And the result is we do indeed get the string condition is true logged to the console. And that's because the code inside the parentheses returned true. We had two conditions bounded by the logical AND operator, and both of them returned true, and that's why the whole condition returned true, and that's why the if block got executed. Now let's have the same setup again. So variable x equals 8 and variable y equals 3.42. But in this case, let's mix up the condition a little bit. So if inside the parentheses, instead of using the logical AND operator, let's use the logical OR operator, which is double pipes. Now in this case, we're defining two conditions again. X is less than or equal to 5, or y is not strictly equal to 9. Now in this case, remember with the logical OR operator, at least one of these conditions will need to return true. If one of them returns true, then the whole condition will be true. It doesn't matter what the other conditions return. Even if all the conditions return false and only one of them returns true, still the whole condition will return true. So in this case, the first condition, which is x is less than or equal to 5, returns false, unfortunately, because x is equal to 8 and 8 is not less than or equal to 5. So x is less than or equal to 5 returns false. However, the second condition, y is not strictly equal to 9, does return true, because y is equal to 3.42, which is not equal to 9. So y, or 3.42, is not strictly equal to 9, returns true. And that's why, because the second condition returns true, the whole condition will return true. It doesn't matter what the first condition returns. So even though the first condition returned false, because we're binding these two conditions together using the logical OR operator, the whole condition returns true. So x is less than or equal to 5 or y is not strictly equal to 9 returns true. And that's why the code inside the curly braces is once again executed. And the result is again the string condition is true is logged to the console. And that's how you can have very complex conditions inside the if block. And the code inside the if block will only get executed if the whole condition returns true. For the condition inside the if block, you can have all types of comparison operators, multiple comparison operators binded together by logical operators, and even multiple logical operators nested inside one another. And the if block will only get executed if the whole condition returns true. Now here's a cool example of using the if block in a real-world practical condition. So let's say we have a variable called colors. So variable colors equals an array which contains two strings, black and yellow. So we have variable colors which contains an array with two elements, the two strings black and yellow. Now we're defining the if block, and then inside the parentheses we're defining the condition. Now in this case the condition is if not colors.includes aqua, then we'll execute some code. Now let's take a step back right now and find out what this code does. Now the colors is a variable which contains an array, and .includes is a method. Now if you remember from the array module, includes is a method available to arrays that tells you whether a value exists inside the array or not. So for example, in this case, colors.includes the string black would return true because the string black is inside the colors array. Similarly, colors.includes the string yellow would also return true because yellow is also present inside the colors array. But anything other than these two would return false. So in this case, colors.includes aqua would return false because aqua is not included in the colors array. So colors.includes aqua returns false. But we're using the logical NOT operator. So see the exclamation sign at the very beginning? That is the logical NOT operator. And remember, the logical NOT operator inverses the condition. So if it's false, it returns true, and if it's true, it returns false. So in this case, colors.includes aqua would return false, and because we were using logical NOT, then it would actually return true, and the code inside the if block will actually get executed. If we did not have the logical NOT operator, then the condition would return false and the code would not be executed. But by using the logical NOT operator, we're inversing false into true and thus making the code inside the if block execute. So what do we do inside the if block? We're pushing the string aqua into the colors array. So what we're basically doing with this if block is we're checking whether the string aqua is included in the colors array or not. And if it's not, then we're pushing the string aqua into the colors array. So if the colors array already contains the string aqua, the code will not be executed. Otherwise, if the string aqua is not included in the colors array, then it will be included in the colors array. So in this case, you can read this if statement out loud as somewhat like, if the colors array doesn't contain aqua, then add aqua to the colors array, right? So this is a very useful trick that you can use to search for a value inside an array, and if it's not there, you can manually add it to the array inside the if block. And now if we check the colors array, we can see it contains the values black, yellow, and aqua. And that's because the condition inside the if block returned true, and that's why colors.pushAqua ran. And that's why the colors array now contains black, yellow, and aqua. But now if you run this code once again with the colors array containing aqua, then another aqua won't be added because the condition would return false and the code will not be executed. So this is a bit of code that checks whether a string or another value is present inside an array, and if it's not, it adds it to the array. Now let's take a look at a more practical example of using the if block. So let's say you're developing an online store website, such as an e-commerce website, and inside the e-commerce website, you are running a marketing campaign. And according to this marketing campaign, if the total order value of a customer is at least $50, then they get a $10 discount. So in the shopping cart page, you have to calculate whether the customer value is more than or equal to $50 or not. And if it's at least $50, you minus $10 from their order. Otherwise, you don't do anything, and they have to pay the full price. So this is a very simple marketing campaign where you're giving a $10 discount if the order value is at least $50. Very simple, right? And you might have some JavaScript code inside your shopping cart page to handle this. How would you do it? Well, let's say we have a variable called order total, which equals the total order value the customer has. So in this case, we're defining a variable var order total, which equals 69. Now we're manually defining the total order value, but in a real life e-commerce store, you'll likely be getting this order total value from another script or from the server or from any other place. But for this example, we don't want to complicate things, so we're manually inputting a number as the total order value. So in this case, order total is equal to 69 or $69. Now we need to define the code that gives a $10 discount if the order value is at least 50. And we can do that using, you guessed it, the if block. So this is how it looks. So we're saying that if the variable order total is greater than or equal to 50, then minus 10 from the order total variable, and then end the code block. So how does this work? Well, first we're defining the order total variable, which contains a value 69. So the variable order total contains 69. Then we're defining the if block. This is where we check whether the order total is at least $50 or not. If it is, then we give the $10 discount, otherwise we don't. So how do we do that? Well, we check whether the order total value is equal to or greater than $50. So order total is greater than or equal to $50. So in this case, this condition will only return true if the order total is either $50 or more than $50. However, if it's less than $50, this condition would return false and the code inside the if block will not be executed. Fortunately, in this case, the customer order value is 69. So 69 is greater than or equal to 50. And this condition returns true. So order total is greater than or equal to 50 returns true. And thus the code inside the if block gets executed. So what are we doing in the code? Well, we're saying order total minus equals or subtraction assignment 10, which means we're minusing 10 from the order total value. Now, if you remember the previous video, you should be familiar with the subtraction assignment operator, which is the minus equals. We're basically telling order total minus equals 10 means order total equals order total minus 10. So JavaScript will take the value of order total, which is 69, it'll minus 10 from it, so it'll be 59, and this will be the new value reassigned to the order total variable. That's how the subtraction assignment operator works. And now, if we check the value of order total, we can see that it's indeed 59. So this code works. Because we have a total order value of $69, which is more than $50, the code inside the if block did get executed and the $10 discount was applied. So now the order total has been decreased from 69 to 59, and the customer is very happy. But what if the order total value is less than $50? So in this case, we're running the same example, but with var order total set to 25, which is less than 50. And we're defining the same condition: if the order total is greater than or equal to 50, then minus $10 from the order total value. And now if we check the value of order total, as you can see, it is still 25. So in this case, 25 is not greater than or equal to 50. So the condition inside the if block returned false. And that's why order total minus equals 10 was not executed. That's why the value of the order total variable was untouched. And that's why the order total variable still contains 25. And no $10 discount has been applied. So this code does indeed work. And that's just a simple example of how you can use the if block to add dynamic logic and behavior to your code. Hello everybody, and welcome back to Expert.js. I'm Abrar, and I'm going to be your instructor for this video. In this video, we're going to be talking about if-else statements. Now in the previous video, we talked about if conditionals and how they work. However, the if conditional can actually be extended with an else statement. So let's see how that works. Okay, so we learned in the previous video that in JavaScript, in order to add dynamic logic and behavior to your code, you use the if conditional. And inside the if conditional, you define a condition. And if the condition is true, only then the code inside the if block will be executed. Otherwise, it won't run. However, this is very limited. For example, in some cases, we might want to run another set of code if the condition is false. And we can do that by pairing an if statement with an else statement. Let's see how that works. So first, we start off with a simple if statement. In this case, the condition is if 2 is bigger than 16.4. Now we know that 2 is not bigger than 16.4, so this will return false, and the code inside the if block will actually not run. But let's go with it. So if 2 is bigger than 16.4, then we will log to the console the string 2 is bigger than 16.4. So console.log 2 is bigger than 16.4. Now instead of just ending the block right there, we can actually extend this if conditional with an else statement. So we type in the ending pair of curly braces, and then we type in else and then start another block. So instead of just ending the if statement, we extend it with an else block. So we type in else and then another pair of curly braces. And here we can define the code that we want to run if the condition is false. And in this case, if the condition is false, we'll run some other code. And that is, we will log to the console 2 is not bigger than 16.4. So console.log 2 is not bigger than 16.4. And then we end the else statement with the ending curly brace. And this is a complete if-else conditional block. So what does this code do? Well, if we run this code, we'll see that it logs to the console 2 is not bigger than 16.4. And that is what should happen, because the condition inside the if block is false. So 2 is bigger than 16.4, that's not true. It will return false, because 2 is not bigger than 16.4. And because the condition returns false, the first bit of code won't be executed. So the code inside the if block will not be executed. But the code inside the else block will be executed, because the else block only gets executed if the condition is false. So if the if block doesn't get executed, you can define some other default code to execute inside the else block. So you can almost read this code as if 2 is bigger than 16.4, then log to the console 2 is bigger than 16.4. Else log to the console 2 is not bigger than 16.4. It's very intuitive and easy to understand. And because the condition 2 is greater than 16.4 is false, the else block ran and we got logged to the console 2 is not bigger than 16.4. And that's how an if-else conditional works. Now let's see some more examples. So first we'll start with a variable, var n, which equal the number 1. So variable n equals 1. And now we'll define the if block. So if n is strictly equal to 53.8, then we will log to the console n is 53.8. Else, if that's not true, then we will log to the console n is something else. And then we end the code block. And the result is we get the string logged n is something else to the console. So how does this work? Well, variable n is actually equal to 1 because we've assigned the value 1 to variable n. Then we're defining the if block. Inside the if block, we're saying that n is strictly equal to 53.8. We're using the triple equal sign, which means strictly equal, which means the value must be the same and the data type must be the same as well. So although the data type is the same in this case, both are numbers, but the values are different. N is 1, and the other side we have 53.8. So the condition in this case returns false, and that's why the code inside the if block doesn't run. However, the code inside the else block will run, because the code inside the else block runs if the condition is false. In this case, the code console.log n is something else is what actually gets executed, and we get that logged to the console. However, if n was equal to 53.8, what would happen then? Well, then the if condition would return true, and if the condition is true, then the else block won't actually get executed. So it's either the if block or the else block. Both of them doesn't get executed at once. If the condition is true, the if block gets executed, otherwise it's the else block. And that's how conditionals work. Okay, so let's see some more examples. In this case, we'll have a variable called n, which equals an array with items 1 and 2. So n equals the array 1 and 2. So now we'll define the if block. And inside the if block, the condition will be n.includes 3. Now, if you remember from the previous videos and also the array module, the includes method is available to arrays that lets you check whether a value is actually present inside an array or not. So in this case, n.includes 3 will tell us whether the value 3 is present inside the n array or not. If it's present and is actually included inside the array, then the includes method will return true. Otherwise, it will return false. So if the value 3 is actually present inside the n array, then we're defining n.splice, n.index of 3, 1. Basically, we're finding the index of the value 3, and then we're removing it from the array using the splice method. So n.splice, the index of 3 and 1, which means we're removing one element, which is the index of the value 3. That's how we're removing the array item with the value 3 if it's present inside the array. But if it's not present, if the condition is false, then we were adding the value 3 into the array. So n.push 3. And then we're ending the conditional statement and the else block. And the result of n after the code is executed, as you can see, the n array now contains 1, 2, and 3. So we have 3 values, 1, 2, and 3. So how does this work? Well, first we define the variable n, which contains an array 1 and 2. So the array only has the values 1 and 2. And then we're defining the if condition. And the condition is n.includes 3. And this condition will return true if the value is actually present inside the array. But in this case, the n array only contains the values 1 and 2. 3 is not present. So n.includes 3 returns false, and the if block is not executed. But the else block is, and inside the else block, we do n.push 3. So we push the value 3 at the very end of the array. That's why now the n array contains the values 1, 2, and 3, because we added the value 3 at the end of the array using n.push inside the else block. However, if from the very start the n array contained 1, 2, and 3, what would happen then? Well, then n.includes 3 would return true, because 3 would indeed be included inside the n array. And that's why the code inside the if block will get executed. And inside the if block, we find the index of the element with the value 3, and then we splice it, meaning we remove it from the array. So if the array initially contained 1, 2, and 3, then after this code ran, the array would only contain the values 1 and 2. So this code ensures if the value 3 is present in the n array, then it's removed. Otherwise, if the value is not present, the value 3 is actually pushed inside the array. And that's how we can use if and else conditionals to accomplish these tasks. Let's take a look at a fun example. So in this case, we'll define a variable date, which equals a new date object. So as we've learned from the dates module, new date creates a new date object which contains the time when the code was executed. So in this case, the variable named date contains a new date object. Then we're defining another variable day, which equals date.getDay. So as we know again from the dates module, the getDay method will give us the day of a date object ranging from 0 to 6. So 0 means Sunday and 6 means Saturday. So in this case, date.getDay method will give us a number from 0 to 6 that will tell us what day of the week it is. And that will be contained within the variable named day. And now we're defining our conditional. And the conditional is if day is strictly equal to the number 0 or day is strictly equal to 6, then we'll run some code. So basically, this condition will return true if either day is 0 or if day is 6. Only one of them needs to be true, not both, because we're binding these two conditionals with a logical OR operator. So in this case, if day is 0 or if it's Sunday, or if day is 6, which is Saturday, then we'll run some code, which is we'll log to the console, it's the weekends. So console.log, it's the weekends. Else, meaning if the day is not 0 and the day is not 6, then we'll log to the console, weekends are in 6 minus day, days. So 6 minus day will tell us how many days are left until the weekends. And the value of that will be concatenated within the two strings in order to make weekends are in X number of days. And now we end the conditional. So how will this work? Actually, the output of this code will be different depending on the day it is executed. So in this case, let's assume that today is Tuesday. So var date equals new date. So the new date object will contain the current timestamp, which is Tuesday. And date.getDay would give us 2 because 2 is Tuesday. 0 is Sunday, 1 is Monday, and 2 is Tuesday. So if it's Tuesday, date.getDay would give us the number 2, and var day would equal 2. Then in the conditional, day is strictly equal to 0 or day is strictly equal to 6. Neither will be true because day equals 2. So day is strictly equals 0 will be false, and day is strictly equal to 6 will be false as well, which means the whole condition would return false, and the if block won't be executed. So the else block will, and inside the else block, we will say weekends are in 6 minus day. So 6 minus day, we know the day in this case contains 2, so 6 minus day means 4. And when the value 4 will be concatenated with the strings, the final output will be weekends are in 4 days. So in this case, depending on the day, we would either get weekends are in an X number of days, or if it is with a weekend, so if it's Saturday or Sunday, meaning if the day is equal to 0 or it's equal to 6, then we'll get logged it's the weekends. And that's how this code will work. Okay, so now let's revisit the discount campaign we built for an e-commerce store in the previous video. So in that video, we had a variable order total which contained the total value of the order. So in this case, we'll have the variable again, variable order total, and we'll set the value 19. So $19 is the total value of this order. Then we'll define the if conditional. So if order total is equal to or greater than 50, just like in the previous video, then order total minus equals 10, which means 10 will be minus from the order total and the new value will be assigned to the order total variable. And we'll log to the console, yay, you received a discount. This is what will be logged if the condition is true. But we can have an else clause and define what we'll do if the condition is not true. So in this case, we will log to the console, sorry, no discounts available. And then we'll end the else block. And now, when this code is executed, we get the string, sorry, no discounts available, logged to the console. So how does this work? So first, we have a variable named order total with the value 19. And then we define the condition in the if block. And the condition is that the order total variable must be greater than or equal to 50. And in this case, it's not greater than or equal to 50, it's 19. 19 is smaller than 50. It's not greater than 50, and it's definitely not 50 itself. So the condition inside the if block will return false, which means all the code in the if block won't be executed, and we'll skip to the else block. And the code inside the else block, which is sorry no discounts available, logged to the console, this is what will be executed, and that's why we get the message logged to the console. And that's how we can use the else block to define a fallback measure if the condition is not true. Okay, now let's talk about if else conditions. Now this is very fun because you can chain these conditions one after another and define multiple conditions and do different things based on different conditions. Let's see an example. So we'll start with a simple if block. So if 4 is less than 2, then we will log to the console 4 is smaller than 2. Now else if 3 is greater than 1, so we're typing in else and then another if conditional, and the condition is 3 is greater than 1. And if that's true, then we'll log to the console 3 is bigger than 1. And then finally we'll define the else block, which will execute console.log neither is true. And then we'll end the else block. So how does this work? So in this case, we're defining two different conditions and finally an else block to do something if neither of them are true. So the code starts executing from top to bottom. So at first, JavaScript encounters the if statement, and then it executes the conditional. 4 is less than 2. And as we all know, 4 is not less than 2. 4 is greater than 2. That's why this condition returns false. And thus the code inside the if block is not executed. So JavaScript moves on to the else if block. So else if 3 is greater than 1, which is indeed true, which means the code inside the else if block will be executed. So the second bit of code will be executed. That's why console.log 3 is bigger than 1 is what is actually executed, and this is the string that will be logged to the console. And finally we have the else block, which again is not executed because the second condition returned true. Only if the first and the second condition would return false, then we would fall back to the else block. And that's how the if else conditions work. Now do note that in JavaScript, the else if is not actually anything different. It's actually an else block chained together with another if block. So you're essentially typing in else and then you're chaining in another if and else block along with it. And you can chain these as many times as you want to define multiple conditions and do different things based on different conditions. And finally an else block to execute if none of them are true. And that's how you can use if else conditions to define multiple conditions and add more dynamic logic and behavior to your code. So let's see another example. In this case, we'll define a variable n, which equals to 32. And now we'll define the if block, and the condition is n is greater than 50. So if n is greater than 50, then we will log to the console n is bigger than 50. Else if n is less than 50, then we will log to the console n is smaller than 50. And if neither of them are true, else we will log none to the console. And then we end the conditional. So how does this work? Now if you execute this code, you'll see that the code inside the second block, which is n is smaller than 50, that's what's actually executed and logged to the console. So how does this work? Well, first we have a variable n, which equals to the value 32. Then we define the if conditional. And now the if condition is n is greater than 50. And this will return false because n is 32 and 32 is not greater than 50. 32 is smaller than 50. So n is greater than 50 would return false and the code inside the if block will not run. Then we will move on to the else if block. In the else if block, n is less than 50 is the condition, and this will return true because n is 32 and 32 is less than 50. So n is less than 50 returns true, which means the code inside this block will be executed, and that's why we get logged to the console n is smaller than 50. Then we have the else block, which again is not executed because we have the second condition return true, and that's why the else block is skipped. And that's how you can use else if to chain multiple conditions together. So you can almost read this code intuitively as if n is greater than 50, then log to the console n is bigger than 50. Else if n is smaller than 50, then log to the console n is smaller than 50. Else, just log to the console none. And that's how this code would read out in human form. In this case, we'll make it a bit different. So first, we'll have $10 discount applied if the order value is at least 50. This is what we had previously. But we'll define another condition in this case. In this case, we'll have a second condition, which is a $20 discount will be applied if the order value is at least 100. So if the order value is 100 or more, then a $20 discount will be applied, and if it's 50 or more, then a $10 discount will be applied. Otherwise, no discounts will be applied. So how will this work, and how will we translate this into JavaScript code? Let's see. So first, again, we'll have the variable order total, which equals the total order value. In this case, it's 199. So that is the total value of the order in this case. Then we'll start defining our conditions. So first, we'll start with if order total is greater than or equal to 100. So we're starting with 100 because that's the biggest. So in this case, order total must be equal to or greater than 100. And if that's true, then we will minus $20 from the order total variable. Else if order total is equal to $50 or more, then we will minus $10 from the order total. And finally, if none of them is true, then we'll log to the console no discounts. And then we end the statement. And now if we check the order total variable, the value is 179. So how does this work? Let's start from the top. So first we define the order total variable with the value 199. That's the value of the order total variable. Then JavaScript executes the if block. And in the if block, we have the condition order total is greater than or equal to 100. Now in this case, the order total is 199. And 199 is definitely greater than 100. So this condition is true. And that's why order total minus equals 20 is executed. And that's how we get the $20 discount for this order. So 199 minus 20 is 179. And that is what the value of order total is after this code is executed. Now the else if block doesn't need to run because the if block already returned true and that code is executed. So the else if block and the else block is skipped. Otherwise we would get an extra $10 discount, which shouldn't be the case. So the else if and the else blocks are skipped and only the if block is executed. That's why we get a $20 discount. And that's why the order total is currently 179. So the $20 discount has been applied. So because the order total was at least 100, we got a $20 discount. But if the order total value was at least $50, so for example $50 or anything between 50 and 100, then we would get a $10 discount. Otherwise, if it was less than $50, then we would just get a message log to the console that says no discounts. And that's how you can use if, else blocks for dynamic logic and conditions like this. Okay, so now let's improve our discount marketing campaign even further. So again, in this case, we'll have a discount if the order value exceeds a certain amount, but the discount will be more if the customer actually has an account with our store, and if it doesn't, the discount will be less. So in this case, we need to define two variables. Variable order total, which will contain the total value of the order. In this case, is $117. And then we'll define another variable has account, which will contain a boolean, either true or false. So in this case, we have two variables. Order total, which contains the total value of the order in numbers. And then another variable has account, which is either true or false, depending on whether the customer actually has an account or not. But again, in a real-life application, you would most likely be getting these values either from the server or from another application or script on the page. But in this case, we don't want to complicate things, so we'll just hard-code the different values in these variables. So we have a variable order total, which equals 117, and has account true, which means the customer indeed has the account. And now the marketing campaign. The marketing campaign will be that if the order value is at least 100 and the customer actually has an account, then we'll give a $20 discount. Otherwise, if the order value is at least 100, but if the customer does not have an account, then we'll only give $10 discount. Otherwise, no discounts will be applied. So how do we code this in JavaScript? Well, we'll start with the if block. So in this case, if order total is greater than or equal to 100 and has account, then we'll do something. What we'll do? We will minus $20 from the order total variable. Else, if order total is greater than or equal to 100 and does not have an account, then we only minus $10 from the order total variable. Else, if neither is true, then we just log to the console no discounts available. And then we end the statement. And now the order total variable contains the value 97. So how does this work? Well, first we have two variables, order total, which equals 117, and has account, which equals true. Inside the if condition, we have two different conditions binded together using the logical AND operator. So which means both of these conditions must return true in order for the whole condition to return true. Otherwise, if one of them returns false, the whole condition will be false. So the first condition is order total is greater than or equal to 100. In this case, it is true. Order total is equals 117, which is greater than 100. So the first condition returns true. And now we have the second condition. The second condition is has account. Now here's the cool thing. We actually don't need to say has account is strictly equal to true, because the has account is strictly equal to true is the same as has account. Because has account is a boolean, we can just define that, because if it's a boolean true, then it will be true. If it's false, then it will be false. So we don't need to define an actual condition in this case. We just need to type in the variable name, and that will be enough. So in this case, order total is greater than or equal to 100, which is true, and the second condition is has account, which equals to true. And because both of these conditions return true, the whole condition returns true because it's binded together with logical AND. And then the code inside the if block gets executed, and $20 has been minused from the order. So 117 minus 20 is 97, and that is the final value of the order total variable, and all the other code is skipped. But what if the has account variable would contain false, which means the customer does not have an account? What would happen then? Well, then the first if condition would return false, because had account would be false and the whole AND condition would be false. That's why the code won't be executed and JavaScript would move to the else if condition. And then again inside the else if condition would have order total greater than or equal to 100, which would be true, and then and not has account. So if has account was false, then the logical NOT would actually reverse this boolean value into true. So not has account would be true then, and then the whole condition would be true, and then $10 would be minus from the order. So if has account is true, then the first condition gets executed. If has account is false, then the second condition is executed. And otherwise, they will get logged to the console, no discounts available. And that's how this whole code will work. So just to recap, if the order total is equal to or more than 100, only then any discounts will be applied. Otherwise, we would skip to the else block and it will be logged no discounts available. Now, if the order value is equal to or more than 100, then we'll have to check for the has account. If the has account is true, then the first if block gets executed and we get $20 discount on our order. If has account is false, then the second bit of code gets executed and we get only $10 discount on our order. And otherwise, we get logged to the console, no discounts available. And that's how this code will work. Now let's talk about a very important concept in JavaScript, block-scoped variables. Now variables declared using the keyword var are not block-scoped. Now if you don't know blocks, blocks are any code that are within a pair of curly braces. So any code inside the if conditional is actually inside a block because the if conditional contains curly braces. So any code inside the pair of curly braces is code inside a block. Now in JavaScript, variables are not scoped to the block, which means variables declared outside the block is accessible inside the block, and even variables declared inside the block is accessible outside the block. So how does this work? So first let's define a variable x, which equals to 0. Then we'll define an if conditional, and inside the if conditional we have a code block, the pair of curly braces. The if condition is if 2 is less than 8, then console.log x. Now in this case, by x, we're referring to the variable x that we defined outside the block. So variable x equals 0, so console.log x would log 0, and x is available here. So although we are inside a code block, we can access variables defined outside the code block. So for example, variable x is defined outside the code block, but we can access it inside the code block. However, if we define a variable inside the code block, so for example variable y equals 1, which is defined inside the code block itself, then of course the variable is accessible inside the code block. So console.log y, which is referring to the y variable that we just created, is available. Y is available here. So console.log y would mean console.log 1. So 1 will be logged. And of course, because we defined the variable inside the code block, we can access it inside the code block. And then we end the if conditional. But the funny thing is, the y variable is actually accessible outside this code block as well. So console.log y still works outside the code block and it will log 1 to the console. And depending on the code, that is something you might not want. Sometimes you might want variables declared inside a code block to stay local and private to that code block, which means those variables should not be accessible outside the code block. But if you declare the variables using the keyword var, which we're doing in this case, the variables are not block scoped. The variables are actually function scoped. We'll learn more about functions later, But for now, just know that variables declared using the keyword var are not scoped to any particular code block. So even if we declare a variable inside a code block, as we're doing here, var y equals 1, that variable is actually accessible outside the code block as well. This is something you might not want depending on the code. And there are ways to solve this. How do you solve this? Well, thankfully, JavaScript provides other variable declarations which are actually block scoped. So what are they? These are variables declared using let and const. These variables are block scoped. So for example, if we have an if block, so if 2 is less than 8, then let y equals 1. So instead of using the var keyword to declare a variable, we're using the let keyword. And variables declared using var and let are almost exactly the same, except when it comes to scope. Variables declared using var are not scoped to the block, however variables declared using let are scoped to the block. So for example, if we define a variable let y equals 1, and also we'll define a constant, so const z equals 2, and we define both of these inside the code block, inside the if block. And of course, because we define these inside the code block, console.log y is available because this code is inside the block. So console.log y logs 1 correctly. Similarly, console.log z also logs 2 accurately. So because the variables are declared inside the block, they're accessible inside the block. However, if we close the block and then we try to access the variables, console.log y is the same thing, but then we get a reference error. Same with console.log z, we get a reference error. So how does this work? Well, if we declare these variables using var, they wouldn't be scoped to the block, which means they would be accessible inside the block and also outside the block. However, because we declared these variables using let and const, these are scoped to the block, which means they're local and private to the code block in which they're declared, and they're only accessible inside that code block. But outside that code block, they're not accessible. And because the variable y and constant z are defined inside the if code block, they're accessible inside the if code block. So console.log y and console.log z works inside the code block. However, outside that code block, when that code block is exited, all these variables are deleted, which means they're not available outside the code block. So console.log y and console.log z outside the code block returns a reference error because the variables declared inside the code block are not available. And that is what scoping means. Scoping means variables are local and private inside the scope it is declared. Variables declared using var are not block scoped, they're function scoped or they're properties of the global object. However, variables declared using let and const are block scoped, which means they'll be scoped inside the block in which they're declared, and they won't be accessible outside that block. Hello everybody, and welcome back to Expert.js. I'm Abrar, and I'm going to be your instructor for this video. In this video, we're going to be talking about the switch conditionals. Now, you already learned about if conditionals and else conditionals, but there are another type of conditionals available in JavaScript, and that is the switch conditionals. So let's see how they work. So we already know about if and else conditions in JavaScript. They can be used to define conditions and run different code based on which condition is true. However, we also have the switch statement. The switch statement works very similarly to the if and else statements. However, there are a bit of differences in the syntax and how it works. So let's see an example. So first we'll start with the variable n, which equal to 2. So variable n will equal to 2. Then we will start our switch block. Now inside the switch block, we first define the value we want to match with the cases. So in this case, switch, and inside the parentheses, we define the value. In this case, the value will be n. So this is what will be matched with different cases that we'll define in a second. So first we define switch, and then inside parentheses, we define the value to be matched. And then we start the switch block. Now we need to define different cases. Now the first case is case 1. Which means if n is equal to 1, then the code inside this case will be executed. Otherwise, it won't be executed. So case 1 means this code will be executed if n is equal to 1. And in this case, we will log to the console n is 1. And then we use the break keyword. The break keyword is used to break out of a switch conditional block, which means we're exiting the block if the condition is matched. Then we define our second condition. In this case, it's 2. So if n is equal to 2, then this code will run. In this case, we'll log to the console n is 2. And then again, we will define break. And then we define another case which equals 3, which means if n is equal to 3, then this code will run. In this case, we'll log to the console n is 3. And then we will break the statement. And finally, a default case, which means if none of these cases are matched, then we'll run this default code, which is console.log n is not 1, 2, or 3. And finally, we end the switch block. So how does this work? Well, first we define a variable n, and give it the value 2. Then we start the switch block, and inside the parentheses, we define the value to be matched. So this is the value that will be matched with every case. Then we define the different cases. And in the cases, we define what we want to match and what we want to execute if the match returns true. So case 1 means this code will run if n is strictly equal to 1. This match is done internally by JavaScript using the strict equality operator. So case 1 means if n is strictly equal to 1, then this code will run. Otherwise, if n is strictly equal to 2, then this code will run. And finally, if n is equal to 3, then that code will run. And if n is neither 1, 2, or 3, then the default code will run, which will log n is not 1, 2, or 3. And that's how the switch conditional blocks work. You can actually write this using if-else conditional. So in this case, the code would be more like if n is strictly equal to 1, then console.log n is 1. Else if n is strictly equal to 2, console.log n is 2. Else if n is strictly equal to 3, then console.log n is 3. Or else console.log n is not 1, 2, or 3. So it's the same thing, but we can make it shorter and simpler using the switch conditional. And the switch conditional can be used for other values as well. For example, strings. So in this case, we have a variable called food, which equals the string orange. Then we start the switch statement. And in the switch statement, we'll match the case values with the value of the variable food. And that's why we have food inside the parentheses. Now we define the different cases. So case apple. So here, this code will run if food is strictly equal to apple. In which case, we will log to the console, apples are red. And then we break the switch. And the second case is case mango. So if food is strictly equal to mango, then we will log to the console, mangoes are yellow. And then again, we will break it. And finally, if case is orange, so if food is strictly equal to orange, then we will log to the console, oranges are orange. And this is what's actually executed. And then we finally end the switch block. So how does this work? Well, variable food contains the string orange. And then when we start the switch statement with the variable food, then each of the case values are strictly matched with this variable. So case apple means food is strictly equal to apple. And if that's true, then the code will run. Case mango means food is strictly equal to mango. And if that's true, then that code will run. Or otherwise, if food is strictly equal to orange, then that code will run. Otherwise, none of these code will actually run. So in this case, case apple is not true because food is not strictly equal to apple. Similarly, case mango is not true as well, but case orange is true. And that's why that code is executed and we get logged to the console, oranges are orange. And that's the basic syntax of the switch statement. Now remember, inside a switch block, at the end of every case, we have a break statement, which is used to break out of a code block if a match is found. But what if we forget that break statement? The break statement is important because if you forget that break statement, the code will continue executing all the other cases regardless of whether the cases are true or not. So for example, if we have variable food which equals orange, and then we start the switch conditional with the variable food, then we define the first case, case apple, which equals console.log apples are red. And then we unfortunately forget the break statement. So instead of writing the break, we go on to the next case, case orange. And then we log to the console, oranges are orange. And then we again forget the break statement and move on to the case mango. And then we log console.log mangoes are yellow. And then we finally close the switch block. Because we don't have a break statement, whenever we find a match and the case is true, that code will be executed and all other cases after that will automatically be executed regardless of whether the case is true or not. So for example, variable food equals orange. So the first case we have is apple, which is false because food is not strictly equal to apple, which means the code won't be executed. However, in the second case, we have orange, and food is strictly equal to orange, which means that code console.log oranges are orange will be executed, and that is what will be logged to the console. However, because we don't have a break statement, we won't break out of the switch block, we won't exit the switch block, and the code for the other cases will continue executing regardless of whether they're matched or not. So case mango, which shouldn't be executed because food is not strictly equal to mango, right? But console.log mangoes are yellow is also executed. So we get two strings logged to the console. Oranges are orange and mangoes are yellow. And that is because we forgot the break statement. So if you forget the break statement, then whenever JavaScript finds a match, then the code will be executed and all other cases after that will automatically be executed regardless of whether they actually matched or not. And that's why you need the break statement if you only want the code inside the matched case to be executed. Otherwise, all other code after that matched case statement will also be executed. But do note that you don't need a break statement at the very end case, because after the end case you are automatically exiting the switch block, so you don't need to break it deliberately. So it's okay if you don't have the break statement and the last code block, but you should have the break statement at the end of other cases. Now what if inside the switch block we want the same code to be executed for multiple conditions? For that we can use a cool trick of the switch block. So first we'll define a variable animal which equal to the string cat. Then we start the switch block with animal. This is what will be matched with the different cases. Now we define the first case, case lion, which means if animal is strictly equal to lion, then we'll log to the console it's a lion. And then we break the statement. And then we have case cat, which means if animal is strictly equal to cat, then we'll run some code. However, we don't define any code yet. And then we move on to case bird, which means if animal is strictly equal to bird, then we log to the console it's a pet cat or a bird, and this is what actually executed. And then we break the statement. And finally we have a default which says console.log it's something else. And then we end the switch conditional. So how does this work? So in this case, if the animal is lion, then we'll get logged to the console it's a lion. However, if it's either cat or a bird, then we'll get logged the same code. It's a pet cat or a bird. So this code is executed if it's a cat or a bird, or otherwise the default code is executed. Now inside the case cat, we don't have any code. We don't have any break statement either, which means the code will fall through and continue executing the other cases until it encounters a break statement, which in this case it finds inside the case bird. So if the animal is a cat, then the code falls through the case bird and gets logged it's a pet cat or a bird. And then at the break statement, we break out of the switch block. So this code will be executed if it's either a cat or a bird. So for both of these conditions, we're executing the same code. And we're taking advantage of the fall through characteristic of the switch block in order to do this. Pretty cool, right? Hi there, and welcome back to another video of Expert.js. My name's Abrar, and I'm going to be your instructor for this video. In this video, we're going to be talking about functions. Now, understanding functions is essential for JavaScript because a lot of the JavaScript's more advanced and fundamental features are built around functions. So let's hop right into it. So first of all, what is a function? What do they do? And how do they work? Well, let's take a look at an example to clear out the confusion. So a function starts with a function declaration. We do that using the function keyword. So we type in function and then we type in the function name. In this case, the name can be any valid identifier. All the rules that apply to naming variables also apply to naming functions, which means it must be unique, it must start with a letter, and so on and so forth. And then we put in a pair of parentheses. These parentheses define the parameters. In this case, we don't have any parameters, so we just put in an empty pair of parentheses. And then the function block starts. So we start the curly braces, and inside the pair of curly braces is the function body. That's where we define the code of the function. In this case, the function body only contains one line of code, which is console.log hello there. And then we put in the ending pair of curly braces. Now this here is a function. This is called a function declaration. And by using this syntax, we have created a function named say hello. Now if you run this code like this, you'll see that no text is actually logged to the console. So although we have code that says console.log hello there, no hello there or any text for that matter has been logged to the console. So what's going on? The thing is, the code inside the function body is not immediately executed. So yes, while it's there, while we have typed it in, it's not executed immediately. So unlike other code in JavaScript, which is executed from top to bottom, left to right, the code inside the function body is not immediately executed. It is there, but is not immediately executed. It is only executed when that function is called or invoked. So in order to do that, we need to type in the function name followed by a pair of parentheses, like this. So if we type in the function name, say hello, and then the pair of parentheses, these pair of parentheses is what tells the JavaScript to invoke the function or call the function. Otherwise, run the code that's inside the function's body. So in this case, when you type in say hello and then a pair of parentheses, then the text hello there is logged to the console. So that's one of the features of functions. Functions allow you to define a code that's not executed immediately. It's executed later on when you call or invoke that function. Now the cool thing is, you can call in a same function as many times as you want, and the code inside the function's body will run exactly that many times, which means you can reuse code. That's one of the main features of functions. Functions allow you to define some common code that you can reuse over and over again. That'll help you avoid writing the same code over and over again, and it makes your code much more clean and manageable as well. You can think of functions kind of like variables. So just like variables are used to store values that you define once and then you can reuse it over and over again by referencing to the variable name, similarly for functions, you can define a piece of code once and then reuse it over and over again. So in this case, you can type in say hello and then parentheses as many times as you want, and we will get the text hello there logged to the console that many times. You don't have to manually type it in every time. You just define it in a function once and then you can reuse it over and over again, just like with variables. Functions can also be used to break up your code. So if your code is getting way too deep and complex, then you can break up certain portions of your code into different functions. We will learn more about the usage of functions later on. Now, if your function is the outermost function in your code, which means it's not nested within another function, then that function actually becomes a method of the global object. Inside the browser, the global object is the window object. So when you define a function such as say hello, it actually becomes a method of the window object. So you can also call it by typing in window.sayHello. And that also runs the code inside the function's body and logs the text to the console. Now the type of operator, when used on a function name, can tell you whether it is a function or not. If it is a function and it is defined, then the type of operator will return the string function. You can also use this to check whether a function is defined or not before actually calling it, because calling a function which is not defined or declared will throw in an error. So you can use a simple if conditional to check whether type of a function name equals to the string function. If it is, that means that function is there and is defined. Now we might be talking about functions starting in this module, but the truth is we've actually used functions all throughout this course at different times. For example, when we used a string method such as a string, then .to uppercase and then a pair of parentheses, then that to uppercase is actually a function. That function is defined in the string prototype, and when a function is defined as the property of an object, we usually call it a method. So the to uppercase method is actually a function that takes in a string and converts it into all uppercase letters. We've also used the parse float method. The parse float method can be used to convert a string into a floating point number. And as you can see, the parse float method is also actually a function. These are built-in functions. And of course, we've used console.log numerous times throughout this course. And if you look at it carefully, the log is actually a method of the console object. So .log is also a function. These are all built-in functions, which means you don't have to define them manually. When you execute JavaScript within a browser, these functions are automatically available as methods that allow you to do certain things. So you've actually been using functions this whole time. Now you can also create function objects. Now functions are actually objects, but the syntax we saw is the function literal syntax. But you can also use the new function syntax. So in this case, we first define a variable say hello, and then we create a new function object and assign it to the say hello variable. And we do that by typing in new function and then console.log hello there as a string as a parameter in the function method. And that creates a new function object. And now you can type in say hello and then a pair of parentheses in order to execute the method which logs the string hello there to the console. However, using this syntax is not recommended because this syntax is not very reliable and it's not the fastest either. So it's better to use the function literal syntax that we just saw. There's no need to use the new function syntax most of the time. Now let's talk about returning from a function. Returning from a function means stopping execution and returning the code from the function. So for example, let's create a function named hello. So we type in function to start the function declaration, then we type in hello and then the pair of parentheses, and then we start the pair of curly braces. And inside the function's body, we define console.log hi. So we log the string hi to the console. And then we type in the return. The return keyword can be used inside the function, which returns from a function, which means the function code will stop executing and it will return from the function when it reaches this statement. And then if we have something else after the return statement, for example console.log the string bye, then this is actually not executed. And we can prove that by finishing the function and actually calling it. So if we invoke the hello function by typing in hello and then the pair of parentheses, then you can see that it only logs the string hi. It doesn't log the string bye. And that's because we returned from the function before we even got a chance to log the text bye to the console. So whenever we have a return statement inside the function's body, the execution will stop there and the function will return, and any code after that won't actually run. Now just returning from a function without doing anything is not very useful. Oftentimes you'll actually be returning a value instead. For example, let's define the same function again. So function hello pair of parentheses and then the starting curly brace. And then we type in console.log hi. So we log the string hi to the console. And then we type in return and then a value. So the return statement can actually return a value if you want. In this case, we want to return the value, the string done. And then again, we type in console.log bye. And then we end the function. Now in this case, when we call the function hello and then the pair of parentheses, we get the string hi logged to the console. Now when we call this function by typing in hello and then the pair of parentheses, then we get the text hi logged to the console. And at the same time, the function returns the string done as a returning value. And this value is replaced with the function call. So hello and then the pair of parentheses is actually replaced with the string done. And you can prove that by assigning hello to a variable. So variable h equals hello and then the pair of parentheses, which logs the string hi to the console and it returns the string done as a value, which means h now should contain the string done. And now if we check the value of h, it is indeed equal to the string done. And that's how you can return a value within a function. Now let's talk about function parameters. Now oftentimes, a function might need to do something that requires a certain input. For example, so let's say we have a function called pounds to kg. So in our code, we might be doing a lot of pounds to kg conversions. So instead of manually doing it multiple times and writing the same code over and over again, it would be just better if we define that functionality within a function so we can call that function whenever needed and reuse the same code over and over again. So in this case, we have a function called pounds to kg, whose job is to take a value in pounds and convert it into kilograms. So how does this work? In this case, this function contains a parameter because we need the value, the number of pounds that need to be converted into kilograms, right? So in this case, we accept a parameter. So instead of an empty pair of parentheses, we typed in a parameter name. We can call the parameter anything we want, as long as it's a valid identifier. In this case, we're calling it pounds. And then we're returning a value. Instead of returning a static value, we are actually taking the value from the pounds parameter and then multiplying it by 0.453592. Now, if you check the conversion table, multiplying a number of pounds by 0.453592 will convert it into kilograms. So this is what we're returning in the code. And then we end the function declaration. And now we can use that function. So in this case, we can define a variable weight, which equals pounds to kg, and here we define the parameter. This is where we can pass a value to the function, and this value is 56. So we want to convert 56 pounds into kilograms. So in this case, we type in pounds to kg, and then inside the parentheses, we type in 56. So this is a value we're passing as an argument to the function. And this value is available inside the function in the parameter name we declared. So in this case, we want to convert 56 pounds to kilograms. And now, when this function is called, the value 56 is sent as an argument into this function. Now, this argument is named as pounds inside our function, and we're returning the pounds multiplied by 0.543592, which means whatever value we receive, we will multiply it by 0.453592, and this is the value that will be returned by the function. Now, the parameter name, pounds, is available as a local variable inside our function. And now the weight variable contains the number 25.401152. And this is what you get when you convert 56 pounds into kilograms. So 56 pounds equals to almost 25.4 kilograms. And this is how we can use the pounds to kg function in order to convert pounds into kilograms. So, just to recap, when we type in var weight, which equals pounds to kg 56, then this 56 value, which we are passing as an argument to this function, is available in the parameter name that we defined in the function declaration. So, in the first statement, we've defined this function parameter and given it a name pounds. And we can then use this pounds parameter as a local variable inside our function to do calculations and return a certain value. And this is how the pounds to kg function works. Now, a lot of built-in functions have parameters as well. For example, we talked about the pad start method in the string module. Now, the pad start method accepts a number as its parameter, and this number is used to define the final length of the string. So for example, violet.padStart10, which means the string violet needs to be converted to the length 10. And it'll pad the beginning of this string with empty spaces in order to achieve that. Similarly, we also have the slice method, which accepts two parameters. So, for example, apples are red is a string, and .slice 7, 10 gives us the string portion r. So it accepts two parameters. First one is where to start the slice, and the second is where to end it. And in this case, these two parameters are required to define the slice function. We also have the search function. For example, I love coding.search love will tell us where the search term occurs inside the string. So as you can see, for all these cases, the functions require parameters to do their job. Now, some methods, such as the toUpperCase method, doesn't require any necessary parameters. It can work without any parameters. But other methods, such as the slice and search method, require a parameter in order to do their job. And that depends what the function is doing. If the function is doing something that requires a value, that is often given using a parameter. So for example, for the search method, we need to define the value we want to search for, right? Because if we don't define the search term, what will JavaScript search for? So based on what the function is doing, sometimes parameters are necessary. Now, functions can also have multiple parameters. For example, let's recreate one of the built-in functions in our own custom way. So we're already familiar with the math.pow function. So the math.pow or POW function can be used to do exponential calculations. So for example, math.pow 3,3 gives us 27. The first parameter inside the pow method is the base. The second parameter is the exponent. So math.pow 3,3 means 3 to the third power, or 3 cubed, which equals 27. Now this is a built-in method, but we can recreate the functionality of this method on our own using custom functions. So for example, in this case, we'll declare a function called calcPower, which is used to calculate the power. And in this function, we'll define two parameters. So we accept two parameters, a base and an exponent. and we name them base and exponent respectively. So function, then calc power, and then base and exponent inside the parentheses. Then we start the function. And then we return base double asterisk or exponential operator and then the exponent. And this is the value that's returned from the function. And now we end the function declaration. Now we can use this function as the same way as the math.power method. So how does this work? Well, when we call the calc power method and we pass in two arguments, 3 and another 3 as parameters, then these values are sent and given the names base and exponent respectively. So when this code runs, the values that we passed during the function invocation, these are given the names base and exponent. And these values are available inside the function with the names base and exponent. And we're returning the value base, exponential operator, and then the exponent, which means the return value will be base raised to the exponent power. So in this case, calc power 3, 3 means 3 raised to the third power, which gives us 27. And calc power 3, 2 means 3 raised to the second power, or 3 squared, which means 9. Now what if we pass more arguments than we actually defined in the function? So for example, calc power 4, 1.5, 6. Now we only defined two parameters in the function declaration, base and exponent, which will be assigned the values 4 and 1.5 respectively. But what about 6? This value is discarded, so it doesn't affect the function at all. And the result is 4 raised to 1.5, which gives us 8. However, if we omit one of the parameters, so for example, calc power, then only 3, then we get a nan, not a number. Why is that? Because by passing in only one value as an argument, we only define the value for the base, but not for the exponent. So inside the function, when we return the value base double asterisk exponent, then the parameter base contains the value 3. But because we didn't pass a second value, the parameter exponent is undefined. And doing a mathematical operation with an undefined value gives us not a number. That's why if we omit one of the values, then we get nan. Now let's talk about the arguments object. Now inside the function, we have a special object called arguments, which looks kind of like an array. To explain this and explore this arguments object, let's define a function. We'll call it log params, so it logs parameters. So function log params, and then we'll accept two parameters, a and b. Then we start the function body. Then inside the function, we log to the console arguments, so console.log arguments. Now note that we didn't define arguments anywhere inside the function, but inside each function, the arguments object is available automatically. And this arguments object kind of looks like an array which contains all the parameters that we passed inside the function and also some other stuff. And because the arguments object is similar to an array, it also has a length property. So console.log arguments.length should give us the length of the arguments object. And then we end the function. Now let's call the function. So log params 4, 5. And that gives us the result, an array-like object 4, 5, and then some other stuff. And also the second log statement gives us the value 2. So as you can see, when we call the log params function with the arguments value 4 and 5, these values are automatically assigned inside the arguments object inside the function's body. So when the function calls in console.log arguments, this arguments object is logged to the console. And because we pass the values 4 and 5 as arguments, the arguments object contains the value 4 and 5 and some other stuff. And the length of this arguments object is the number of arguments we passed to the function. In this case, we passed two arguments, 4 and 5. That's why arguments.length gives us 2. Now the arguments object contains every argument passed when the function is called, even if that argument is not defined in the function declaration as a parameter. So for example, in the log params function, we only accept two parameters, a and b. However, if we type in log params 4, 5, another value such as 4, 5, 0, then the arguments object would contain 4, 5, 0, and the length of the arguments object would be 3. So even if we don't define parameters names for them, the arguments object contains all the arguments passed when that function is called. Now JavaScript also allows REST parameters, which allows you to accept an infinite number of parameters inside a function. And in this case, it looks something like this. So function log params, then you can define the named parameters. In this case, we'll have two named parameters, a and b, and then we'll have a REST parameter. And we declare the REST parameter by typing in 3 dots or period symbols and then the parameter name. In this case, the REST parameter name is args. So ... args, and this is the REST parameter. And then we start the function body. Inside the function body, we log to the console the REST parameter, in this case args. And we also log the arguments object just to compare the two. And then we end the function. Now if we call this function log params 1, 2, 3, 4, then the first value we get logged to the console is an array containing 3 and 4. And this is a value of the args parameter. So because we're typing in console.log args and we're getting a return value, an array 3, 4, which means the arg REST parameter must contain the value 3, 4. And this is what's exactly happening. So unlike other parameters, the args REST parameter contains all the arguments that we pass to the function call but are not explicitly named. So in the log params function, we defined and named two parameters, a and b. And when we type in log params 1, 2, 3, 4, then 1 is a and 2 is b. However, 3 and 4 doesn't have any specific name. And that's why these arguments as an array is available inside the REST parameter, inside args. And this is how the REST parameters work, which means the REST parameter for a function always contains all the extra argument values that are not named. So in this case, a inside the function is 1 and b inside the function is 2. However, we didn't define names for 3 and 4, but these are all covered inside the args parameter. And this is how REST parameters work. If you had log params 1, 2, 3, 4, 5, 6, and so on, then anything after the first two arguments would be contained inside the args parameter. And of course, we have the second value, which is console.log arguments. So we're also logging the arguments object to the console. And the result is an array-like object containing 1, 2, 3, 4, and then some other things. So the arguments object, unlike the REST parameter, contains all the values passed to the function as an argument. So when we call the log params function, we called in 1, 2, 3, and 4 as different argument values. And all of these are available in the arguments object. So the arguments object contains all the arguments, named and unnamed, defined and undefined, everything. However, the args REST parameter only contains the values that are not defined explicitly as parameter values inside the function. So inside the logs params declaration, we only defined a and b. However, any other values passed as an argument after the first two values, which are assigned a and b, all these will be available in the args REST parameter. Now you can also break up REST parameters. So remember in the previous example, we had a and b and then ... args. So the args was the name of the REST parameter. And this arg contains an array which contains all the extra arguments passed when the function is called. However, you can break it up into individual names as well. So for example, function log params a, b, ... and then an array c, d. And inside the function body, we log all the values a, b, c, and d. And then when we call this function log params with 4 values 1, 2, 3, and 4, then of course the first argument 1 is represented by the parameter name a inside the function. The second parameter 2 is represented by the parameter name b inside the function, and the arguments 3 and 4 are represented by the REST parameters, but we've broken up the REST parameter into the value names c and d. So c and d now contains 3 and 4. 3 is represented as c and 4 is represented as d. So console.log a, b, c, d gives us 1, 2, 3, 4. So this is how REST parameters work inside the functions. And this is how parameters work inside the function. If you have explicitly defined a list of parameters inside the function, then those will be available when the values are passed as an argument, and all other argument values that are passed that are not defined will be available in the REST parameter if you've defined it. And you can also break up the REST parameter to have individual values as different argument names. Now in JavaScript, there's a very important concept called function hoisting. Now you already might be familiar with variable hoisting. Variable hoisting means any variables that are declared are actually hoisted to the top automatically by JavaScript, which means you can reference them before they're even declared. The same thing works with functions. Whenever you declare a function, those functions are automatically hoisted to the very top of the code, which means you can actually refer to a function and call it before it's even declared. For example, we can have a variable weight, which equals pounds to kg 56. Now in this case, we didn't even define the pounds to kg function, right? So this should throw in an error because the pounds to kg function is not even declared. However, if we take in the value of weight, then we can see it's 25.401152, and that's because we've defined this function later on. So function pounds to kg, and then the pounds as a parameter value, and then we're returning pounds into 0.453592. And now, because we're declaring this function eventually, this whole function declaration is actually hoisted to the very top. So when we refer to that function, variable weight equals pounds to kg 56, then when that code is executed, this pounds to kg function is already actually available because this whole function declaration has been hoisted to the top. Which means you can actually refer and call the functions even before they're declared. So just because you're calling a function that hasn't been declared yet doesn't mean it'll throw an error. If you eventually declare the function later on in your code, and then that function will be hoisted to the top and the code should work correctly. So in this case, the whole function declaration, which means function pounds to kg and return value and everything, is hoisted to the very top of this code. And then when we declare variable weight and assign the value pounds to kg 56, then the pounds to kg function runs, and 56 is represented by the parameter named pounds inside the function, and the return value is pounds into 0.453592, which means 56 will be multiplied by 0.453592, and that's the value that will be returned. And now the weight variable contains the correct value, and we've converted 56 pounds into kilograms. Now in JavaScript, you can have recursive functions. Recursive functions are functions that call themselves inside their function body. So how does this work? So let's define a function called sayHello. So function sayHello, an empty pair of parentheses because we don't need any parameters, and then inside the function body, let's log the text hello there to the console. And now let's call this same function inside the function body. Now this might seem a bit crazy, but this is perfectly valid code. We're just calling the function itself inside the function's body. So we're defining the sayHello function, and at the end, we are actually calling the sayHello function itself. And then if we end the code, and then if we call this function by typing in sayHello and then the pair of parentheses, then the function code runs, which means we get console.log hello there, so it logs to the console hello there, and then the sayHello function runs again because that function call is inside the function, which means the sayHello function will run again, logging into the console hello there one more time, and then the sayHello function will run again, and this will continue on and on and on forever and ever and ever, and this runs infinitely. So if you run this code, it might actually crash your browser because it'll continue logging the string hello there forever for thousands of millions of times. So be careful with this kind of code, because with recursive functions, if you don't define a stopping point, then the function will call itself again and again and again, and it'll create an infinite loop of the same function being called and the same code being executed over and over again forever. Now, if you want to use recursive functions, then you need to define a stopping point. You need to break the loop at some point, and you can do that in a certain way. So for example, for this, we'll define the same function again, function sayHello, but this time we'll accept a parameter. We'll call it n. This is the value that will represent how many times the function have been called. And then we define a condition, and the condition is that if the value of this n parameter is equal to 10 or more than that, then it should return, which means the function should stop executing and it should return from anything and everything it's doing. And then we can go on with what we were doing, console.log hello there. And then when we call the function again, we type in n plus 1. So we're taking the variable that's available as n, and then we're adding 1 to that, which means every time the function is called recursively and the function loops itself over and over again, the value of n will change. And now we have to call the function giving n an initial value. So sayHello and then 0 inside parentheses means the n parameter has an initial value of 0, which means it'll start from 0 And then the if clause in this case returns false because n is not equal to or more than 10 right now, right? So the condition is false, and that means the return statement is not executed. So the string hello there is logged to the console, and then when we run the function again, say hello, this time we type in n plus 1. Now n in this case is 0, and so n plus 1 means 0 plus 1, which means 1. Now when the second time this function runs, the value of n in this case is 1. And now the whole conditional checking and text logging goes all over again, and the next time when we call the say hello function, n plus 1, which means 1 plus 1, which means 2, which means every time the function is called, the value of n increases by 1. And eventually, when the value of n reaches 0, then the conditional, if n is greater than or equal to 10, returns true. And that time, the return statement is executed and the function is stopped. Which means in this case, we get the string hello there logged to the console a finite number of times. In this case, only 10 times. And that's how you can run recursive functions a finite number of times. Hello everybody, and welcome back to Expert.js. I'm Abrar, and I'm going to be your instructor for this video. In this video, we're going to be talking about anonymous functions and function expressions. In the previous video, we learned the basics about functions, what they are, and how they work. But there's a lot more to it than that. So in this video, we're going to take a look at anonymous functions and function expressions, and much more. Okay, so let's start with anonymous functions. What is an anonymous function? Well, anonymous means something that doesn't have a name, and an anonymous function means exactly that. An anonymous function is a function that doesn't have a name. So usually in a function declaration, you type in the keyword function followed by the function name, and then any parentheses with optional parameters, and then the function body. But with an anonymous function, you don't have a name. So you write it kind of like this. So as you can see, you start with the function keyword, and then you just immediately type in the parentheses. Usually you type in function, then some name, for example ABC, and then the parentheses, and that ABC will be the name of the function. But with an anonymous function, you just type in function and then parentheses. And then you put in the curly braces and the function body. So inside the function body, we will type console.log hi. So we'll log the string hi to the console. And then we put in the ending pair of curly braces. Also note that we wrap this whole function inside a pair of parentheses. This is a basic anonymous function, a function that doesn't have a name. But wait, if this is an anonymous function, how do we call it, right? Because usually when calling or invoking a function, you type in the function name, such as ABC, and then the parentheses, and the parentheses actually executes the function. But in this case, we don't have a name for this function. So how do we execute it? Well, if you run this code, as usual, nothing will happen. That's because code inside the function's body, such as console.log hi, doesn't get immediately executed. It's only executed when that function is invoked. But in this case, this function doesn't have a name. It is an anonymous function. So how do we call it? And how do we make sure that this code is actually executed? Well, in this case, because the function declaration doesn't have a name, unfortunately, like this, you can't do that. So this is just an example of anonymous functions. You won't usually write it this way because using this, you can't really do much. Because this is a function declaration without a name. Because it's a function, the code inside the function doesn't get executed, and because it's an anonymous function, you can't call it. In order to call this anonymous function, you need to assign it to a variable. So let's see how that works. So in this case, you first type in a variable name. So for example, var say hello. And then that equals to a function. So previously we've seen variables contain strings, booleans, arrays, numbers, and so on. However, variables can also contain functions as values. Yes, so they not only contain strings and numbers and booleans and stuff like that, but they can also contain a whole function as a value. So here we're declaring a variable named say hello, and we're assigning it an anonymous function. In this case, again, we're typing in function and then the pair of parentheses. We're not typing in any function name. This is an anonymous function. And then inside the function's body, this is where we define the code, the function body code, which will be console.log hi. So we'll log the string hi to the console. And then we put in the ending pair of curly braces. So this is an anonymous function written as the value of a variable. And now, although the function itself doesn't have a name, it's an anonymous function after all, but because we assign it as a value to a variable, the variable can be used in the place of a function name. So in this case, we can actually type in say hello and then the pair of parentheses to execute the function, and then the code inside the function console.log hi actually gets executed, and we get the string hi logged to the console. So this works very similar to the function declaration, where you type in function, then say hello, then the pair of parentheses, and then function body. But in this case, instead of typing in function, say hello, then parentheses, we create a variable named say hello, and then assign it a value that's a function, an anonymous function. And that anonymous function contains the code we need to execute. And then the variable name can be used as the name to call that anonymous function. So say hello, and then the pair of parentheses to execute the function gives us the string hi logged to the console. This is also a way of creating functions, and creating functions this way is known as a function expression. So previously the method that we used was typing in function keyword, then the function name, such as function say hello, and then the pair of parentheses. That is known as a function declaration. And function expressions, which is creating a variable and then assigning it a function as a value, is known as a function expression. So the function that we just created here, say hello, is a function expression. We use the function expression syntax to create this function. And a function expression means creating a variable and then assigning it a function. Now, function expressions can also have named functions. So for example, like previously, we have a variable named say hello. So var say hello equals function hi and then parentheses. So here we're not using an anonymous function. We're declaring a variable and we're assigning it a named function. So just like we would function, then the function name, and then parentheses, that's what we're doing here. We're not using an anonymous function. We're using a named function. And then inside the function's body, we type in console.log hi. So we're logging the string hi to the console. Although you can have pretty much any type of code you want, you would just log into the console just to illustrate the point of these functions here. And then we close the curly braces and the function body block. And now, just like the previous example, you can use the say hello, the variable name, as a name for this function. Say hello parentheses executes the function and logs to the console hi. However, just because this function has a name doesn't mean that you can use it to call it or invoke it. So for example, hi and then pair of parentheses actually gives us a reference error, because this function, although it's named, you can't call it by that name. Because it's assigned to a variable, you must call it and invoke it by the name of the variable. Which means if you want to call this function, you must call it by that variable name, say hello and then parentheses. Just because the function has a name in its declaration, such as function hi parentheses, doesn't mean that you can call it by that name. That name won't work. So what's the use of naming functions in function expressions? Well, sometimes naming functions make it a bit easier to debug code and trace down where an error came from. But other than that, this is still a function expression, and the name of the function is say hello. That's what you should be calling it with. Now let's talk about a very interesting feature of JavaScript, IIFEs. These are known as immediately invocable function expressions, also known as self-executing anonymous functions. So in this case, we declare an anonymous function first. So we type in function, then parentheses, and then we start the function body. Inside the function body, we declare console.log hi, so log the string hi to the console. Then we put in the ending pair of curly braces, and then we wrap this whole function inside a pair of parentheses. So we put in the pair of parentheses, one at the start right before the function keyword, and another one right after the ending curly brace. And this is similar to the very first example of anonymous functions that we saw. We just type in function, then parentheses without any name. But previously we said that because this function doesn't have a name, you can't call it later on, And because it's a function, the code inside the function doesn't even get executed. So what's the point? The point is you can actually turn these anonymous functions into an IIFE, or immediately invocable function expression. These are known as self-executing anonymous function. So what you do is you want to execute this function automatically. So right after this function is declared, it gets executed. It's not executed later on. It's executed only once and immediately. And you do that by simply putting in a pair of parentheses at the very end. Okay, so in this case, because this function doesn't have a name, you can't call it later on. You also can't call it multiple times. So this is not very flexible, but it has a lot of uses, as you'll see later on. But for now, just know that in order to create a self-executing anonymous function, you declare the anonymous function and wrap it around in a pair of parentheses. That is the function declaration. And then in order to execute that function, you put in another pair of parentheses at the very end. That pair of parentheses is actually what executes the function. Because the function doesn't have a name, you use the whole function declaration to actually define the function and also execute it all at once. And that is how you use IIFEs. These are immediately invocable function expressions. This is an anonymous function that gets self-executed, which means that right after it is defined, it's executed. So if you run this code, unlike the very first example, we actually get the string hi logged to the console because this function is defined and it's immediately invoked at the same time, which means the code gets executed. However, because this function doesn't have a name, you can't call it or invoke it later on in your code like other functions. So usually with non-anonymous functions, you can define the function first and then you can call it later on in your code whenever you want multiple times. However,